Hey, how's it going everybody? In this video, I'm going to teach you everything you need to know to start coding with Java. This series even contains about 15 hands-on projects that we're going to code together. Our final project will be a functioning alarm clock that plays music of your choice. If you've never coded anything in your life, don't worry, we're going to start from the very beginning. I encourage you to sit back, relax, and enjoy the show. I don't like boring introductions, so we're just going to jump right in. To start coding with Java, you'll need two things: a Java development kit, also known as a JDK. A JDK contains a compiler. A compiler will compile your source code, your written code, into bytecode, which can run on a machine. You'll also need an integrated development environment, IDE. An IDE is a fancy term for a workspace in which we can write code, because sometimes Notepad just doesn't cut it. We'll get started by downloading a JDK, a Java Development Kit. Okay, here's how to download the JDK, the Java Development Kit. You can easily just Google or do a search for JDK download. We're going to use the one by Oracle, so we'll click on this link. I'll also post the link in the description of this video, if you would like to access it that way. We will download the latest JDK version. As of the filming of this video, we're on JDK 23. We're going to look for our operating system. I'm running Windows. I will download the 64-bit installer by clicking this link. Then we just have to wait for it to download. The download is complete. We're going to open this executable, select Next, Next. Our JDK has been successfully installed. We can close it. And that's all we got to do for the JDK. Now we need to install an IDE, an Integrated Development Environment. One I recommend is IntelliJ. You can easily just Google or do a search for IntelliJ download. We'll select the top link. Now, if you're not brought to this page, let's say you're at a different page, go to the top right where it says Get IntelliJ, click it, and you should be brought to a download page. This version is a 30-day trial, but if you scroll down, there is a free version. This is the Community Edition, because I don't like to pay for things. Select the correct download for your operating system. I'm running Windows. I will download the executable. Once the download is complete, we will open this executable for IntelliJ. Select Next. Choose a destination folder. I'll keep it as is. Click Next. You can create a desktop shortcut. I think I will just for convenience. Now this is important too. You can update the path variable. It basically tells your operating system where to find the executable files. This is useful if you're going to be running Java code from command prompt or terminal, but we won't be doing that in this series. You can always come back later and update this, but we'll just select Next and install. Alright, and we can finish. We might as well start IntelliJ right away. I'm going to check this checkbox to run IntelliJ, and finish. We should now be at a welcome screen for IntelliJ. We need to create a project. Select New Project. I'll name my project My First Project. Select the latest version of your JDK. I have JDK version 23. There is a checkbox, and it's most likely going to be checked, that says Add Sample Code. Just as a beginner, I recommend unchecking this. It'll auto-generate some sample code for us, but we're going to do that ourselves. I'll show you how. And then Create. Within our project folder, navigate to your source folder. It has a name of src. We need to create a main Java file. Go to the top toolbar, go to File, New, Java class. We'll name this class main. It's going to contain the main body of our code. Then select Class. Now the font is probably going to be really small. Here's how to change that. Go to the top toolbar, go to Settings, go to Editor, General, and you can check this checkbox for Change Font Size with Control plus mouse wheel. Apply. OK. Now you should be able to zoom in if you hold Control and scroll your mouse wheel. Now we can actually read something. In Java, in order to get some code to run, you need a main method. Within our class of main, there's a set of curly braces. We'll type the following: public static void main. Add a set of parentheses, then a set of curly braces. Within the set of parentheses, you're going to type the following: string, straight brackets, args. Like you're a pirate. You need this method in order for your program to run. Over the course of this series, we'll learn what each of these keywords means. But as a beginner, think of it as a magic spell that you have to say in order to get your program to run. To run your program, you're going to click this green arrow, or you can hold Shift plus F10. If we have written the main method successfully, we should have no errors. It says processed finished with execode 0. That means everything is running fine. If I were to delete this main method, we can't actually run the program. So be sure that that method is in. To output some text to the console window, we're going to type system with a capital S .out .print. Add a set of parentheses, then a semicolon. In Java, you'll end most of your statements with a semicolon. It's kind of like a period at the end of a sentence in the English language. Within the set of parentheses, we'll add a set of double quotes. Whatever we would like to output, we're going to type within the set of double quotes. Think of a food you like. I'll type, I like pizza. And then we can run this, and this should be the output. Again, I'm going to go to the green arrow, or you can hold Shift F10, and a console window should pop up that says, I like pizza, or whatever your favorite food is, whatever you typed here. Let's add another line of code. Again, type system.out.print. End it with a semicolon. Within quotes, what should we type? I like pizza. It's really good. Let's run it again. Alright, here's our output. I like pizza. It's really good. Now these are both on the same line. To move your output down to the next line, you can use println, meaning print line. Now it should look something like this. I like pizza. It's really good. If you type \n, that's an escape sequence for a new line. And that works too, besides print line. I like pizza. It's really good. Let's add another line of text. System.out.print, or print line. I like pizza. It's really good. Buy me pizza. And I'll add a new line character. I like pizza. It's really good. Buy me pizza. Or again, you could use print line. So, println for print line. And this will do the same thing. Now you can write a comment. Comments aren't displayed as output. To write a comment, you use 2 forward slashes, and the text should be grayed out. Comments are good as notes for yourself or for other developers. Let's add a comment that this is my first Java program. When we run this, this won't display as output. It's really just used as notes. We still have our output. It hasn't changed. You can even add a multi-line comment with a forward slash, then an asterisk. To end a multi-line comment, you need an asterisk, then a forward slash. I'll write, this is a multi-line comment. This won't output either. We don't see either of these comments. This is specific for IntelliJ, but you can change the console font and the colors. I kind of find this hard to read. To do that, we're going to go to the top menu. Under File, go to Settings. Under Color Scheme, go to Console Font. Here, you can change the font if you would like. Or the colors. I'll change the colors. I'll make the output bright green so it's easier to read. I'll go to Console, standard output, and select a new color. I'll select something green. Apply, and I think that looks pretty good. It's more readable that way. I'll also change the system output too. I'll make it kinda grayed out. That's pretty good. Yeah, and there's our output. I like pizza, it's really good, buy me pizza. Now a shortcut to type system.out.println, if you're using IntelliJ, is to type SOUT, then hit tab. That's going to auto-generate a println statement for you. I didn't realize this trick until a little bit later, so you don't always need to type out this statement. You can just auto-generate it. Alright everybody, and that is your first Java program. Your homework in the comments section is to post 3 println statements. Maybe type a poem or some song lyrics or something. And well everybody, that is your first Java program. Alright everybody, so we are moving on to variables in Java. Probably back in elementary school or middle school, you learned about variables. In algebra, a variable was a representation of a number. Well, in programming we have variables too. A variable is a reusable container for a value. A variable behaves as if it was the value it contains. But variables can contain more than just numbers. They can contain characters, and even entire words. There's different data types. A whole number would be an integer. A number that includes a decimal would be a double. There's 2 categories of variables we'll discuss: primitive and reference. Primitive variables are simple values, like numbers. They're stored directly in memory, usually in a location known as the stack. Reference variables actually hold memory addresses on the stack. They point to a location in a different area known as the heap. Think of it this way. If I give you a primitive variable, that would be the same as me handing you $10. But if I give you a reference variable, a memory address, that would be the same as me giving you an IOU that says I owe you $10, but the actual money I owe you is at the bank. That might be a beginner's way of thinking of the difference between a primitive and reference data type. Primitive, I'm giving you $10. A reference data type, I'm giving you an IOU that I owe you $10. We'll discuss the different data types. We'll begin with integers. An int, short for integer, is a primitive data type. I'll show you how we can create an integer variable. In Java, there's 2 steps to creating a variable. The first is declaration. The second is assignment. Let's say we would like to create a variable that stores a whole number, an integer. With the first step of declaration, we're going to first type the data type of what we would like to store exactly. So for integers, we will type int. Then we should think of a unique variable name. We don't want to say x or something similar. That would make sense in basic algebra. But in programming, you want your variables to be descriptive. Like, shut up. In programming, you want your variables to be descriptive. So let's say we are working with, let's say, int age. End this line with a semicolon. So this is declaration, step 1. We are creating a variable named age. If I was to print my variable of age, system.out.println, let's print age and see what it is. Variable age might not have been initialized. We're using a variable, but we've never given it a value. We've never completed step 2 of assignment. So we can set age equal to a value. So on my YouTube channel, the average age of my viewers is approximately 21 or so. So let's set age to be 21, and then we'll print it. So that outputs 21. If I were to change this to 30, then my variable age would behave as if it was the number 30. So those are integers, they're whole numbers. Let's say that I'm 30.5. Let's see what happens exactly. You can see that IntelliJ is already giving us a warning that we're working with a different data type known as doubles. So if I were to run this, we get an error message. We have incompatible types from double to int. If we declare a variable as an integer, they can only store whole integers. Let's think of a few more examples. Another example of an integer could be a year. So let's say the year is 2025. Then we'll print our year. 2025. Or maybe a quantity. Int quantity equals 1. Then we'll print our quantity. 1. So when working with quantities, they're whole numbers usually, right? We wouldn't have, let's say, half a product, 1.5. I would like 1.5 Nintendo Switches. That wouldn't make sense, right? They would be whole numbers, like 1 or 2. Now you can output a variable with a string of text as well. Let's say the year is, then I'll add plus a variable, year. Make sure that the variable is not within quotes. So currently this says, the year is 2025. You do have to pay attention to the spacing. So after the word is, I'm going to add a space to separate is and the variable year. The year is 2025. Now, if our variable was within quotes, we would literally be printing the word year. The year is year. So don't do that, unless it's intentional. Let's go on to the next data type. The next data type is double. Double is a number, but it can contain a decimal portion, unlike int. Ints are whole numbers. So this time, we will create a variable type of double. What are some examples of a variable that could be a double? Let's say a price. There could be dollars and cents. $19.99. Or perhaps a GPA, a grade point average. Double GPA equals 3.5. Or a temperature. Double temperature equals negative 12.5. All right, let's output some of these. Let's do price. System.out.println. Let's output the price. 19.99. Let's add a unit of currency. I'll pick American dollars. So $ plus price. $19.99. If you were to assign a variable that's a double data type, but store an integer, here's what would happen. We would just add 0.0 to the end. It's still a double. So those are doubles. They're numbers that can contain a decimal portion, unlike integers. Okay, then the next data type we have is char, meaning character. Char pronounced like the word Charizard. So with chars, what are a few examples of single characters we could use? Let's say a grade, like a letter grade. With chars, characters, we enclose them within single quotes. Let's say we have the letter A. That's the grade we got on the last test or something. Or maybe a symbol. Maybe I'll put an exclamation point or something. Or currency. Char currency equals, pick a unit of currency. I'll pick dollars. Okay, then let's output some of these. System.out.println. Let's print our grade, which is an A. Or our symbol, an exclamation point. Or our currency, which is American dollars. So then we have something called booleans. Booleans are either true or false. We will declare this variable as a boolean. Let's check to see if somebody is a student. Our variable name will be isStudent. And this equals true or false. So if I am a student, I would say true. Now, a common naming convention in Java is called camel case naming convention. If your variable name takes up two words, such as is and student, when you combine them, the first letter of the first word should be lowercase. Then any word after, the first letter is going to be uppercase. So, is student. And I will set that to be true. Maybe something is for sale or not. Boolean for sale equals false. It's not for sale. Is somebody online? Boolean is online. And I will set that to be true. These are a few examples of Boolean variables. Now you could output them directly using system.out.println. Let's test it. System.out.println. Let's output is student. Are we a student? That is true. Is something for sale? For sale. That is false. Now with Boolean variables, we don't typically output them directly to the console. We tend to use them more internally within a program. One place in which you might see them is with the use of if statements. And this is a future topic, we'll revisit it later, but I want to demonstrate the usefulness of Booleans. So this is an if statement. We can check some condition, parentheses, then curly braces. If our condition is true, if is student double equals true, but we could simplify this to if is student. If this variable contains true, which it does, we can execute some code. System.out.println, we will print the following. You are a student. If this Boolean variable contains true, we will print the following. You are a student. Or we could add else, an else clause. Else, let's print you are not a student. So currently, we're still a student. But if this Boolean variable contained a value of false, we would perform the else statement. You are not a student. So we'll cover if statements in a future topic. You don't necessarily need to know how these work right now. But that's one of the uses of Booleans. They can only contain true or false. These are a few of the basic primitive data types for beginners. Int for integers, they contain whole numbers. Doubles are numbers, but they can contain a decimal. Chars, meaning characters, are single characters. And Booleans, which are either true or false. These are a few of the beginner primitive data types. But there's still a lot more than this. There's floats, there's long doubles, all sorts of different data types, but you don't need to know those as a beginner. I would just stick to these four for now. So then we have the reference data types, a few of which include strings, arrays, and objects. In this topic, we're only going to discuss strings, a series of characters. Arrays and objects are really complex. We'll revisit these later. So we're going to create a string, a series of characters. So the data type is going to be string. An example of a series of characters could be a name. What's your name? With strings, we enclose them within double quotes. Chars, single characters, are single quotes. It's really easy to mix the two up. You might do it a few times as a beginner. So type in your name, including a space. I'll use my YouTube channel name. And then we will output our name, system.out.println. Print your name. And your first and last name should appear. Now we could use this variable of name within another string. This is known as string concatenation. So let's say hello plus our name. Hello, bro code, or whatever your name is. What are a few other examples of strings we could write? Let's add string food equals, again within a set of double quotes, add your favorite food. Mine is pizza. Then let's type again system.out.println. Your favorite food is plus the variable food. Your favorite food is pizza. What about an email? String email equals, make up an email, fake123@gmail.com. Strings, they can contain numbers, but we treat them more as characters rather than actual numbers that we can use for any sort of math or arithmetic. So let's print our email. Your email is plus email. Your email is fake123@gmail.com. Or what about a car? String car. Think of a car that you like. I will pick a Mustang. That's another example of a string. Or a color. String color equals red. So strings are a series of characters. They have a reference data type. You may have also noticed that the font color of strings is different from the primitive data types too of booleans, chars, doubles, and ints. At least within my workspace, the font color is orange. And with strings, the font color of these data types is white. Now we're going to cover a few exercises. So let's start with our name. System.out.println. We will print hello plus our name variable. It's a string. Hello, your first and last name. Let's print our age. System.out.println. You are. We're going to insert our variable age, then add another string literal. You are age, years old. Again, do pay attention to the spacing. You are 30 years old. Let's use my GPA. That's a double. System.out.println. Your GPA is, then we will insert our GPA. Your GPA is 3.5. Okay, let's use our char of grade. System.out.println. Your average letter grade is our variable grade. Your average letter grade is A. Now, within a single println statement, we're going to combine multiple variables. Let's say we're going to output our color, a year, and our car, all within one print statement. System.out.println. Let's say we're choosing a car. Your choice is a, we'll add our color variable, plus the year, plus our car. Let's see what happens exactly if we attempt this. So we've combined all three variables, red, 2025, and our car of Mustang. So we're going to add some space characters between each to separate them. So plus a space character, add that after the color, after the year. We'll add a space between color and year and car. So your choice is a red 2025 Mustang. Let's display the currency and a price. System.out.println. The price is plus currency. I picked American dollars plus price. The price is $19.99. For a car, let's up that. That's way too cheap. That's too good to be true. Let's say $19,999.99. That's more realistic. Now we're going to use this Boolean variable of for sale. If for sale, if this is true, then we're going to print there is a plus car plus the text of for sale. Else we will print something else. I'll just copy this. Let's say the plus car plus is not for sale. For sale currently, that's set to false. The Mustang is not for sale. But if this were true, there is a Mustang for sale. For sale is set to true. Alright everybody, so those are variables in Java. A variable is a reusable container for a value. A variable behaves as if it was the value that it contains. There's two different categories of variables, primitive and reference. Primitive data types are simple values, like integers, floats, single characters, and booleans. They're stored directly in memory, usually in a location known as the stack. Reference variables, such as strings, which are a series of characters, like your name, or an email, they're more complicated. We store a memory address that points to a location in the heap. And your homework assignment is in the comment section, post 5 variables: a string, an integer, a double, a char, and a boolean. And if you don't do your homework, you're going to make me sad. And well everybody, that is an introduction to variables in Java. Hello again friends, so today I'm going to show you how we can accept user input in Java. We will need the help of what is called a scanner. A scanner is an object that allows us to accept user input in Java. However, in order to use a scanner, we actually need to import it from the certain package called utilities, or util. At the top of our Java file, we're going to write the following statement: import java.util, this is a package, dot scanner. Scanner is a class. So make sure you have this import at the top before we get started. To sum up programming, we typically accept input, process it, then produce output. So that's why accepting user input is important. We would like to do something with the input. So to accept user input, we're going to create a scanner object. So type this: scanner, that's the name of the class. Scanner, that's going to be the name of the object we'll be working with. Do pay attention to the capitalization. Our scanner object is all lowercase characters, whereas in the first scanner, has an uppercase S. Scanner equals new scanner. Add a set of parentheses, then a semicolon. Within the set of parentheses, we're going to type system.in. Our scanner object can read user input. However, it is good practice if you create a scanner object. At the end of your program, when you're done, we're going to take our scanner object and use the close method. So scanner.close, parentheses, semicolon. If you don't close your scanner, it can lead to unexpected behavior. For example, let's say that we read a file. Well, after we're done reading the file, we'll want to close the file. When we open something, we typically want to close it. We're going to create a prompt within our console that says enter your name, then a user will be able to type in their name. We'll need a user prompt to work with. So let's say system.out.println, enter your name. After receiving this prompt, a user is going to be able to type in their name. We're going to use our scanner object, scanner.next line, parentheses, semicolon. So a user is going to be able to type in a string of text. So let's type in our full name, then hit enter. However, with this user input, we're not doing anything with it. So let's assign it to a variable. So with our line of scanner.nextLine, we will declare a variable and assign it. String name equals scanner.nextLine. We have declaration and assignment. Those two steps. And then once we have our name, let's output it. System.out.println, let's say hello plus name. So enter your name, type in your full name, hit enter, and the output should be hello, whatever your first and last name is. Now, if you prefer, we can put the input on the same line as the prompt. We're going to use print instead of print line. Print line will add a new line character to the end. So let's stick with print. So the input will be on the same line as the prompt, if you prefer it that way. So the next line method of our scanner object, it reads a string of characters, including any spaces. If you don't want any spaces, you can use next. So if I were to type in my full name, with the first and last name separated with the space, we only get the first name. Next doesn't read any spaces. So use what you would prefer. I typically just use next line. To read an integer, there's a different method called nextInt. This time, let's create a prompt of enter your age. I'll use print instead of print line. We will assign a variable of age. Int age equals, use our scanner object, use the built-in nextInt method. Then once we have our integer of age, let's output it. System.out.println, you are plus our variable age plus years old. Enter your name, type in your name, enter your age. Oops, I'm going to add a colon and a space after my prompt just because I think it'll look better. Okay, enter your full name, enter your age. Hello, your name, you are, whatever your age is, years old. So that's how to accept an integer. If you were to type in a floating point number or a double, anything that includes a decimal, now check this out. Our variable of age should be an integer. If we type in something that contains a decimal, like a floating point number or a double, let's say that I'm 25.9. Well, we get an error. Here it says we have an error at line 12, where we accept an integer. So if you need a double, there's a next double method of scanners. So this time, let's ask for a GPA. What is your GPA, your grade point average? We will assign a variable that's going to be of the double data type. Double GPA equals, again, use our scanner, use the next double method, and then let's output it. System.out.println, your GPA is plus our variable GPA. So again, let's go through the prompts. Type in your name, type in your age. What is your GPA? Let's use print instead of print line. Enter your name, enter your age. What is your GPA? Let's say my GPA is 2.1. I'm just barely passing. Hey, C's get degrees, right? Your GPA is the GPA variable. So that's how to accept a double. Use the next double method of scanners. Now, for some reason, if you need a Boolean, Booleans are either true or false. Here's how we can accept that. System.out.println, let's ask, are you a student? Then I'll add a prompt for true or false, so the user knows to type in one of these instead of yes or no. So we will create a Boolean variable of isStudent equals, use our scanner object, use the next Boolean method, and then let's output it. System.out.println, let's say student colon space plus isStudent. I think an if statement would be better. We'll cover that in a moment. Again, go through the prompts, type in your name, type in your age, type in a GPA. Are you a student, true or false? Let's say that's true. Student, true. And again, I'm going to use print instead of print line. Not necessary, but I think it looks better. Let's use an if statement instead when checking is student is true or not. So if is student, again, if statements will be a future lesson we'll cover pretty soon. If is student, if that's true, then we will print, let's print you are enrolled as a student. Else we will print something else. If that's not true, if it's false, you are not enrolled Okay, enter your name, enter your age, enter a GPA. Are you a student? Let's say that it's false. Okay, we have our name, our age, our GPA, and then we're outputting, you are not enrolled. You are not enrolled in classes, because we said false. Now, if we put true, well, then we get the output, you are enrolled as a student. That's how to accept user input of different data types, a few of which include strings, integers, doubles, and booleans. Now, there's one common issue when accepting an integer or double, then accepting a string. Let me demonstrate. So we have our scanner. Let's say we ask for a user's age. Enter your age. And I'll make this a print statement instead of print line. Int age equals, use our scanner, use the next int method. And then, let's ask what the user's favorite color is. Enter your favorite color. We will store that within a variable named color, and it's going to be of the string data type. String color equals, use our scanner object, use the next line method. Then we'll output the following. System.out.println, you are plus age, years old, as well as you like the color plus our variable color. Here's what happens. Enter your age, 25, hit enter. Enter your favorite color. You are 25 years old. You like the color. So what's going on here exactly? So when we type in a number, for example, 25, then hit enter, within the input buffer, there's still a new line character because we hit enter. So the next line method is picking up that new line character and using that as the input. So we need to get rid of that new line character. This is a common problem that you might see in Java. If you accept an integer or a double, then accept a string of text. So one way in which we can clear the input buffer to get rid of that new line character is after accepting an integer or a double, we can use our scanner and call the next line method, but don't assign it to anything. That should get rid of that new line character in the input buffer if that problem comes up. So let's try this again. Enter an age, enter a color. You are 25 years old. You like the color red. So if you encounter that problem, I would just call the next line method of your scanner object to clear the input buffer. Now we're going to cover an exercise. In this exercise, we're going to calculate the area of a rectangle. What I like to do when creating a project is declare all of my variables at the top. Again, make sure that you're importing the scanner class. I will create a double variable of width. I'll set that to be 0. And a double variable of height, also 0. And double area, I will set that to be 0. We're going to accept some user input and reassign width and height. So we need a scanner object to accept user input. Scanner equals new scanner, parentheses, semicolon. Within the parentheses, we will type system.in. And again, since we're opening a scanner, it's good practice to close it. I sometimes forget to do that. scanner.close. We'll create a prompt to tell the user to enter in a width. We can use system.out.println or print. For prompts, I like to use print. Enter the width. We will take our width. We've already declared our width once. We don't need to type the data type again. We can reuse it. Width equals, use our scanner object, use the next double method because we're accepting a double, a width. Let's do this with height. I'll just copy these two lines, then change width to height. Alright, let's test it currently. Let's make up some numbers, 3.1 and 4.2. Alright, once we have the width and the height, we have to calculate the area. So we're going to take our area variable equals our width times our height. And then let's output it. System.out.println, the area is plus our variable area. So let's say 3.2 and 4.3. The area is 13.76. Let's add a unit of measurement afterwards. After area, we'll add centimeters. You could do centimeters squared if you prefer, or you could even add a superscript of 2. So if you're on Windows, make sure numlock is on, hold Alt, then type 0178 on the numpad. If you would like a superscript of 2. You know, because we're working with areas. So let's say 5.3 and 6.4. The area is 33.92 centimeters squared. Alright everybody, that is how to accept user input in Java. You need to create a scanner object. Be sure to close it at the end of the program. If you don't, it might lead to unexpected behavior. The scanner object does have a few built-in methods for accepting strings, integers, doubles, and booleans. And well everybody, that is how to accept user input in Java. Alright everybody, so in this video we're going to create a game of Mad Libs. Mad Libs is a game where you have a story and a user fills in different words. The result is that it gives you a story that's really silly or doesn't necessarily make sense at times. But that's what we'll be doing in this video. It will help us practice accepting user input. Since we're accepting user input, we'll need to import the scanner class at the top of our Java file. Import java.util.scanner. A scanner is going to help us accept user input. We'll declare that and assign it. Scanner equals new scanner, parentheses, semicolon. Then within the parentheses, we will type system.in. When writing a program, I like to declare all of my variables first. All these variables are going to be of the string data type. We will need an adjective. You're going to get an English lesson today too. Adjective 1. An adjective describes something like fast, slow, cheap, expensive. We'll need a noun. String noun 1. A noun is a person, place, or thing. We'll need another adjective. Adjective 2. We'll need a verb. A verb is an action, like sleeping or running. Verb 1. Then another adjective. Again, an adjective describes something. Alright, so let's work on our story. We'll have 4 lines. So for the first line, we'll say, today I went to a... We'll insert an adjective, adjective 1. We're going to describe a zoo that we went to. We haven't asked for user input yet. We're getting a warning that this variable has not been initialized. That's okay. We'll take care of that soon. So today I went to a description, an adjective, zoo. In an exhibit, I saw a plus a noun. A noun is a person, place, or thing, like a gorilla or Harambe. Then we'll add some punctuation, a period. We'll say noun 1 was plus adjective 2 and our verb 1, then add some punctuation. So we could say that Harambe was big and sleeping. So a verb is an action. I was plus adjective 3. Then add some punctuation. Alright, now we just need to accept user input. So let's do that after assigning the variables. We'll need 5 print statements. We will prompt the user to enter an adjective. Enter an adjective. I'll give a hint that an adjective is a description. We're describing something. Enter a noun. Enter a noun. I'll give a hint that we are looking for a animal or person. We'll need another adjective. We can just copy this line. Then we need a verb. Enter a verb, and we want it in present tense. So ending with ing, like running. I'll give a hint that a verb is an action. And then another adjective. Alright, now we just need to assign these variables. We've already declared them. Adjective 1 equals take our scanner, use the next line method, and really we can just copy this line, paste it, and then change what we're assigning it to. We're accepting strings for each of these lines. We have adjective 1, noun 1, adjective 2, verb 1, and adjective 3. Alright, now the last thing that I'm forgetting, since we opened up a scanner, it is good practice to close it at the end of our file. If we don't, it can lead to unexpected behavior if we leave any open resources. Scanner.close. Alright, we are ready to run this. I'm going to prefix a new line character before displaying our story, just so that it's not so close to the prompts when outputting it. Enter an adjective, a description. I'm going to say suspicious. Enter a noun. So I like making fun of Mark Zuckerberg. I'm going to write the name of a person. Mark Zuckerberg. Enter an adjective. Smelly. Enter a verb ending with ing. Screaming. Enter an adjective. Happy. And here's our Mad Libs game. Today, I went to a suspicious zoo. In an exhibit, I saw a Mark Zuckerberg. Mark Zuckerberg was smelly and screaming. I was happy. So for your Mad Libs game, post your results in the comment section because I would like to read them. I want to see what you guys wrote. Or if you wrote a different story, post that too. And well, everybody, that is a simple Mad Libs game that we can write using Java. Alright everybody, so we got a really important topic to discuss today, although it can be a little dry, and that is the use of different arithmetic operators in Java. When it comes to programming, you gotta math sometimes. It's a pretty important topic. So let's start with some basic addition. In this demonstration, we will have 3 variables. X will equal 10, Y will equal 2, and Z will store the result. We'll declare it, but not yet assign it. So for basic addition, we'll store our result within Z. Z equals X for addition, you can use the plus sign, Y. What is 10 plus 2? Then we'll display it. we're storing the result within z, which gives us 12. Then we have subtraction. Z equals x minus y. 10 minus 2 is 8. Multiplication. For multiplication, we're going to use an asterisk. 10 times 2 is 20. For division, we use a forward slash. Z equals x divided by y. 10 divided by 2 is 5. There's also the modulus operator, which is a percent sign. That would give you the remainder of any division. Z is going to store the remainder this time. X modulus y. So modulus is a percent sign. 10 divides by 2 evenly, so the remainder is going to be 0. But if we divided 10 by 3, that doesn't divide evenly. 10 modulus 3 gives us a remainder of 1. The modulus operator is really useful if you need to determine if a number is even or not. Or when working with time, you need to see if something is divisible by 60 seconds or 60 minutes. We'll get more into that later, but you should at least know what the modulus operator is. Now we have something called augmented assignment operators. Instead of storing the result within z, this time we're going to reassign the result to variable x. So let's say we would like to add 10 and 3 together, but store it within x. Well, we could say x equals x plus y. This would technically work. So 10 plus 3 is 13. But there is a shortcut, though, that we could use, and that is by using augmented assignment operators. We'll condense some of these steps. Instead of saying x equals x plus y, we'll simply say x plus equals y, and that does the same thing. 10 plus 3 is 13. There's also subtraction. X equals x minus y. 10 minus 3 is 7, but we could condense it to be x minus equals y. That gives us 7. Or multiplication, x equals x times y. 10 times 3 is 30, but we can condense it to be x times equals y. That is also 30. For division, x equals x divided by y. That gives us 3. Now, one thing to pay attention to with division. Alright, so 10 divided by 3 should be 3.33 repeating, right? Well, we're using something called integer division. We're not able to store the decimal portion because we're working with whole integers. So that's something to pay attention to when you're using integer division. If we were working with doubles, then we would retain that decimal portion. So do pay attention to that. We'll discuss that in another video when it comes to typecasting. For the augmented assignment version, that would be x divided by equals y. And let's change that to be 2. So 10 divided by 2 is 5. Then we have the modulus operator. X equals x modulus y. 10 divides by 2 evenly. X will be 0. The augmented assignment version of this would be x modulus equals y. And that would also be 0. But if y were 3, then that would be 1. Now we have increment and decrement operators. You see this a lot with looping structures. Let's say that x equals 1 this time. Instead of saying x equals x plus 1, which would give us 2, or even the augmented assignment version, which would be x plus equals 1, well, there's even a shortcut for this if we're only incrementing by 1, and that is x plus plus. We're incrementing x by 1. You tend to see this in a lot of looping structures, but that's a topic for another day. Each time I increment x by 1, it's going to be retained. So now x equals 3. X plus plus, again, well now x is 4. Now there's also the decrement operator. x equals x minus 1. Of course, that's going to be 0 this time. So to decrement, you can use x minus minus. So now x is 0. Let's do it again. X minus minus. Now x is negative 1. X minus minus. X is negative 2. So those are the increment and decrement operators. You'll see these again when we reach the topic on loops. The last thing I need to discuss today is the order of operations, and there's an acronym, PEMDAS. It's parentheses, exponents, multiplication, division, addition, then subtraction, in that order. You may hear the phrase to remember this, please excuse my dear Aunt Sally, but I like the phrase, please excuse my dope-ass swag. That's my version that I like to use. Let's say we have the equation double result equals 3 plus 4 times parentheses 7 minus 5 divided by 2.0. I'm dividing by 2.0 because right now we're using integer division, which we previously talked about. So I'm going to use 2.0 so we retain that decimal portion. Again, that's a topic for another day. Let's display the result. So I don't know what the result is, but it is 7.0. In what order do we solve this equation exactly? Well, we can use that acronym of PEMDAS. From the left to the right, we solve anything within parentheses first. So going from the left to the right, we skip over any addition, multiplication. We're looking for parentheses, which we have right here. If you enclose part of an equation within parentheses, you would solve that first. 7 minus 5 is 2. There's no more parentheses. Then we check any exponents. There are no exponents. Multiplication. Well, we have multiplication right here. We would solve that next. 4 times 2 is 8. There's no more multiplication. Then we have division. We have 8 divided by 2, which gives us 4. Then any addition. 3 plus 4 is 7. And that was our original result. And then you would do any subtraction last. So that is the order of operations when it comes to arithmetic operators. Alright everybody, so that is some basic arithmetic and different operators you can use in Java. Hey everybody, so in this video we're going to create a shopping cart program. A user is going to be able to type in an item, set a price for each, and then ask for a quantity. The output is that it's going to give you a total, based on the price and how much you're buying. This would be a good exercise for us, to get us more comfortable with accepting user input. Alright, let's get started everybody. We'll need the help of a scanner. The scanner allows us to accept user input. We'll need to import that at the top, so be sure that you have this line of code. Import java.util.scanner. We'll create a scanner object. Scanner equals new scanner. Parentheses semicolon. Type system.in. Then if we open a scanner, it's good practice to close it when we're done with it. Scanner.close. If you leave resources open, it can lead to unexpected behavior. When creating a project, I like to declare all of my variables at the top. Let's say we have an item name. That data type is going to be a string item. What are we buying exactly? We need a price. That would be a double, because there might be dollars and cents. A quantity. How many of something are we buying? Int quantity. Pick a unit of currency. This could be a character. Char currency. I'm going to initialize this right away. American dollars. And then a total. We're going to multiply the price by the quantity to give a total. Double total. Now, if you would like, you can initialize some of these right away and assign them. For example, let's say we are at a pizza restaurant. I could set the item to be pizza right away. Or within this program, we could fill it in. Let's create some prompts. I'll use system.out.print. What item would you like to buy? Then let's accept user input. We're going to assign our string of item equal to use our scanner object and use the next line method. Then let's just print it to verify that it's working. What item would you like to buy? Maybe this time I'm buying a hamburger. That will output hamburger. We know that we can get user input, so let's delete this line. I was just testing it. Let's ask for a price. You could set an initial price if you would like, or we could ask for one, depending on how you want to write this program. So let's system.out.print. What is the price for each? If we're working with a price, a double, we'll use the next double method. We're going to assign our price equal to use our scanner dot next double. And then let's test it by outputting the price. Okay, let's say I'm buying a pizza this time. What is the price for each? $14.99. And that outputs $14.99. So it is a good idea every once in a while to test your code, just to be sure that it all works as you go along. Then we'll need a quantity. Let's ask, how many would you like? We will assign our quantity variable equals scanner.nextInt, since we're working with whole numbers this time. Then let's test our quantity to see if it works. I don't know, maybe I'm buying a hot dog this time. What is the price per each? $4.99. How many would you like? I would like 12 hot dogs. 12. And I'm just going to make sure I'm using print instead of print line, just because I think it looks better. Now we'll create a total. We don't need user input for that. We're going to use the variables that we've already had after assigning them. Total equals the price times the quantity. And then I will just test the total. Maybe I'm buying a pizza or pizzas. Each is $14.99. And I'm buying 3 of them. 44.97. Instead, let's output the following. I'm going to use a new line character, just to separate our output from the prompts. You have bought plus our variable of quantity plus a space character plus our variable item, but it might be more than one, so let's say /s. It might be pizza or pizzas. Then we will display the price, including the unit of currency. Your total is, I'll add our unit of currency. It's a character. I picked American dollars, but pick whatever you would like, plus our total that we have calculated. All right, let's see the result. What item would you like to buy? I would like to buy a pizza. What is the price for each? $14.99. How many would you like? I would like 8 pizzas. Maybe it's for a party. You have bought 8 pizzas. Your total is $119.92. All right, everybody, so that is a shopping cart program that you can write as an exercise using Java. Hello, everybody. Today we're going to discuss if statements in Java. An if statement performs a block of code if its condition is true. We've discussed how Boolean variables can be used within if statements. We may be a little familiar with them already. In this demonstration, we will have a variable of age. Set it equal to be some age. Age will be an integer. I would like to check if my variable of age is greater than or equal to 18. If so, we can print a message that you are an adult. To write an if statement, we'll type if, parentheses, curly braces. Within the set of curly braces, we can check a condition to see if it's true. So let's check to see if age is greater than or equal to 18. If that's true, we'll print the following. You are an adult. That would result in us outputting, you are an adult. Now, if this condition was false, if it's not true, let's say that my age is 12. Well, then we skip over the if statement. We check if this condition is true. If it is, we perform this code. If not, we skip it. Alternatively, we could add an else clause. This would be another statement. We would add else. If this is false, then do something else. So let's output the following. You are a child. Since the age is 12, we would output, you are a child. There's also an else if clause. So we have one of two possibilities. Do this or do that. Now we could add something called an else if clause. Let's check else if age is less than 0. If this statement is true, then let's say you haven't been born yet. Now we're doing one of three things. But it all depends on these conditions. Our else clause is kind of like the default if none of the above conditions are true. So let's test this. My age variable is set to 19. This would display, you are an adult. If my age variable was -1, we would display, you haven't been born yet. This statement was false, so we go down to the next one. This is true, -1 is less than 0, so we do this. Or if I was 10, well then these top two conditions are both false, so we do whatever's within the else statement. You can add as many else if clauses as you would like. So here's another one. Else if our variable age is equal to 0 exactly. Double equals is the comparison operator. We're checking if a variable or a value is equal to another value or variable. You don't want to use single equals because that's the assignment operator. Java thinks we're trying to assign a variable. When making a comparison, you use double equals. Is our variable age equal to 0? Then we'll print something else. Okay, we're going to print, you are a baby. I will set variable age to be 0. You are a baby, because our variable age is equal to 0 exactly. Let's add another else if statement. There's something I want to demonstrate. Let's check to see if age is greater than or equal to 65. Then we will print, you are a senior. I'll set age to be 70. Here's the result. You are an adult. So why did we print this statement rather than this one? Well, with these if statements, we check them from the top down. This condition is technically true, as well as this one. 70 is greater than or equal to 18. So we execute this code and skip over the rest, even though this one is also true. You do have to pay attention to the positioning of your if and else if statements. In this situation, it would be better if we were to check to see if somebody's age was greater than or equal to 65 first. So let's turn this into the if statement. And then where we check if age is greater than or equal to 18, we will use an else if clause instead. Now this should work. You are a senior, but if the age was 50, well then, you are an adult. Now we're going to modify this program slightly. This time, we will ask for user input. We'll need the help of a scanner. At the top of our Java file, we're going to import java.util.the class of scanner. we'll need to create a scanner object. Scanner equals new scanner. Within the set of parentheses, type system.in. Then when we open a scanner, it is a good idea to close it when we're done with it, just so we don't leave any resources open. With our variable of age, we're going to create a prompt to have a user enter in their age. I'm going to declare a variable of age, but we'll assign it later. Let's create a prompt. Enter your age. I'll use print instead of print line. And then we will assign age equal to scanner.nextInt. Okay, let's try this again. Enter your age. Let's say that I'm 21. You are an adult. What if I was 99? You are a senior. I am -1 years old. You haven't been born yet. I am 0 exactly. You are a baby. Or maybe I'm 10. You are a child. So with if statements, we check a condition. If it's true, we do it. We do this code. If not, we don't. Otherwise, we can check another condition with else if. And if none of these conditions are true, we can perform whatever's within an else statement. Else acts like the default code if none of the above conditions are true. Now this time, we're going to work with strings. We're going to create a variable of name, and it's going to be a string. We'll declare it, but not yet assign it. We will prompt the user to enter in their name. I will use print instead of print line. Enter your name. We will assign our variable of name equal to scanner.nextLine to get a line of text. This group of if, else if, and else statements, let's set this to be group 2. We're going to create another set. This will be group 1 for the name. When somebody enters in their name, they could skip the prompt, like this. Enter your name. I'm just going to hit enter to skip it. We will check if our name variable is empty. Here's how. If, we'll check if our name is empty. There's a string method for this. We haven't discussed string methods yet. Instead of saying name is equal to an empty space, there is a built-in method of strings, and that is to take our variable name, dot, is empty. This is another way to check to see if a string is empty. This will be our condition. Is empty will give you a boolean of true or false. So let's print the following if our name variable is empty. Let's say you didn't enter your name. Else, if our name is not empty, that means somebody typed in their name. Let's say hello plus name. And I'll add an exclamation point. Okay, let's try this again. Enter your name. If I hit enter, we'll perform then whatever's within the if statement. Then enter an age. You didn't enter your name. You are an adult. This time, let's type in our name, our first name. Hello, whatever your name is, you are an adult. This time we have two groups of if-else statements. Group 1 is for the name. Group 2 is for the user's age. This time, let's create a boolean. Boolean is student. Then we'll create a prompt. Let's ask, are you a student? But we need a value of true or false, because booleans can only be true or false normally. Is student equals, use our scanner to get some user input, next boolean. Now we'll create another group of if and else if statements. Group 3. We need an if statement. So with booleans, we could say is student is equal to true, but there is a way to simplify this, a shortcut. You can just say is student. it holds a direct value of true or false. We don't necessarily need to write like a whole condition. So if we're a student, we'll output, you are a student. Else, if isStudent is false, then we'll output, you are not a student. We have three groups of if-else statements. Group 3 is for isStudent. Group 2 is for the age. Group 1 is for the name. Just to make this more fun, I'm going to add some emojis. I think it would make it more interesting, but you don't have to. So if somebody doesn't enter their name, I'm going to add a pouting face. If somebody enters their name, I will add a smiley face. If somebody is a senior, maybe we can find an emoji for a grandpa. Let's find one for an adult. You haven't been born yet. We could do like a spirit or something. You are a baby. You are a child. You are a student. We could do a school. You are not a student. We could do an office. All right, so this is our final program. Again, we have three groups of if statements this time. One for the name, one for the age, and one for isStudent. And then for the prompt for are you a student, I'm going to use print instead of print line. Here's the result. Enter your name, enter your age. Are you a student? Hello, your name. You are an adult. You are not a student. Let's try some of the other statements. I'm not going to enter a name. For the age, let's say that I'm -1. Are you a student? True. You didn't enter your name. You haven't been born yet. You are a student. So those are if statements, everybody. They perform a block of code if its condition is true. Check a condition. If it's true, do this. If not, you can do something else. And well, everybody, that summarizes if statements in Java. Hey everybody, in this video I'm going to show you how we can work with the random class and generate some random numbers. Let's begin. To work with random numbers, we'll need to import the random class. At the top of our Java file, we will import java.util.random. Much like what we do with the scanner class. We're going to follow a similar pattern for creating a random object, much like a scanner object. We will type the name of the class, random, the name of the random object, random, equals new random. So random random equals new random. Let's say we have an integer variable of number. I'm going to assign our number variable equal to, and here's where we'll generate a random number. We will take our random object, then we will use the nextInt method. This will generate a random number. However, there's one issue with this. I'm going to print our number. The number is going to be very large. So the random number that's generated, it's going to be within a range between just about -2 billion and +2 billion. I'm guessing you don't want a number that big. So within the nextInteger method, we can set some bounds. If I would like a random number between 1 and 6, like I'm rolling a dice, or die, I would say 1, 6. This is actually going to give us a random number between 1 and 5. The first number is inclusive, the second number is exclusive. No matter how many times I re-roll this die, I'm never going to get 6. Since this number is exclusive, I'm going to increase this to be 7. That will give us 1 through 6. And there's 6. Let's say this time you would like 3 random numbers. You're rolling 3 dice. Let's say we have number 1, number 2, and number 3. All integers. we'll assign number 1 with a random integer. And we'll do this with numbers 2 and 3 as well. Number 1, number 2, number 3. Then we will print them. Number 1, number 2, number 3. 2, 4, 6. 2, 3, 4. 2, 2, 5. Good enough. For random numbers between 1 and 100, the second number is going to be 101 because it's exclusive. So now we're generating 3 random numbers between 1 and 100. Not only can you generate random numbers, you can generate random doubles. So let's set this back to be number. Let's change the data type in number to be double. We're going to use the next double method. This is going to generate a random number between 0 and 1. Just the decimal portion, really. You can also generate a Boolean. This might be good in a situation where you need to flip a coin. Let's say we have a Boolean of is heads. When we flip a coin, is it heads? Random.next Boolean. Then we will display if the coin we flip is heads or not. Is it heads or it's tails? That's true, it is heads. Now it's false. It's tails. We could even use an if statement. If is heads, if our coin flip is on heads, let's print heads. Else we will print tails. So this will simulate us flipping a coin. I'm getting a lot of tails. Alright everybody, that is how you can generate random numbers and use the random module in Java. Hey everybody, in this video we're going to cover some useful math-related constants and methods that you may be interested in as a beginner. Then at the end of this topic, we'll cover a few exercises. Let's begin. If at any time you need the value of pi, there's a built-in constant of the math class. So I'm going to print the following. Math, with a capital M, dot pi, all capital. So that would give you the value 3.14 and some change. So instead of creating a variable for pi, it's always available to you within the math class. You just have to access it. There's also E. Math.capital E. This is the exponential constant, also known as Euler's number. You may never use this, but it's available to you in case you do. So again, access the math class, dot the name of the constant. This time, let's create a double variable named result. Here's a few methods. I'm going to reassign result equal to access math dot. To raise a base to a given power, you can use the pow method. Let's raise 2 to the power of 3, then print it. Let's print our variable result. 2 to the power of 3 would be 8. And again, I'm using a double. That's why we have the decimal portion. 2 to the power of 4 would be 16. 2 to the power of 5 is 32. Pow, meaning power, you can raise a base to a given power. These can be values or variables. There's the absolute value method. Math.abs for absolute value. What's the absolute value of -5? That would be 5, positive 5. Basically speaking, the absolute value method gives you that number but positive if it's negative. Think of it as the distance away from 0, if that helps. For square root, there's a square root method. Result equals math.sqrt. What is the square root of 9? I did make a spelling mistake here. If you're accessing the math class, make sure it's with a capital M. So the square root of 9 would be 3. We can also round a number. Again, access the math class. Use the round method. Let's round 3.14. Round will round a number to the nearest whole integer. Again, we're working with a double, though, so that gives us 3.0. To always round up, there's the ceiling method. Math.ceil. Again, I accidentally used lowercase m. It's capital M. Let's round 3.14 up to the ceiling. So 3.14 rounded up is 4. To always round down, you can use the floor method. Math.floor. So this time, let's round 3.99 down. Normally it should round up, right? So 3.99 rounded down is 3. You can find the max between two values, or variables. Math.max method will have two numbers, which are comma separated, 10 and 20. What is the max between these two values or variables? The greater number is 20. There's also min. I'll just copy this because I'm lazy. Replace max with min. What is the minimum value between these two values? That would be 10. So those are a few useful math methods and constants that you may be interested in. We're going to cover some math-related exercises if you would like additional practice. In this first exercise, we're going to find the hypotenuse of a right triangle. You can follow this formula. C, the hypotenuse, equals the square root of a squared, one of the sides, plus b squared, the other side. We're going to accept some user input. We'll need a scanner. We need to import the scanner class. Import java.util.scanner. Then we'll create a scanner object. Scanner equals new scanner. Then place system.in within the set of parentheses. Then when we open a scanner, it is a good idea to close it, so we don't leave any resources open. Scanner.close. We'll prompt the user to enter in the length of side A and B. Let's declare those as variables. Double A, double B. We'll also declare double C. That will store the hypotenuse. Double C. We'll need two prompts. I will use print instead of print line. Enter the length of side A. Within side A, within our variable of A, we'll assign it to scanner.nextDouble. Let's do this with side B. We can copy these two lines, paste them, replace A with B. That is lowercase b. Let's do a test run just to be sure that these two work. Temporarily, I'm going to print A, then B. Enter the length of side A, 3, B will be 4. These work. I just wanted to test that. It is a good idea to test your code as you're writing it. Then we have to follow this equation. C equals math.square root of a squared plus b squared. There is a square root method within the math class, but we have to raise side A to the power of 2 plus b to the power of 2. Here's how we can do that. So within the square root method, we're going to raise a to the power of 2 first. Math.pow, to raise a base to a given power, raise a, comma, to the power of 2. Plus, again, math.pow, to raise a base to a given power, b to the power of 2. And that's it. So let's display whatever c is, the hypotenuse. The hypotenuse, I'll write that this is c, side c, is the following, plus c. If side A is 3, side B is 4, side C should be 5, which it is. If you would prefer, we can add a unit of measurement, such as centimeters or inches. So after side C, add cm for centimeters, or in for inches, whatever you prefer. So let's try that again. Side A will be 4, side B will be 5. And side C is this really long number. We haven't talked about the printf statement yet. Using printf, you can display a given amount of digits, but we do have centimeters at the end, which is what we were looking for. So let's try 3 and 4, and that gives us 5 centimeters. All right, let's cover another exercise. Given the radius of a circle or a sphere, we'll return the circumference, the area, then the volume. That's if we're working with the sphere, given the radius. So be sure that we're importing our scanner at the top, and we'll create a scanner object. Scanner equals new scanner, system.in, then be sure to close your scanner. Scanner.close. We'll prompt the user for a radius, because we need a radius to work with. We'll create a variable. It will be a double named radius. We'll declare it, but not yet assign it. We'll prompt the user using print instead of print line. Enter the radius. Then we will assign our radius variable. Radius equals scanner.nextDouble. Once we have a radius, we have to follow these formulas. So we need a circumference, area, and volume. Let's declare those at the top of our program, but assign them later. Double circumference. I think I spelled that right. Double area. Double volume. We will calculate the circumference. Here's the formula. 2 times, we need pi to work with. Instead of typing 3.14159, so on and so forth, we can access that from the math class, math.pi. Pi is always available to us. Then multiply this by the radius. Let's perform a test run. I will display the circumference. The circumference is plus our variable of circumference. Then I'll add a unit of measurement afterwards. Centimeters is good, or whatever you prefer. Enter the radius, I'll enter in 5. The circumference is 31.4 centimeters. In the future, using printf, we can limit the amount of digits that are displayed. I'll show you how to do that later on in this video. Then we need the area. Area equals, here's the formula. Again, we need pi. Pi is always available to us, math.pi, times our radius to the power of 2. So we need the power method of math. Math.pow, raise the radius to the power of 2. And I'll just copy this line because I'm lazy. The area is our variable area. Now, when working with an area, the unit of measurement is going to be squared. So we can raise it to the power of 2, or you can use superscript 2. If you're on Windows, make sure numlock is on. Hold Alt, then on the numpad, type 0178 for a superscript of 2, if you would like to use that instead. So now, what is the area? Enter the radius 5. The area is 78.53 centimeters squared. Then we have volume. If the radius is for a sphere, we're going to assign our variable volume, then follow this formula. 4 divided by 3 times pi times radius to the power of 3. 4 divided by 3. We should probably make these doubles. Times math.pi. And again, make sure the m is capital. Times our radius to the power of 3. Math.power method, raise our radius to the power of 3. Then display the volume. The volume is our variable volume, centimeters cubed. For a superscript of 3, make sure numlock is on, hold Alt, then type 0179. That's if you're on Windows. Alright, let's print the volume. Again, my radius is 5. Then we have the circumference, the area, and the volume. And the unit of measurement is centimeters cubed. Now, we haven't talked about the printf statement. We could display just a few digits. Here's how. Again, this is a future topic. Replace print line with printf. Instead of adding plus our variable name, we're going to add a placeholder, %f, to display a double. But if you would like one digit between the % and f, type 0.1. So let's do this with area and volume. Replace the plus with a comma. Then instead of adding plus centimeters, after our placeholder, add cm. Then centimeters squared, and centimeters cubed. Then we can get rid of the portion where we add the centimeters to the end. So let's say the radius is 5. Then we should add a new line character to the end of each of these. That looks much better. We're only displaying one digit after the decimal. Again, don't worry about this. This is a future topic, the printf statement. But if you would only like to display one digit, that's how you can do that. Again, we'll cover this later. Alright everybody, so those are a few math-related constants and methods that you may be interested in as a beginner. What's up everybody? In this video I'm going to discuss the printf statement in Java. Printf is a method used to format output. We already do have a little bit of experience using printf in the last few topics involving math. We'll get more in depth with the printf statement in this topic. Printf is an alternative to print and print line. Wherever we would like to insert a variable, we can add a placeholder of a %sign, then add one of a few characters, following it to format the output. In this demonstration, let's create a few variables. Let's create a string of name. I'll assign some name. I'll pick SpongeBob because many people know who SpongeBob is. We'll need a character. Let's say character first letter equals S. Int age equals 30. And a double. Double height equals 60.5. And a boolean. Boolean is employed. I will set that to be true. SpongeBob is employed at the Krusty Krab. So we have some variables. They're all different data types. We can insert them into printf statements when we output a string literal. Here's a demonstration. Instead of using print line, I'm going to use printf. We will display the following. Hello. Then I would like to insert this variable of name. We're going to use a %sign as a placeholder. %. Then we need a specifier character. What is the data type of the variable we're trying to insert? If you're trying to insert a string, you're going to use a lowercase s. So after this word of hello, we're adding a placeholder, then inserting a string at this location. So instead of adding plus the variable name, we're going to comma separate any variables we're inserting. So comma, name. Here's the output. Hello, our variable name, which contains SpongeBob. If we need to insert a character, that would be lowercase c. So let's use system.out.printf. I don't know, let's say your name starts with a. We're going to insert a variable. We need a placeholder, that %, lowercase c for a char variable, then comma separate any variables, comma our variable of first letter. So here's an important thing too. With the printf statement, we have to manually insert any new line characters. We'll end each printf statement with a new line character. So after our format specifier, we'll add \n to insert a new line. That's better. Otherwise, the output is going to be all on the same line. So that's how to insert a character. %c for chars. Then for an integer, we use d. So printf we're going to insert a variable. We use d for integers. Our variable age, years old. Then a new line character. Then we will insert our variable age. You are 30 years old. And in the middle is our variable of age. For a double, that would be f. System.out.printf. Add a placeholder, f for floating point number. Think of that as a double. Inches tall, or you can pick centimeters, up to you. Then we will insert our variable of height. You are 60.5, then a bunch of zeros, inches tall. We can limit the amount of digits that are displayed after the decimal. We'll have to set a precision, but I'll explain that later. Then a boolean. All we need is the letter b. System.out.printf. Let's say employed. Add a placeholder, b. Then a new line character. We will display our variable of isEmployed. Employed, then our variable of true. Now you can insert multiple variables within the same line. Here's how. We'll use system.out.printf. We're going to insert our variable of name, SpongeBob. For a string, the specifier character is going to be lowercase s for a string. So string SpongeBob is, we're inserting an integer. We need %d, years old. We'll comma separate all variables we're inserting. We have a string followed by an integer. So that would be name, comma age. We're inserting two variables this time. SpongeBob is 30 years old. So those are specifier characters. Add a %, a placeholder, then follow this placeholder with a specifier character, depending on what the data type is. S for strings, C for chars, D for integers, F for doubles or other floating point numbers, and B for booleans. It might take a little bit of time to remember these. Now we'll cover precision. With setting the precision, we can limit the amount of digits that display after a decimal. Let's create 3 different prices, and these will be of the double data type. Price 1 equals $9.99. Price 2, I'm just making up numbers here, 100.15. And double price 3 equals -$54.01. We're going to use printf to display these prices. System.out.printf. We're going to insert, we'll use that % placeholder, then use f to display a double, f for floating point number. comma, our variable of price 1. Then we'll do this with price 2 and price 3. Price 1, price 2, price 3. And here are the prices. Oh, and we have to add a new line character too, because they're all in the same line. I forgot to do that. So, \n, \n, \n. That's better. Naturally, when we're using printf to display a floating point number, such as a double, normally it displays 6 digits after the decimal point. But we would like to limit that. Here's how. We're going to set the precision to display 1 digit after the decimal between the percent sign and the f, type 0.1 to display 1 digit. So we have 10.0. This will automatically round to the output. So we have 10.0, 100.2, and 54.0. For 2 digits, that would be 0.2. 999, 100.15, and negative 54.01. Or we could do 3. 0.3f. Then we have 3 digits after the decimal. So that is precision. It's useful for displaying prices. Then we have flags next. Let's set the precision to be 0.2. Here's different flags that we can add. By adding a plus after the percent sign, we can output a plus for any positive numbers. Positive 999, positive 100.15, 54.01 is still negative. To display a plus before any positive numbers, just add a plus sign. Let's increase these prices. Let's add 3 zeros to the end of each. If you add the flag of a comma, it's a comma grouping separator for any thousandths place. After the percent sign, add a comma. At any thousandths place, we have a comma grouping separator. Again, this is useful for displaying prices. By adding a single left parentheses, any negative numbers are enclosed in a set of parentheses. So let's revert these prices back. After the percent sign, add a left parenthesis. So we only have one negative price, negative 54.01. And then we have a space character. This will display a minus if negative, space if positive. We have 2 positive numbers in 1 negative one. So by using a space character, any positive numbers are preceded with a space. 54.01 is negative, so we do not have that space. It's good for aligning numbers. The last specifier we have to talk about is width. We're going to create some ID numbers. These will be integers. Int ID1 equals 1. Int ID2 equals 23. Int ID3 equals 456. And int ID4 equals 7890. These integers have a varying number of digits. 1, 2, 3, 4. By setting the width, we can align them. Here's how. Again, we're going to use printf. We're displaying an integer, so we need %d. We will begin by displaying ID1. Then let's do this with 2, 3, and 4 as well. 2, 3, 4. And again, I am missing that new line character. New line, new line, new line, new line. That's better. So we have our 4 IDs. By adding a 0 after the percent sign, we can 0 pad some of these values. But Java is giving us a warning. By how many characters do we want to pad these numbers with 0? Let's say 4. We have one variable that has 4 digits. We'll set it to be 4 to be the maximum. So 0, 4. And here we are. These ID numbers are all now 0 padded. And they align vertically, which is kind of nice. So to add some 0 padding, follow our placeholder with 0, then the amount of digits to 0 pad, in this case 4. By setting a positive number, we can justify these variables. So let's replace 0 with just 4. Rather than having that 0 padding, we just have some spaces, if you would prefer it that way. Or with the negative number, we can left justify these values. So let's set 4 to be instead negative 4. Now these values are left justified, and we still have those spaces afterwards. Except for the last variable, because it's already 4 digits. Alright everybody, so that is the printf statement. It's a method used to format output. You add a placeholder, then one of a few characters afterwards. There's flags, width, precision, and specifier characters, depending on the data type of what you want to display. We'll have more practice with this in the future. And well everybody, that is printf in Java. Hey everybody, this video serves as a project. We're going to create a compound interest calculator using Java. If you put money in a bank account or the stock market, using the given formula, we can determine what our final amount is going to be plus interest after a given amount of time. This project serves as an exercise using Java. Let's begin. Alright, let's get started everybody. The first thing we'll need is a scanner. We'll need to import it at the top of our Java file. Import java.util.scanner. We need to create a scanner object. Again, scanner equals new scanner. Then within the set of parentheses, type system.in. When you open a scanner, it is good practice to close the scanner when you're done with it, so you don't leave any resources open. After creating our scanner, here are the different variables we'll need. Double principal. This will store the principal amount. What's our original investment? An interest rate. Double rate. An integer for times compounded. How often does our interest compound? Like yearly, quarterly, monthly. Then we need an amount of time, such as years. Int years. And the final amount. Double amount. Now we have to get some user input. We'll need some prompts. First we need the principal amount. I'll use system.out.print. Enter the principal. I never spell principal right. Enter the principal amount. We are working with a double, so we need the next double method of our scanner. Principal equals our scanner dot next double. Then we need the interest rate. This is going to be a double. System.out.print. Enter the interest rate. I'll add within our prompt that this is in a percentage form, like 5% or so. The number 5 instead of 0.05. So then we have our interest rate. So we need our scanner dot next double. So let's say somebody types in 5 for 5%. We would like the rate to be 0.05 rather than 5. After accepting the user input, let's divide that number by 100. Or let's say somebody types in 7. We don't want the rate to be 7, we want it to be 0.07. That's why we're dividing by 100. We'll fill in the times compounded variable. We're going to use print. Enter the number of times compounded per year. So this could be yearly, that would be 1, quarterly 4, or monthly would be 12. In most cases, it's probably going to be 1 for yearly. times compounded equals use our scanner dot next int, because we're accepting an integer. Then we need the amount of times our money is going to be invested. Enter the number of years. Then we need to assign our variable years. Years equals scanner dot next int, because we're working with an integer. Then we need to calculate the total amount. Here's the formula. Amount equals, we need our principal amount, times, access the math class, use the power method, raise 1 plus the interest rate, divided by the variable times compounded. So this is going to be the base. We comma separate the base and the power. We are raising this part of our equation to the power of times compounded times the number of years. And that's our formula. It's a little confusing, but it should work. Then we will display the amount. System.out.println, the amount after plus years plus is, pick a unit of currency, I'll pick American dollars, plus amount. Let's test this. So let's say we have $10,000 or so, and we're putting it in the bank. What is the interest rate? Maybe 3%. So I'm going to type 3. Enter the amount of times compounded per year. I'll go with 1. Enter the number of years, 1. So we should have 10,300 in our bank. Which we do. 10,300. If you would like, you can use a printf statement to format the output. So if you're familiar with that, let's replace println with printf. Instead of concatenating these variables, we'll add some placeholders instead. So to display an integer, we need %d within printf. Years is, then to display a double, we need %f. Then we'll list our arguments. Years, comma, amount. So to display two decimals within a double, between the % and the f, we're going to type 0.2 to display 2 digits after the decimal. We'll precede this placeholder with the unit of currency. Let's do American dollars. Okay, let's see the total amount. Enter the principal amount, $10,000. Enter the interest rate, 2%. Enter the number of times compounded per year. This time let's do quarterly, so 4, because there's 4 quarters in a year. Enter the number of years. Let's do 2, actually. And here's the amount in our bank account after 2 years. $10,407.07. Alright everybody, so that is a compound interest calculator you can write using Java. What is going on everybody? In this video I'm going to explain nested if statements in Java. In Java, it is possible to have if statements within other if statements. Kinda like this. After checking some condition, you could follow with another condition, if the first condition is true. You can add if statements, else if statements, and or else statements. It really depends on the program that you're trying to write. So what we're going to do in this demonstration is have 2 Boolean variables. A Boolean of is student. Let's say that we're selling movie tickets. If somebody's a student, they get a 10% discount on their movie ticket. We also have a senior discount. Boolean is senior. If somebody is 65 or older, they get a 20% senior discount. Or if they're a student and a senior, they get a combined total of 30% off their ticket price. Let's say we have a double of price. The price of a movie ticket will be $9.99, let's say. That's actually kind of cheap nowadays. We'll write an if statement to check to see if somebody is a student. If isStudent is equal to true, but since this is a Boolean variable, we don't need the equals true portion. We can just say if isStudent. I will go ahead and set this to be true right away. So if somebody is a student, they get a student discount. Else, they won't. So if isStudent is true, let's output the following. You get a student discount of 10%. Then we will take our price. Price equals price times 0.9. That will give you a 10% discount. You could shorten this using the augmented assignment operator. Price times equals 0.9. That will set the price to be 90%. Or a 10% discount, so to say. If somebody is not a student, they're going to pay full price. Price times equals 1. That really doesn't do anything, but it might help with this visualization. Then we'll output the following. The price of a ticket is, pick a unit of currency, then I'll add our price. Let's perform a test run. Currently we're a student. You get a discount of 10%. The price of a ticket is $8.99. To limit the amount of digits that display, let's use a printf statement. We'll use printf instead of printline. After the $sign, I will add a format specifier. We're going to display a double. We'll use f for a floating point number, comma price. To display 2 digits after the decimal, use 0.2. Now we can display a price. You get a student discount of 10%. The price of a ticket is $8.99. Now, if we weren't a student, I'll set this to be false. We don't get that discount. The price of a ticket is $9.99, what it was originally. Now, what if somebody is a senior and a student? Within our if statement, we'll write a nested if statement, as well as an else statement. If is senior, they get a student discount and a senior discount. Let's cut these 2 lines within the if statement and stick them within the nested else statement. If somebody is a senior and a student, you get a senior discount of 20% and a student discount of 10%. So let's take our original price times equals 0.7 and an additional 10% off the original. So let's say is senior is true for now. Okay, else, if they're not a student, but they are a senior, we'll check that with a nested if statement within the else statement. If is senior, they get that senior discount, but it's only 20% instead of 30%, because they're not also a student. Price times equals 0.8. You could add else. Price times equals 1. That's if somebody is not a student and not a senior. But you don't necessarily need this else statement. Alright, let's perform a test run. Let's say that we're not a student and not a senior. The price of a ticket is $9.99. What if we were a student, but not a senior? You get a student discount of 10%. The price of a ticket is $8.99. What if we're not a student, but we are a senior? You get a senior discount of 20%. The price of a ticket is $7.99. What if we're both a student and a senior? You get a senior discount of 20%. You get a student discount of 10%. The price of a ticket is $6.99. That's how nested if statements can be useful. You could check another condition after checking a condition already. So that's just one example of nested if statements. And well, everybody, those are nested if statements in Java. Hey, so today I'm going to show you a few useful string methods you may be interested in as a beginner using Java. In this demonstration, let's create a variable of name. The data type is going to be a string. Type in your full name, including a space. I'll just use my YouTube channel name. If at any time you need the length of a string, you can use the length method. I'll store that as an integer. Int length equals, to access these string methods, you need a string, or a variable that is a string, dot, then we have one of a few methods. If you need the length, you can use the length method. And then let's print it. Print the length. How many characters are in the string? 8. 1, 2, 3, 4, 5, 6, 7, 8. This could be useful. Let's say somebody is setting a password and you have a maximum size of 12 characters. Well, you can check the length to see if it's under 12 characters. So that is the length method. There's char at. That will give you the character at a specified index. We'll be given a single character. We'll store that as a variable. Char letter equals, take our string of name, use the char at method. Within the char at method, we'll list an index. 0 is the index of the first character, because computers like to start at 0. What is the character at index 0? Well, that letter is B. At index 1, that would be R, and 2 would be O. That is the char at method. It returns a character at a given index within a string. We also have the capability of finding a letter at a given index. Let's say we have a variable of index. Take our name, use the index of method, find the first occurrence of an O. So in my example, that should be 2. 0, 1, 2. That is the first index of this character, O. What about a space? Well, that would be 3. 0, 1, 2, 3. There's also last index. Last index equals, take our string of name, then use the last index of method. What is the last index of an O? Because index of gives you the first index. Last gives you, well, the last one. What is the last index of O? Where is it exactly? 5. 0, 1, 2, 3, 4, 5. We can take a string and make all the characters uppercase. I'll reassign that to our name variable. So we're going to take our name, use the toUppercase method, then print our name after reassigning it. Now all the letters are uppercase. There's also toLowercase. We'll replace upper with lower. And I should probably turn this into a comment. Now all the characters are lowercase. We can trim any white space before and after a string. Let's add a few spaces before and after. Then print the name. We can eliminate all this white space. We'll use the trim method for that. We'll reassign name equals name and use the trim method. Now all that white space is gone. We can replace a character with another one. Name equals name. We will replace one character with another. Let's replace any O's with A's. For your own name, feel free to change these. So what is my name now? Brocade. There are methods that return Boolean values. To check to see if a string is empty, you can use the isEmpty method. This would return a Boolean. To demonstrate, I'm going to put this within a print statement. So, my string is not empty. That's false. But if it was, it would return true. But I have to turn these lines into comments. That would return true. My name is empty. This could be useful within an if statement. If name dot isEmpty method. If our name is empty, we will print your name is empty. Else we will print hello plus name. Currently, my name is empty. Your name is empty. This method returns true. But if it wasn't, it would return false. Hello, whatever your name is. I'll use a multi-line comment just to comment all this out. We can check to see if our string contains a character. That would return a Boolean. Let's check to see if our name contains any spaces. If that's true, your name contains a space. Else, we'll print your name doesn't contain any spaces. So my name does contain a space. That would return true. Your name contains a space. If we're working with, let's say, a username, usernames typically don't contain spaces. Your name doesn't contain any spaces. There is a method to check to see if two strings are equal. Again, I'm going to use a multi-line comment just to comment this out. If our name equals... Using the equals method, we can check to see if two strings are equal, the given characters within them. Let's see if our name equals password. This actually would be more appropriate if we were working with a string named password. If our name, if the string of name, is equal to this string, if they have the same characters exactly, then we'll print your name can't be password. Else we will print hello plus name. I will set my name to be password. Your name can't be password. But if it wasn't, well then, this returns false. These two strings are not equal. And we execute the else statement. Hello, your name. Now, the equals method doesn't account for case sensitivity. So let's say our password has a capital P. Well then, this method returns false. Hello, password. To ignore case sensitivity, you can use equals ignore case. Then that would return true. Your name can't be password. Alright everybody, those are a few useful string methods you may be interested in as a beginner using Java. Alright everybody, in this video I'm going to explain how the substring method works in Java. Substring is a method that's used to extract a portion of a string. Strings have a built-in method of substring. Within the substring method, you can list one of two indices. This method will create a new string based on the positioning of the indices, the start and the end. I can best demonstrate this with us creating an email slicer program. So what we'll do in this demonstration is create a string of email. Type in your own email. I don't want to give you guys my actual email because some of you guys are weird, no offense. My email will be bro123@gmail.com. Our variable of email is a string. Strings have a built-in method of substring. We can create a new string from portions of the original string. Here's how. Let's say I would like the first 6 letters, but depending on your own email, it may be different. The substring method will return a new string. So let's create a new variable, the data type is string, of username, equals. To create a substring, we will take the original string, use the substring method, then list one of 2 possible indexes, or indices. The first index will be 0. At what position would we like this substring to end? I would like to end right before this @ sign. So that would be 0, 1, 2, 3, 4, 5, 6. The second index is exclusive. So we're creating a new string of username by using the substring method of our original string of email. Then let's print it to test it. We will display our username. And now we have a new string. Mine is bro123, but depending on what you wrote for your email, it may be different. Now I would like a new substring of every character after the @ sign. This will be a variable named domain. What is the domain of our email? Again, we're taking our original string, using the substring method, then list one of 2 possible indices. So again, let's count. This is index 0, because in programming we tend to start with 0. 1, 2, 3, 4, 5, 6, 7. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then we will display our domain. So my domain is gmail.com. Within your substring method, if you have a starting index, but you would like all the characters that come after all the way till the end, you don't necessarily need an ending index. We could just say 7. That would work too. gmail.com. There's one issue with how we wrote this program. What if somebody has a different length of an email? There's a greater or lesser number of characters. So let's say I have a different email. This program doesn't work as intended. It's not flexible. So my domain is 1@gmail.com. I could modify the indices of the substring method. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Then the domain would be 9, because I want everything after the @ sign. And then my username, let's check that. So this would be my username, brocode1. To make this program more flexible, instead of manually entering the indices, we can determine what this number should be with another string method. We're going to use the indexOf method in place of a number. We're going to find the @ character. Let's replace our second index with email, our string, dot, use the indexOf method. Then we will find the index of our @ character. We're going to replace this number with email.indexOf and find the @ sign. So now let's try printing our username. So here's my username. Then let's print the domain. Currently we have that @ sign. The indexOf method returns a number, which we're using as the index. It's returning the index of this @ sign. I'm going to increase it by 1, so we get everything after the @ sign. So +1. And now the @ sign is removed. Even better yet, let's accept some user input. We'll need a scanner. Import java.util.scanner. We'll create a scanner object. Scanner equals new scanner. Then we will need system.in. Then when we open a scanner, it is a good idea to close it when we're done with it. I sometimes forget. We'll create a prompt for a user to type in their email. Enter your email. I'll use print instead of print line. I'm going to declare my variables after our scanner. That's just how I like to arrange things. We'll declare our email, but not yet assign it. Same thing applies with our username and our domain. We've already declared these variables. We don't need to do that again. Instead of manually assigning our email, we're going to use our scanner to accept user input. Scanner.next line. Let's display our username and our domain. Okay, enter your email. I'll make up something. bro123@gmail.com. Here's my username and the domain. We can take this a step further too. We can check to see if our email is valid. We'll use some of the string methods we learned about in the last video. So after accepting our email, we're going to write an if statement. If our email contains the @ character, our email is only valid if we have this @ character. If it is, then we'll perform all this code. So let's cut it, then stick it within the if statement. Else we will do something else. Let's print emails must contain @. Let's type in an email that's not valid. I won't include the @ sign. Emails must contain the @ character. Let's try that again. Fake guy 1 at, maybe they're using Yahoo, yahoo.com. So my username would be fakeguy1, the domain is yahoo.com. Alright everybody, so that is the substring method and how to create an email slicer program. The substring method is used to extract a portion of a string. You can list one of two possible indices within the substring method, a starting index and an ending index. We used the substring method on an email, then created two new substrings, one of username and the other of domain. And well everybody, that is the substring method in Java. Hey everybody, in this video we're going to create a weight conversion program to convert a weight from pounds to kilograms or vice versa. It will help us become more familiar with if statements. So let's get started. Okay, let's get started everybody. What might be helpful to you as a beginner when creating a project is to use comments to describe what you want to do at each part of your program. This is also known as pseudocode. For example, the first thing we'll do is declare our variables. Declare variables. Then we'll create a welcome message. Then a prompt for user input. Prompt for user input or choice. We'll say option 1, convert LBS, meaning pounds, to KGS, kilograms. Option 2, convert KGS to LBS. If somebody doesn't select option 1 or 2, we'll use an else statement. Else print not a valid choice. So here's a rough outline of our program and what it's going to do. We'll begin at the top. We'll declare any variables that we'll need. So we will need a scanner. We'll create a scanner object. Scanner equals new scanner. Then type system.in within the set of parentheses. If you hover over the word scanner, you can import it automatically. Import java.util.scanner, or otherwise you can type it in. What are some other variables we'll need? Double weight for the original weight, double new weight, that's after we convert the weight, we'll need to store it, and int choice. A user is going to type in 1 to convert pounds to kilograms, or 2 to convert kilograms to pounds. We have our variables. Now we need a welcome message. I'll use a few print statements. Let's say weight conversion program. One colon space. This means option 1, convert LBS, meaning pounds, to KGS, kilograms. Or choice 2, 2 colon space, convert kilograms to pounds, LBS. Then we'll prompt for a user's choice. I'll use print instead of print line. Choose an option. Then we'll need to store that choice. Variable choice equals use our scanner to accept user input. We're accepting an integer. We'll use nextInt. Let's do a test run, and I will print our choice temporarily. Weight conversion program, 1 to convert pounds to kilograms, or 2 to convert kilograms to pounds. I'll type in 1, we get 1, or 2. Then we output 2. We can delete this print line statement. We were just checking to see if it works. Okay, option 1. If somebody selects option 1, we have to convert pounds to kilograms. Well, we'll need to check to see if choice is 1. We can use an if statement for that. If choice is equal to 1, be sure you use double equals, that is the comparison operator. We're checking if these two values are equal. If you use a single equals, that is the assignment operator, and Java thinks you're trying to assign 1 to choice. So double equals for comparisons. We're converting pounds to kilograms. We'll ask a user to enter the weight in LBS. I'll use print instead of print line. We will assign our weight equals use our scanner, then use the next double method, then we will accept a double value. So once we have our weight, we have to convert it to kilograms because it's currently in pounds. We will assign our new weight equal to the weight, our current weight that is, times 0.453592. Then we'll output the new weight. The new weight in KGS is, then we'll add our new weight. Okay, let's perform a test run. We'll type in 1 to convert pounds to kilograms, enter the weight in pounds. What's 150 pounds converted to kilograms? 68.0388. If you would like to limit the amount of digits that display after the decimal, you can use a printf statement instead of print line. So to do that, we'll convert this to printf. Where we would like to insert a value or variable, we'll use %. Since we're displaying a double, we'll use f, meaning floating point number. To display 2 digits after the decimal, we'll use 0.2, or 0.1 to display 1 digit, depending on your preference. Replace the plus with a comma. We're inserting this variable at this location, this placeholder. Let's perform that again. Choose an option, convert pounds to kilograms. Enter the weight in pounds. 150 is good. The new weight in kilograms is 68.04 kilograms. Now, if choice equals 2, we're going to convert kilograms to pounds. And really, we can just copy this if statement, paste it, then convert it. Else if choice equals 2, the user wants to convert kilograms to pounds. Enter the weight in kilograms. The new formula is going to be weight times 2.20462. The new weight in pounds, LBS, is our new weight. Let's try it. Choose an option. We will convert kilograms to pounds. I'm going to press 2. Enter the weight in kilograms. Let's say 68 kilograms. The new weight in pounds is 149.91 pounds. What if somebody types in a number that's not valid? So we can get rid of this comment, is use an else statement to print that the user didn't select a valid choice. We will follow this with an else statement. We will follow else if with an else statement. Else print that was not a valid choice. We have options 1 or 2. If I type in 3, We execute the else statement. That was not a valid choice. And again, like usual, I'm forgetting to close my scanner because I sometimes forget to do that. So at the end of your program, close your scanner. Scanner.close. Because you don't want to leave resources open. Okay, let's do one final test run. Let's convert pounds to kilograms. What's 200 pounds converted to kilograms? 90.72. Alright everybody, so that is a weight conversion program you can write using Java. Hey everybody, in this video I'm going to show you how we can use the ternary operator in Java. In Java, the ternary operator is a question mark, followed by one of two possible values. Here's the formula. We check a condition, then use a question mark, like we're asking a question. Is this condition true? If it is, we'll return a value. If not, we return something else, a different value. It's a simpler version to an if-else statement. Here's a demonstration. Let's say we have an integer of a score. Score will equal 70. That's technically passing. Using an if statement, I will check if my score is greater than or equal to 60. If it is, then we will print pass. Else, we will print fail. So this does work. With a score of 70, I have passed. If it were 55, well then, I fail. There's another way in which we can write this, and that is by using the ternary operator. What we're going to do, let's create a variable. A string variable of pass or fail. And we're basically just following this formula. We have our condition. Is our score greater than or equal to 60? Question mark. We're asking a question. Is this condition true? If it is, let's return a string of pass. Colon, think of it like otherwise, we'll return fail. And then I will print pass or fail to display it. So 55, that means we fail. But if it were 75, that means we pass. By using the ternary operator, it's an alternative to writing an if-else statement, and it can be simpler in many cases. Here's a few other examples. Let's create a variable of number. Set it equal to some number. Using the ternary operator, we will check if this number is even or odd. I'll create a string of even or odd equals our condition. We can check if a number is even or odd by using the modulus operator. We will take our number, modulus 2. The modulus operator gives you the remainder of any division. Does 3 divide by 2 evenly? If it does, that would equal 0. 3 doesn't divide by 2 evenly. There's a remainder of 1, and that does not equal 0. Is this number divisible by 2? We'll use the ternary operator. If it is, we'll return a string of even. Otherwise, we'll return a string of odd. Is my number even or odd? So 3 is odd. But if it were 4, well then, it's even. Here's a more practical example. Let's say we're working with a time in hours. This will be in military time. Hours equals 13. That would be the same as 1 p.m. I will create a string of time of day. Equals. We'll check if our hours is greater than or equal to 12. If it is, we'll return p.m. If not, we'll return a.m. Hours less than 12. Ternary operator. Is our hours less than 12? If it is, we'll return a.m. Otherwise, we'll return p.m. And then we will display the time of day. 13 hours, that's the same as 1 p.m. Yep, the time is 1 p.m. Or if the hours were 9, that would be a.m. Alright, last example. Let's say we have an income, or salary. Income equals $60,000. Let's pretend that you're a software engineer in the United States. In the United States, we have different tax brackets depending on your income. This time we will assign a variable of tax rate equals, we'll check if our income is greater than or equal to $40,000 for $40,000. Question mark, ternary operator. If that's true, then our tax rate is going to be 0.25. Otherwise, it will be 0.15. So with our income, what is the tax rate? 0.25. But if I changed it to 30,000, well, then our tax rate would be 0.15 for 15%. So that is the ternary operator. You follow this formula, you check a condition within a set of parentheses, then use the ternary operator, like you're asking a question. If this condition is true, return this. Otherwise, if it's false, return something else. And then if you would like, you can assign it to a variable. And well, everybody, that is the ternary operator in Java. Alright everybody, in this video we're going to create a temperature conversion program to convert from Celsius to Fahrenheit, or Fahrenheit to Celsius. This is a practice project to get us more familiar using the ternary operator. So let's get started. We will be accepting some user input, so let's get the scanner out of the way first. Scanner equals new scanner. We need a scanner to accept user input. Within the set of parentheses, type system.in. And then I will just automatically import this class. So at the top of your Java file, you need this import. Import java.util.scanner. Then when you open a scanner, it is a good idea to close it at the end of your file when you're done with it, because you don't want to leave resources open. We have our scanner to accept user input. Let's declare some variables. What will we need? We will need the original temperature. This will be of the double data type. Double temp. We'll need a new temperature. Let's say double new temp. That's after we convert it. And a unit. We could use char for the unit, the letter F or C, for Fahrenheit or Celsius. But just to keep it simple, I'm going to use a string, because there's a built-in method of to uppercase. We can take the input and make it uppercase automatically. Just to make it simple, we'll use a string rather than a char for the unit. Okay, now we just need to get the temperature. We'll need a prompt. I'll use print instead of print line. We will ask the user to enter the temperature. We will assign the temperature, temp equals scanner dot next double. Because we're accepting a value, we're assigning a variable of the double data type. Now we need the unit. Is it going to be Celsius or Fahrenheit? We'll need another prompt. I'll use print instead of print line. We will ask the user, convert to Celsius or Fahrenheit. C or F. Let's assign our unit variable, use our scanner, then use the next method to get the next character. We'll use the next method to get the next character. We don't necessarily need next line, we just want a single character. So check this out. I'm going to output our temp and our unit. What if somebody types in a lowercase c or f? So let's say the temperature is 75 degrees Fahrenheit, and we would like to convert it to Celsius. I'll type lowercase c rather than uppercase c. Our unit is currently a lowercase c. We can convert it to be uppercase. Following the next method of our scanner, where we assign our unit, we're going to do something called method chaining. We'll add another dot, then use the to uppercase method of strings. Let's try that again and see if it works. 75. I'll type in lowercase c, The toUpperCase method will take that lowercase c and make it uppercase, which is what we'll need in this next section. We can delete these two statements. Now we're going to use the ternary operator. How the ternary operator works is that we check a condition, followed by a question mark, like we're asking a question. We will return some code if that condition is true. Colon, meaning else. If it's false, we'll do some other code, or return some other value. We're going to follow this formula. So what is our condition? Let's check to see if our unit is equal to a c. Take our variable of unit, use the equals method, because strings have a built-in method of equals. Does our unit equal an uppercase C? Question mark. That's the ternary operator. We're asking a question. If this is true, that means we're trying to convert from Fahrenheit to Celsius. The formula to do that would be the following. We would be executing this code since it's true. Take our temp, subtract 32, then multiply 5 divided by 9. Now, what if our unit does not equal C? That means we're trying to convert to Fahrenheit. We'll need that colon for the next part of this section. Now here's the formula to convert from Celsius to Fahrenheit. This will be the false section of the ternary operator. Take our temp times 5 divided by 9 plus 32. With the ternary operator, how we've written this code is that we're going to be returning a double. After converting it, we need to do something with it, so we're going to assign it to a variable, our variable of new temp. Then we can do something with it. Once we have our new temperature, let's display it. I'll perform a test run. Let's print our new temp. Let's say it's 100 degrees Fahrenheit, and we're going to convert to Celsius. I'll type in C. Well, the temperature in Celsius is 37.7 repeating. We're going to format this in a moment. Let's add a degree symbol, plus a string. On Windows, to add a degree symbol, make sure numlock is on, hold Alt, then type 0176. Plus our unit we're converting to. Let's try that again. What is 100 degrees Fahrenheit converted to Celsius? 37.7 repeating degrees Celsius. To limit the amount of digits that display after the decimal, we can use a printf statement. Let's convert our print line for the new temp to be printf rather than print line. We'll add a placeholder. We're displaying a double, so we need f. To display one digit, type 0.1 between the percent sign and the f, comma, new temp. After our placeholder, we'll add our degree symbol. Again, I'm holding Alt, numlock is on, I'm typing 0176. Then we will display the unit. It's a string, %s for strings. We're inserting a new variable, we're going to comma separate them, then add our unit. And let me just close this gap. Let's see what the final product is. Let's convert 30.1, this will be in Celsius, to Fahrenheit. And the temperature in Fahrenheit is 48.7 degrees Fahrenheit. Okay, everybody, that is a temperature conversion program that you can write using the ternary operator in Java. Why, hello there. Today I gotta explain something called enhanced switches in Java. In Java, there's switches, and then there's enhanced switches. Enhanced switches are a Java 14 feature. I would recommend using enhanced switches over standard switches. So, what is a switch exactly? A switch is a replacement to using many else-if statements. Here's an example of us using a lot of else-if statements. In this sample program, we have a day of the week. I set mine to be Friday. With each of these if statements, I am checking to see if the day equals Monday, Tuesday, so on and so forth. Currently, my day is set to Friday. this would give me, it is a weekday. If I set the day to be Saturday, well then, it is the weekend. Or Sunday, let me show you the code. It is the weekend. Then I have an else statement, if none of the above conditions are true. For example, let's say day is pizza day, which doesn't exist, but it really should. Pizza day is not a day. This code does work, but it could be more efficient. We have a lot of redundancies. We're using a lot of else-if statements that all basically do the same thing. An improvement would be to use an enhanced switch. Let me demonstrate how to make that. So let's set our day to be Monday, for example. To create a switch, we will type switch, add a set of parentheses, then a set of curly braces. It's similar to an if statement already. Within the set of parentheses for the switch, we're going to examine a value or variable. We're going to examine our string of day. We will examine this value against any matching cases. The first case will be a string of Monday. If day is equal to this value, a string of Monday, we'll do something. We'll use an arrow. An arrow is the arrow operator. In Java, think of it as meaning do something, do this. If day equals Monday, do this code. So let's print something. Let's print it is a weekday. And then for fun, you don't have to, but I'm going to add an emoji. Nobody likes Mondays. Let's be honest. If day is Monday, do this code. Let's add another case. Let me zoom in a little. If case is Tuesday, arrow operator, meaning do this code, we'll print the same thing. It is a weekday. We'll do this with the other days too. I'll just copy this code, then repurpose it to save some time. Case Wednesday, it is a weekday. Case Thursday, it is a weekday. Case Friday, it is a weekday. Now, if it's Saturday, that means it's the weekend. Case Saturday, it is the weekend. Let's change the emoji. Case Sunday, it is the weekend. Let's perform a test run. If you're using IntelliJ, you may have these warnings. It's basically saying that these sections of code are unreachable. We're manually setting a variable. These sections of code are not going to execute. So I would just ignore that for now. So let's perform a test run. My day is Monday. Day is equal to the case of Monday, so we do this code. If it were Friday, case Friday, we do this code. If case were Saturday, well, we do this code. And Sunday. Case Sunday, so we do this code. It is the weekend. What if we have a day that doesn't exist, like pizza day? Well, we can add a default case. Here's how. We'll type the keyword default arrow, meaning do this. We'll print our variable day plus a string of is not a day. Pizza day is not a day. The default case, it behaves similarly to your else statement. If no above conditions are true, then we will do this. So what we'll do now is accept some user input using a scanner. We'll need to create a scanner object. Scanner equals new scanner. Within the set of parentheses, type system.in. And then I'm just going to automatically import this class at the top of my Java file. Import java.util.scanner. We'll create a prompt for a user to type in the day. Enter the day of the week. And I will use print instead of print line. Instead of manually assigning a variable, we'll use our scanner. scanner.nextLine to accept a string. Okay, let's try this again. Enter the day of the week. It is Tuesday. It is a weekday. Let's try that again. Enter the day of the week. It is Saturday. It is the weekend. And let's make up a day. Let's go with Taco Day. Taco Day is not a day. We could actually improve the switch even further. IntelliJ is saying we have a duplicate branch in our switch. We have 2 or more cases that are doing the same thing. We are outputting, it is a weekday. We could consolidate some of these cases. Here's how. The cases of Monday, Tuesday, Wednesday, Thursday, and Friday, they all output the same thing. So we're going to consolidate them. I'll copy one of these print statements and delete all of them. We can comma separate these cases. So case Monday, comma, Tuesday, comma, Wednesday, comma, Thursday, comma, Friday, then arrow. If our case is Monday, Tuesday, Wednesday, Thursday, or Friday, then do the following. We'll print, it is a weekday. Now, Saturday and Sunday do the same thing too. Let's cut one of these lines and delete them. Case Saturday, comma, Sunday, arrow, meaning do this. It is the weekend. Then we'll keep our default case, in case there are no matches. Let's try this again. Enter the day of the week. It is Wednesday. It is a weekday. It is Saturday. It is the weekend. It is Sunday. It is the weekend. Then let's go with Hamburger Day. Hamburger Day is not a day. So those are enhanced switches. They're a replacement to using many else-if statements. If you find yourself using a lot of else-if statements, I would recommend using a switch instead. But not just any switch, an enhanced switch, which is a Java 14 feature that you should know about. And well, everybody, those are enhanced switches in Java. What is going on, everybody? In this video, we're going to create a simple calculator program using what we've learned with enhanced switches. This is meant to be more of a practice project. Let's get started. The first thing we'll need is a scanner. We will create a scanner object. Scanner equals new scanner. Within the set of parentheses, type system.in. And then when you open a scanner, it is a good idea to close it when you're done with it. Scanner.close. Then be sure to import the class. At the top of your Java file, make sure you have this import. Import java.util.scanner. What are the different variables we'll need? A user is going to type in 2 numbers and an operator, such as a plus for addition, minus for subtraction, so on and so forth. The first variable will be of the double data type. Double num1. Double num2. Then an operator. This will be a char. Char operator. And a result. Double result. There's going to be one more variable, but we'll fill that in later. So we'll stick with these 4 for now. We'll prompt a user to type in the first number, followed by an operator, then the second number. Here's how we can write that. Let's ask the user to enter the first number. And I will use print instead of print line. We will assign num1 equal to, use our scanner to get user input, next double. Then we need the operator. We will use a print statement. Enter an operator. We'll have plus for addition, minus for subtraction, an asterisk for multiplication, a forward slash for division. Let's add one more. Let's add a caret. This will raise a base to a given power. Feel free to add more if you would like, but we'll just stick with these 5. A user is going to enter in a character, one of these operators. Hopefully. We will assign our variable of operator equal to scanner.next. The next method will give you a string. We can method chain the char_at method to return a single character. When a user types in something, just give me the first character. This will also convert it to be a character, rather than keep it a string. So ideally, our operator is going to be a plus, a minus, an asterisk, a forward slash, or a caret. Then we need num2. We can just copy these 2 lines, paste them, change first to be second, and num1 to be num2. We have our 2 numbers and our operator. We have to determine what the operator is. We can use an enhanced switch for that. We will create a switch. Within the set of parentheses, we are examining our operator. We're examining our operator against any matching cases. The first case will be a plus sign, and these cases are going to be within single quotes, not double quotes, because we're working with a character, not a string. With our switch, if our operator is a plus character, we're going to write an arrow, meaning do this. We will take our variable of result, set it equal to be num1, that's the first number, plus num2. That will be the case for addition. Then we have subtraction. Case minus, arrow, do this. Assign our result equal to num1 minus num2. Multiplication would be case, a character of asterisk, arrow, take our result, equals num1 times num2. Now for division. We have a forward slash, arrow, take our result, equals num1 divided by num2. Now with division, if somebody divides by 0, we'll return to this case later and make it a little more sophisticated where we check to see if num2 is 0. I would like for us to get a solid foundation first for this program. So if somebody would like to raise a base to a given power, we will use the caret. We will assign our result equal to, now we're going to use the math class, the power method of the math class. We can raise a base to a given power. We will raise num1 to the power of num2. Let's perform a test run just to be sure that it works. I'm going to display our result after the switch. So Java is giving us a warning that variable result might not have been initialized. That's because it's possible there's no matching cases, and we would be keeping our result uninitialized. So to clear that up, when we declare our variable, we can also assign it. I'll just set it to be 0. Let's perform a test run. Enter the first number, let's do 3.14. Enter an operator, let's do addition. And the second number, 1.1. The result is 4.24. Let's do subtraction, 3.14 minus 1.1, which gives us 2.04. Multiplication, 3.14 times, let's do 2, 6.28. Then division, 3.14 divided by 2. That gives us 1.57. Then we have power. What is 3 to the power of 3? That is 27. 3 times 3 is 9, times 3 is 27. 3 to the power of 3. We have one potential issue, though. What if somebody divides by 0? Here's what happens. What is 3.14 divided by 0? We get the output of infinity. Here's how we could prevent that. Underneath the case where we do division, we'll write a few lines rather than just one, but we're going to enclose them within a set of curly braces. Then I'm going to cut this line of code. Within this case, we'll write an if statement. We'll check if num2 is equal to 0. That's because we can't normally divide by 0. If it is, then let's print cannot divide by 0. Else, we'll assign our result of num1 divided by num2. We'll execute the else statement if num2 doesn't equal 0. Because if it did, this would be true, and we execute this code instead. Let's try that again. What is 3.14 divided by 0? Cannot divide by 0. However, we still do display a result, and that is by using this print statement. What if somebody types in an operator that doesn't exist? 3.14, I'm going to type in pizza for the operator. Type in, I don't know, 1. Well, we still display a result. So let's modify this program. Let's display a result only if we have a valid operator, because right now we don't. Pizza is not a valid operator. Let's add a Boolean variable of valid operation. I will set this to be true from the beginning. If somebody attempts to divide by 0, I'm going to take our valid operation variable and set it to be false, because we do not want to continue and display the result. We're going to add a default case. The default case will be the following. So I'm going to write 2 lines of code for the default case. Let's output invalid operator. Then we will take our Boolean variable of valid operation and set it to be false. So this is what our switch looks like. Feel free to pause the video if you would like a moment to look it over. Within our case of division, we do have a few lines of code. Same thing applies with the default case. We're only going to print the result if our Boolean of valid operation is true. If valid operation is equal to true, but really we can just shorten this to if valid operation. Then we'll print the result. Then we don't necessarily need an else statement, because we're already printing either invalid operator or cannot divide by 0. Okay, let's run this one final time. 3.14 plus 2.1 is 5.24. 3.14 minus 1.1 is 2.04. 3.14 times 2.1 is 6.594. 3.14. Okay, 3.14 divided by 0. Let's see what happens. Cannot divide by 0. And we do not display the result, because our equation is invalid. Which is good. We don't want to display the result. We're displaying a type of error message instead. Let's raise 4 to the power of 2, which gives us 16. Now let's type in an operator that doesn't exist. 3.14 pizza 69. Invalid operator. That's because pizza is not a valid operator. Alright everybody, that is a calculator program that you can write. The purpose of this program is to more or less help us with enhanced switch statements. Depending on the operator, we can perform one of a few operations. We've also learned that your cases can take up more than one line if you would like. And well, everybody, that is a calculator program in Java. Yo, yo, yo. In today's video, I'm going to explain logical operators in Java. Logical operators, they allow us to check or modify more than one condition. There's and, or, not. We'll discuss and first, which is represented by two ampersands. Let's declare a variable of temperature. Temp meaning temperature. I will set this to be 20. I would like to check to see if my temperature falls within a certain range. Well, to do that, I could use the AND logical operator. We can check more than one condition. So first, I would like to see if my temp is less than or equal to 30 degrees Celsius. And if the temp is greater than or equal to 0. We have two conditions this time. If this is true and this is true, then do this code. So let's output the following. If our temperature falls within this range, we'll output the weather is good. And for fun, I'll add a smiley face. Because why not? Okay, let's see how this works. The temperature is currently 20 degrees Celsius. The weather is good. If the temperature were 40 degrees Celsius, well, we don't do anything. This condition evaluated to be false, but this one is true. Our temperature is greater than or equal to 0, that is true, but this one is false. And using the AND logical operator, both conditions must be true, in order for this entire statement to be true. Since only one of them was true, where temp is greater than or equal to 0, we don't execute this code. The AND logical operator is used to check more than one condition. We can add as many as we would like to. This time, let's create a variable of is sunny. This will be a boolean. Boolean is sunny. Is it sunny outside? I will set that to be true. Not only are we going to check to see if our temperature is within a certain range, we're also going to check and is sunny. Is this true? So now we are linking three different conditions. All three must be true. So if all three are true, we'll output the following. It is sunny outside. Let's set is sunny to be false. And then we are going to set our temperature to, not 240, 20. These two conditions are true, but this one is false. So we don't do any of it, we skip over it. With the AND logical operator, all conditions must be true. If is sunny were true then, well then we execute this code. The temperature falls within this range, this is true, and this is true, and this is true. All three conditions are true. So we execute this code. The weather is good, and it is sunny outside. We check more than one condition, and both must be true. There's also the not logical operator. It's a little different. How it works is that it gives you the opposite. You can check to see if something is not true. Let's add an else if statement. We're going to copy these three conditions, but make one change. We're going to precede is sunny with the not logical operator, represented by an exclamation point. It checks the opposite. We are checking to see if something is not true. Is our temperature less than or equal to 30, and greater than or equal to 0, and is it not sunny? So if something is normally false, using the not logical operator, it becomes true. If it's normally true, it becomes false. It gives you the opposite for a Boolean value, basically. If the weather is good, but it's not sunny, that must mean it's cloudy. It is cloudy outside. Then I'll add an emoji of a cloud. The temperature is good, but we'll set is sunny to be false. The weather is good, but it is cloudy outside. The temperature falls within this range, and it is not sunny. The not logical operator checks to see if something is not true. Then we have the or logical operator, represented by two vertical bars. Or is similar to the and logical operator. However, only one condition needs to be true that are linked by the or logical operator. With and, both must be true. Let's say our temperature is really cold. It is negative 10 degrees Celsius. But it is sunny outside. We actually don't end up doing anything. We skip over the if statement and the else if statement. Let's add another else if statement. We're going to check to see if our temperature is really hot or really cold. We will check if our temp is greater than 30, or, using two vertical bars, temp is less than 0. Then we'll output the weather is bad. If our temperature is negative 10, the weather is bad. With the or logical operator, at least one condition must be true. This condition was false, but this one was true. So we execute this code, because using the or logical operator, at least one condition needs to be true. Or if the temperature was 35 degrees Celsius, this time this condition was true, but this one was false. So we execute this code. Alright, let's go over another example. We're going to use these logical operators to validate a username when somebody tries to set a username. So, in this project, we'll need a scanner. Scanner equals new scanner. We're going to type system.in, then import this class. Then be sure to close your scanner at the end of the file. Scanner.close. Our username has a few rules. I'll add these as comments. Username must be between 4 through 12 characters. Username must not contain spaces or underscores. We'll create a string variable of username. We'll create a prompt to have a user enter in a username. Enter your new username. I'll use print instead of print line. We will assign our username using the scanner. Username equals scanner.nextLine. We'll write a condition to check if our username is between 4 to 12 characters. We're going to check if our username is under 4 characters or greater than 12 characters. We'll check that within an if statement. If our username, use the length method to return the length of this string. If the length of our username is less than 4, use the or logical operator, or our username, the length of it, using the length method, is greater than 12. That means our username is too short or too long. We'll output the following. Username must be between 4 through 12 characters. Let's perform a test run. Enter your new username. I'll type in something that's less than 4 characters. Username must be between 4 to 12 characters. Let's type in a really long username. I'll just make up something. Username must be between 4 to 12 characters. Let's type in something actually within that range. Oh, and then we need to add an else statement, because I forgot. Else we will print welcome plus username. Enter your new username. Welcome, whatever your username is. The second part of this assignment is that we need to check to make sure that there are no spaces or underscores within our username. After the if statement, we'll add an else if statement to check that. Using the contains method of strings, we can check if a string contains a certain character. With our username, we will use the contains method. Does our username contain any spaces? Or does our username contains any underscores? If so, we'll output the following. Username must not contain spaces or underscores. Let's perform another test run. Type in your first and last name, including a space. Username must not contain spaces or underscores. This time, I will use an underscore to separate the first and last name. Username must not contain spaces or underscores. Let's type in a username that follows the rules. That seems to work. So that is the OR logical operator. If at least one condition is true, then the entire statement is true, and we execute it. Alright everybody, so those are logical operators, and checks more than one condition. Both must be true. Or checks more than one condition, at least one needs to be true. Not is a little different. It checks if something is not true. Basically, it does the inverse. And well everybody, those are logical operators in Java. What is going on everybody? In this video, I need to explain while loops in Java. If I could summarize a while loop in one sentence, a while loop will repeat some code forever while some condition remains true. First, I'll give you a demonstration using an if statement, then we'll convert it to be a while loop, and we'll see how it's useful. We'll need to accept user input in this demonstration. I will create a scanner. I'm pretty sure we know how to create one by now. Be sure to import the scanner class, import java.util.scanner, then be sure to close your scanner because I always forget to do that. Alright, we are going to create a string of name. I'll use an if statement to check to see if my name is empty. If name, use the isEmpty method. Now Java wants us to assign this name right away, so I'm going to go ahead and initialize it. We can initialize it with an empty space. If our name is empty, which it will be, we will prompt the user to enter your name. I'll use print instead of print line to keep it on the same line. Then we will assign our variable of name. Name equals scanner dot next line. After we escape the if statement, we'll output our name. Let's say hello plus name. So this program will work, but there's one issue. What if I don't type in anything when I enter my name? I'll just hit enter. Well, we still continue with the rest of the program. The output is hello. We don't display a name because we didn't type in anything. How can we prevent people from doing stuff like this? Skipping prompts. Well, we could use a while loop. Rather than an if statement, replace if with while. What we're doing is, while this condition remains true, continue this code forever until this condition is no longer true. Let's try that again. Enter your name. I'm just going to hit enter. Enter your name. No. Enter your name. No. Enter your name. No. Okay, I give up. I'll type in my name. Then we escape the while loop. Hello, your name. So that's why a while loop is useful. We can repeat some code, possibly forever. At times, we may not want a user to continue without doing something. A while loop would be really helpful for that. They would be stuck until this condition is no longer true. At the end of your while loop, we go back to the beginning to check the condition. If the condition is no longer true, then we escape the while loop and move on with the rest of the program. There's one thing you should be cautious of though, and that is an infinite loop. Let me give you a demonstration. With our while loop, if we have a condition that we can't change from within the loop, that's called an infinite loop. So let's say while the number 1 is equal to 1. Even my IDE IntelliJ is giving me a warning that 1 is equal to 1 is not updated inside the loop. I would not recommend following me along for this part. Your computer might freeze up, but I'm going to print help. I'm stuck in a loop. Within this while loop, I have no way to change it from inside of it. So we're going to be stuck in this while loop forever. Here's a demonstration. We're just going to print this code forever. Let's check back later.
One eternity later.
It's still going. We're stuck in a loop. This may happen to you if you have some condition that you can't change. Within your while loop, you'll need some way to update your condition. Let me give you another example. Again, we'll need our scanner. We're going to pretend that we're playing a game. For a user to quit, they have to press the Q key. We will declare a string of response. We'll use a while loop. Now, for my condition, for us to be able to escape the while loop, our response, I'm going to use the not logical operator equals a capital Q, and this will be a string. So while our response does not equal Q, we continue the loop forever. In order for somebody to escape this game, they have to press Q to quit. Java wants me to assign this variable right away and initialize it, so I'll do so. We don't want our variable to be empty when we use it to check a condition. Then IntelliJ is giving us another warning that our response is not updated inside the loop. If we don't update it, we'll be stuck in an infinite loop. Let's pretend that we're playing a game. You are playing a game. Then we'll output press Q to quit. Then we will need to update our response. Response equals use our scanner. For a single character, we can use next. In case somebody types in a lowercase q, we'll follow this method with the to uppercase method. If a user was to type in a lowercase q, we'll convert it to be an uppercase q so that it matches. Once we escape the while loop, we'll print you have quit the game. Okay, let's perform a test run. You are playing a game, press Q to quit. No. Yes. Okay. As long as our response does not equal Q, we are still playing our imaginary game. In order for us to quit, to escape the while loop, we have to press Q to quit. I will press Q, and we escape the loop. You have quit the game. While our response, using the not logical operator, while our response does not equal Q, continue the loop forever. Let's go over another example. We'll ask a user for their age. Int age. I will set this to be 0 right away. We'll prompt a user to enter in their age. Enter your age. We will assign our age variable. Age equals scanner dot next int. Then at the end of this program, I will print you are our variable age plus years old. Let's say I would like to prevent somebody from typing in a negative number, like -1. You are -1 years old. Well, we could use a while loop to reprompt the user before displaying the result. So after we assign our age once, let's use a while loop. While age is less than 0, we'll output the following. Your age can't be negative. Then we'll reprompt the user again. We can just copy these two lines and then paste them within the while loop. We'll ask the user to enter in their age again and reassign it. If we keep on typing negative numbers, we can't escape the while loop. we're stuck until we type in something that's valid. You are 21 years old. That's a valid number. From the beginning, if I type in something that's valid, we don't enter the while loop at all. It is possible to skip over it. We check the condition of a while loop before entering it. If we type in a number that's valid, let's say age is 25, we check the condition. It's false from the beginning, so we don't enter the while loop at all. We skip over it and go straight to the end. In this program, we only get caught in the while loop if we type in user input that's not valid. There's a variation of the while loop known as a do while loop. We do some code first, and then check the condition. If I was to convert this code to be a do while loop, I would cut the while part, do this code, then check the condition at the end. This is how the program would run now. It's going to be a little bit different. Your age can't be negative. Enter your age. I am negative 100 years old. Your age can't be negative. Enter your age. You are, whatever your age is, years old. So with the do while loop, we do this code first, and then check the condition at the end. Where it's different compared to a standard while loop is that with the standard while loop, you may not enter the while loop at all if this condition is false. But with the do while loop, you always do this code at least once, and then check the condition at the end. Let's go over one last example with the do while loop. We'll prompt a user to type in a number that's between a certain range. We will have int number, and I will assign this to be 0 right away. Let's use a basic while loop first. While our number is less than 1, we'll use the OR logical operator to check, or if our number is greater than 10. Then do this. Prompt the user to enter a number between 1 through 10. Then we will assign our variable of number equals, use our scanner, use the next int method. And then at the end, we will print our number. You picked plus number. So let's run this. Our number is set to 0. Enter a number between 1 and 10. Let's do -1. 11, -2, 1 kajillion. I think I broke it. Okay, I'll type in something that's valid, like 5. You picked 5. Rather than check the condition from the beginning, we could check it at the end. So let's convert the while loop to a do while loop. Do this code once, and then check the condition. So this would work similarly. So, do this code once, check the condition at the end. Alright everybody, so those are while loops. They allow you to execute some code, possibly forever, while some condition remains true. They're really useful when accepting user input, because the user might not type in something that's valid, and you have to keep on reprompting them. That's one good use. There's 2 variations of while loops, a standard while loop and a do while loop. It depends if you want to check the condition before entering the loop. And well everybody, those are while loops in Java. Hello everybody, in today's video we're going to create a number guessing game using Java. Let's get started. In this program, we'll be using random numbers. We'll need to create a random object. Random equals new random. Then import this class. So at the top of our Java file, import java.util.random. This random object can generate random numbers for us. We'll also accept user input. We'll need a scanner. Scanner equals new scanner. Then within the set of parentheses, type system.in. Then import this class as well. Import java.util.scanner. we have a random object to generate random numbers, and a scanner object to accept user input. What are the different variables we'll need? We'll need the following: an integer to hold our guess. So let's say we're going to guess a random number between 1 and 100. We'll use the scanner to accept an integer and place it within this variable of guess. For example, the guess might be 50. We'll need to keep track of the amount of attempts it took a user to get the correct number. Int attempts. We'll assign these later. And we'll need a random number. Int random number. Let's go ahead and assign this right away. To generate a random number, we're going to use our random object, use the next int method of a random object. Within this method, we can list two numbers, a range. If I would like a number between, let's say, 1 and 10, my two numbers would be 1, 11. The first number is inclusive, the second number is exclusive. Let's perform a test run of our random number. I just want to be sure that it's generating correctly. When writing a program, it is a good idea to test your code every once in a while, just to be sure that everything is working. So we should get random numbers between 1 and 10. 1, 10, 5, 8. Good enough. A random number stores a random number after generating it. Let's create a welcome message. Let's say, number guessing game. We will prompt the user, guess a number between, let's start with 1 through 10. Later on, we'll increase it to 100. Now, we'll need a while loop, but not just any while loop. We'll create a do while loop. So do this code once, while this condition remains true. And let me zoom in a little bit. So what's our condition going to be? We're going to continue playing this game while our guess does not equal our random number. We'll keep on playing until we get the random number. Exclamation point equals means not equal. So if our guess does not equal our random number, this returns true then. We want to keep playing while our guess doesn't equal the random number. Within this do while loop, we'll prompt the user to enter in their guess. I'm going to use print line instead of print for guess a number between 1 and 10. Now, we'll prompt the user to enter a number. Enter a guess. Enter a guess. For this, I'll use print instead of print line. We will assign our guess variable equal to, use our scanner, use the next int method. We're also keeping track of the amount of attempts it takes a user to get the correct number. So we can increment attempts by adding ++. And let's go ahead and initialize attempts. We'll set that to be 0. Temporarily, outside the while loop, I'm going to print you have 1. My random number right now is only between 1 and 10. I'm just going to keep guessing until we get the right number. So I'll just start with 1 and go all the way to 10. The answer was 9. We escaped the while loop. So we know that this is working currently. One thing this program is missing is that we'll want to give a user a clue if their guess is too low or too high, because we have no way to tell. I'm just typing in random numbers, and I have no clue how close I am to the actual number that we need to guess. Let's get rid of this print statement. We were using it for testing purposes. Within the do while loop, we'll write an if statement. We'll check if our guess is less than our random number. That means we guessed too low. If that's the case, we'll output the following: too low, try again. Else if our guess is greater than our random number, that means we guessed too high. Too high, try again. If our guess isn't lower than our random number, and our guess isn't greater than our random number, that means our guess must equal the random number. So if that's the case, we would be executing this else statement, because the preceding two conditions would be false. That means we have the right answer, the right guess. So we'll output the following. Correct. Let me zoom out. The number was plus our random number. And then we'll display the amount of attempts it took. Number of attempts plus our variable of attempts. After each guess, we increment it by 1. The last thing I'm forgetting is to close my scanner, because I always forget to close it. Scanner.close. Okay, let's perform a test run. We're only guessing a number between 1 and 10 currently. I'll guess something right in the middle, 5. Too low, try again. The random number we have to guess should be between 5 and 10 then. I'll go with 7. Too low. 8. Too low. 9. Too low. Okay, it must be 10 then. Correct, the number was 10. Number of attempts, it took 5. We're going to improve this code now. What if we would like the numbers 1 through 100 this time? Well, we could make this program a little more flexible. Instead of hard coding these numbers within the next integer method, we'll place some variables here instead. We will create int min equals whatever you want the minimum to be, let's say 1. Int max, I will set the max to be 100. Let's replace these two numbers. The first one will be min, comma, max. So these variables behave as if they were these numbers. Within this range, the second number is exclusive. So to include 100, I'm going to add plus 1. Give me the numbers between 1 and 100. Within this print statement, let's use printf instead. We'll replace these numbers with the format specifier, a placeholder. We will display an integer, so we need d. Let's do the same thing with 10. D. Let's do comma min, comma max. And then add a new line at the end. Let's do one final run. So now we're guessing a number between 1 and 100. I'll guess something right in the middle. Too high, try again. Our number's going to be between 1 and 50 then. 25, too high. 12, too high. 6, too high. 3, too low. Between 3 and 6. 4. Correct, the number was 4. The number of attempts, it took 6 attempts. Alright everybody, so that is a number guessing game that you can create using Java. Hi there everybody, so in this video I'm going to explain for loops in Java. A for loop is similar to a while loop. However, a for loop executes some code a certain amount of times. How a for loop is different from a while loop could execute an infinite amount of times, until its condition is no longer true. So with for loops, we want to do something a certain amount of times. To create a for loop, type for, parentheses, curly braces. Now within the condition of the for loop, there's 3 statements. Each is separated with a semicolon. We have statement 1, statement 2, and statement 3. The first statement is used for initialization. We can create a counter to keep track of how many times we have iterated this loop. Basically, we're declaring a variable, a counter. This will be int. Now, a common practice for a for loop is to create a counter named I, meaning index. Int I equals 0, or some other number. I is going to be used as a counter within this loop, also known as a loop control variable. The second statement is a condition. When do we want to stop? Maybe we would like to execute some code 10 times. We'll continue this loop as long as I is less than 10. Now the third statement is the step. We can increment our counter of I by 1, or another number, or even decrement. After each iteration, let's increase I by 1, I++. Let's perform a test run. I'm just going to print the word pizza. So we should execute this code 10 times using this for loop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a for loop is good if you want to repeat some code a certain amount of times. But there's a little bit of setup you have to do. We'll need some sort of index or counter, a condition in which you want to stop, and you'll need to update the counter, one way or another. Initialization, condition, update. We can also print this index of I. Rather than printing the word pizza, let's print I, to see what we're working with. During the first iteration, I is 0. After our loop is complete, we increment I by 1, our counter. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're looping 10 times, but we set I to be 0 to begin with. If I were to set I to be 1, and I want to iterate 10 times, I could say, while I is less than or equal to 10. So now we're starting at 1, and counting up to 10. We can even decrement too. Let's set I to be 10. We'll continue this loop as long as I is greater than 0. To decrement, we'll set I to be minus minus. Now we're starting at 10 and decrementing. But we're still looping 10 times. Let's go back to the beginning. Using the update statement, we can even increment by a certain number. Instead of incrementing by 1, let's increment by 2, and see what happens. So this time we start at 1, and update our counter of I 2 each time. Or even 3. I plus equals 3. 1, 4, 7, 10. We can decrement by a given number. Let's set I to be 10. We'll continue this loop as long as I is greater than 0, and we will decrement our step. We will decrement by 2. I minus equals 2. Now we're starting at 10 and decrementing by 2. Or even 3. I minus equals 3. 10, 7, 4, 1. For this next example, we're going to accept user input. Again, we'll need a scanner. Import the scanner class, and close your scanner at the end. We'll create a prompt. Enter how many times you want to loop. I'll create a variable of max. Max will equal, use our scanner, use the next int method, and now we're going to create a loop, a for loop. Again, there's 3 statements, each separated with a semicolon. We'll need an index or counter to keep track of how many times we have looped. Let's say int I equals 0. For the next statement, what's our condition? We want to continue as long as I is less than the max. I is less than our max variable. Then increment I by 1. Then we'll print I, or something else. Let's try this. How many times do you want to loop? Let's loop 5 times. 1, 2, 3, 4, 5. Again, we set I to be 0, so that's why we're beginning with 0. If you would rather begin with 1, we can set I to be 1. Then the condition would be I is less than or equal to max. Let's try that again. Let's loop 6 times. 1, 2, 3, 4, 5, 6. Alright, now we're going to create a mini project. We'll create a program to simulate a countdown. Perhaps we have a variable of int start. Let's start at 10. We're counting down from 10. Then we'll create a for loop. We will set our index of I equal to our start. Our start variable behaves as if it was the number 10. We'll continue as long as I is greater than 0. Then we will decrement by 1 with I minus minus. During each iteration, let's just print I. Then when we escape the for loop, let's print Happy New Year. Kind of like it's a countdown to a new year. Here's what we have currently. We start at 10, count down to 1, then display Happy New Year. If you would like, we can use the thread class and have our program sleep for about 1 second between each loop. Here's how you can do that. After printing I, this is a little advanced Java. At this level, you don't need to understand how this works. But we're going to use the thread class, call the sleep method, then pass in an amount of milliseconds in which we would like to sleep. 1000 milliseconds. Now Java wants us to add the following. Java wants this method of main to throw this exception if our thread is interrupted. This is intermediate Java. We will need this section of code in order for our program to sleep. After you finish this lesson, be sure to remove throws interrupted exception. We'll no longer need it. Print I, then our program is going to sleep for 1 second, 1000 milliseconds. Alright, and here's our mini project. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year. Let's modify this program a little bit. Now we'll use a scanner to accept user input. Scanner equals new scanner. We have already imported the class. With start, we're going to accept some user input. But we'll need a prompt. How many seconds to count down from? We will assign start to be use our scanner, then use the next int method. Alright, let's try this again. Let's say I would like to count down from 20. And it looks like it's working. I'll fast forward the video till we get to the end. 3, 2, 1. Happy New Year. So those are for loops. We can execute some code a certain amount of times. It's very similar to a while loop. In fact, there's a lot of overlap where you could use either a for loop or a while loop. Use a for loop if you want to do something a limited amount of times. And well, everybody, those are for loops in Java. I have a pretty short video for you today. We're going to discuss 2 important keywords when it comes to loops: break and continue. Break is used to break out of a loop. Continue skips the current iteration of a loop. Think of the break keyword as the stop button on a remote. Continue would be similar to skip. With break, we're stopping. With continuing, we're skipping. Let me give you a demonstration. Let's create a for loop that will iterate 10 times, let's say. Int I equals 0 will continue as long as I is less than 10. Then increment I by 1. During each iteration, I'll just print I. Then add a space. Here's what we got. We have the numbers 0 through 9. So let's say when we reach 5, I would like to break out of the loop. We're going to stop it. Well, I could add an if statement. Let's say if I is equal to 5, then we will use the break keyword and break out of the loop entirely. Here's what happens. Once we hit 5, we break out of the loop. Previously, we continued all the way until 9. Now, with the continue keyword, we don't break out of the loop. We just skip the current iteration, like a skip button on a remote. This time, let's use continue rather than break. And we'll see the differences between the two. Now, since we're using continue, the number 5 is missing. We skipped that specific cycle of the loop and went back to the beginning. That's why 5 is missing between 4 and 6. But we still continue to the end. When working with loops, if you ever need to break out, you can use the break keyword. To skip the current iteration, you can use continue. And well, everybody, that is both the break and continue keywords in Java. Hello again, friends. Today I'm going to explain nested loops in Java. A nested loop is really just a loop inside of another loop. You often see nested loops within a matrix or matrices, or when we reach the topic of data structures and algorithms. They might not come up for a while. Yeah, this can be any combination of for loops or while loops. Any kind of loop inside of another loop. Let me give you a demonstration. Let's say I would like to print the numbers 1 through 9. I can do that pretty easily with a for loop. So we will create a for loop. I will set an index of I equal to 1. We'll continue this loop as long as I is less than or equal to 9. Then I will increment I by 1. During each iteration, I will display I. So this will print the numbers 1 through 9. Or if you prefer, you can have it all on the same line by using print instead of print line. Then it would look something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can even separate them with a space. After printing our index of I, let's print a space character. And now the output looks something like this. What if you would like to do this code 3 times, let's say? Print the numbers 1 through 9 3 times. Well, you could copy and paste this for loop, then do that 2 additional times. So we have the numbers 1 through 9 3 times. To put each row on a new line, can use an empty print line statement. Then it would look something like this. A matrix. We seem to be repeating our code a lot. In programming, we like to follow the dry principle. Don't repeat yourself, if you don't have to. Instead, why don't we create a for loop, and stick this for loop inside of that loop. Let's create a for loop to iterate 3 times. I will create an index of I equal to 1. We'll continue as long as I is less than or equal to 3. Then increment I by 1. All we're going to do is take our code, including the for loop, and stick it within this other for loop. Do pay attention to the indentation. But we have one problem. We're reusing this index of I. You can see that Java is already giving us a warning. Here's what happens. Variable I is already defined in method main. If we have a loop inside of another loop, we can't use the same index. A common naming convention for a nested loop is to use an index of j rather than I, because j comes next in the alphabet after I. Instead of printing I, we're going to print j. Let's see how this works. And here's our matrix of data. We're printing our index of j 3 times. After escaping the nested for loop, we have a print line statement here. If I were to get rid of that, we'll print the numbers 1 through 9 3 times, all on the same line. Let's put that back in. Nested loops are really good when you're working with a matrix of data. Nested loops come up pretty often in the topic of data structures and algorithms, because we have to loop over sets of data. Now we're going to cover a mini project. We're going to create a matrix of a symbol that a user is going to type in. A user will set the rows and columns for this matrix. We'll declare the following variables: int rows, int columns, and char symbol. We'll need a scanner, so let's declare that. We'll need a scanner, scanner equals new scanner. Within the set of parentheses, type system.in. Let's be sure to import this class of scanner at the top of our Java file, and close the scanner when we're done with it. Scanner.close. We're going to accept some user input. A user is going to specify the rows, the columns, and the symbol we're going to use. Let's create some prompts. Enter the number of rows. I'll use print instead of print line. We will assign our variable of rows equal to, use our scanner, use the next int method. Then let's do this with columns. Enter the number of columns. Columns equal scanner.nextInt. And the symbol we're going to use. Enter the symbol to use. We will assign our symbol equal to scanner.next, and we can use the char@at method. Give me the character at index of 0. Let's create a for loop for the columns first. Let me zoom in. We're going to set int I. We can set it equal to 0. We'll continue as long as I is less than our columns, whatever the user types in. Then increment I by 1. During each iteration, I'll use print instead of print line. We will print our symbol. Let's perform a test run. Enter the rows. It doesn't matter. We didn't set up the rows yet. For the columns, let's do 8. Enter the symbol to use. Let's do a $sign. That'd be cool. We have the column set up currently. We should have 8 $signs. 1, 2, 3, 4, 5, 6, 7, 8. We need to repeat this for loop for as many rows as we have. So we're going to stick this loop within another loop. With our nested loop, let's replace our index of I with j. For the outer for loop, we will create a new index of I equal to 0. We'll continue this as long as I is less than the rows, the number of rows that a user types in. Then increment I by 1. Let's perform another test run. Let's say I would like 3 rows of 6, and I will use an @ sign. So these are all on the same line. We should have a total of 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Our inner loop ends after each group of 6. I'm going to print a new line. We can use an empty print line statement. Our outer for loop is in charge of the rows. Our inner for loop is in charge of the columns. Let's see the final product. I would like 5 rows of 3 columns. I'll use an ampersand. Here we are. We have 3 columns and 5 rows. Alright everybody, those are nested loops. It's really just any kind of loop inside of another kind of loop. It doesn't matter if it's a for loop or a while loop. We often use nested loops with matrices, or when we reach the topic of data structures and algorithms. They might not come up very often, but you should at least be aware of their existence. And well everybody, those are nested loops in Java. What is going on everybody? In this video I'm going to discuss methods in Java. Think of a method as a block of reusable code that is executed when you call it. To call a method, you use a set of parentheses, kind of like it's a pair of telephones talking to each other. Why are methods useful? Well, with a method, you can write some code once and reuse it whenever you want. You just have to call it. Let me show you why a method is useful. So let's say we have a task. We have to sing a happy birthday song 3 times. So without using a method, we could do something like this. We'll create one verse of a happy birthday song. I'll just make something up. Let's say, happy birthday to you. Happy birthday, dear you. You are, we'll insert somebody's age here, but let's say you are X years old. Then happy birthday to you again. Then I'll add a new line character to the end. So when we run this code, we sing happy birthday once. If I need to sing happy birthday, let's say 3 times, well, without using a method, we could, although it's inefficient, copy this code and paste it 2 additional times. Then we're singing happy birthday a total of 3 times. Well, you know, this does work, but we tend to be repeating ourselves a lot. In programming, we like to follow the dry principle. Don't repeat yourself. How can we not repeat ourselves if we don't have to? Well, let's create a method. A method is just a block of reusable code. So to create a method, in Java, outside of the main method, do pay attention to these curly braces, we'll create a new method. A method can return something. For now, we'll type void, much like our main method. And we need a name for this method. The method should be descriptive of what it does. Let's call it the happy birthday method. All it does is sing happy birthday. We need a return type, a name for the method that's descriptive, parentheses, then curly braces. Let's cut our song of happy birthday and paste it within the happy birthday method. At any point to use this method, I have to call it. Call it by its name. Happy birthday, then add a set of parentheses. So we have one issue in Java. Java wants this method to be static, much like the main method that we work within. So in order for this program to work, we need to add this keyword of static. Normally you don't need this keyword, but since we're calling this method of happy birthday from another method that's static, this method also needs to be static. Later on in the series, we'll discuss what static does. You'll likely have to include that for now. Alright, let's do a test run. So we are going to sing happy birthday once. So again, to call a method, type the name of the method, then a set of parentheses. The pair of parentheses kind of represent a pair of telephones. That's how I think of it at least. So now we should sing happy birthday. Now this code is reusable. We write it once and reuse it whenever we want. We just have to call it again. We will call the happy birthday method again. Now we are executing that block of code 2 times, or even 3. Happy birthday. One thing you should be aware of is that methods are unfamiliar with any variables declared within other methods. So let's say we have 2 variables, a string of name. Type in your first name, whatever it is, and an integer of age. Set it to be some age. If I was to use these variables within my happy birthday method, well, the happy birthday method actually doesn't know what these are. So let's attempt to use them and see what happens. Within our happy birthday song, let's convert this print statement to be a printf statement, and we will insert our name variable. Replace you with the format specifier, and we are displaying a string. See, we already have a warning. Cannot resolve symbol name. I'll attempt to run this code, and we'll see what happens exactly. Java cannot find variable name. Methods are not familiar with variables inside of other methods. If we live in this method of main, if it's our house, so to say, we can't see what's going on in our neighbor's house. One way in which we can solve this is to pass arguments to this method. From one method, we can send information to another method. These are known as arguments. So when we sing happy birthday, within the set of parentheses, within the pair of telephones, we can pass a value or a variable. So let's send our variable of name to this method of happy birthday. Anything that you send a method is known as an argument. But we have one issue though. Our method of happy birthday isn't set up to receive arguments. If you send any values or variables to a method via arguments, you need a matching set of what is called parameters. Our happy birthday method isn't set up to receive these arguments. We need a matching set of parameters. To set up some parameters, we're going to list the data type of what we're receiving. We're receiving a string value. So the data type is going to be string. And then we need a name for what we're receiving. It doesn't have to be exactly the same, but it might be helpful to keep these consistent. So let's perform a test run. After this printf statement, I'm going to add a new line character. Happy birthday to you. Happy birthday, dear, your variable name. So if I was to change my name to, let's say, SpongeBob, we'll insert this value at this location within our method. Happy birthday, dear SpongeBob. Let's also pass in our variable of age. So any arguments you're sending to a method, you're going to comma separate. However, we need a matching set of parameters. Our method isn't set up to receive this variable of age. Let's perform another test run. So we have an error. Actual and formal argument lists differ in length. We need a matching set of parameters to the arguments we're receiving. Not only do we need a string variable, we need an integer variable, because we're receiving an integer. So let's say int age. We'll insert our age variable right here. We're displaying an integer, so we need %d. This will be a printf statement. Then I will include a new line character. We are inserting our age variable. Let's say SpongeBob is 30 years old. Alright, let's see how this works now. Happy birthday to you. Happy birthday, dear SpongeBob. You are 30 years old. Happy birthday to you. So with these parameters, you can rename them. When you receive these arguments, just be sure that the order and their data type is correct. For example, we could rename name as, let's say, birthday boy. You know, this would work too. SpongeBob is the birthday boy. The names of your parameters can be different from the arguments. Just be sure that you get the data type correct and the order in which you receive these arguments. Let's replace the name of SpongeBob with Patrick. Patrick will be 38. So now with the happy birthday method, we're inserting new variables. Happy birthday, dear Patrick, you are 38 years old. With methods, they also have the capability to return a value. So I'm going to collapse this happy birthday method. We won't be working with it anymore. Let's create a method to square a number. We'll create a method to square a number, then return the result. Normally, if we're not returning anything, we would type this keyword avoid. But since we're returning a double, we have to list the data type of what we're returning. We're returning a double. Then we need a name for this method. Let's say double square. All we're going to do is use the return keyword. Let me zoom in a little. Let's return a number times itself, number. We're going to receive one argument, an argument of number, so we have to set up a matching parameter. Our number is going to be a double number. Let's call the square method, I will square the number 3. And again, since we're calling a method that's not static from another static method, we need to add this keyword of static in order for it to run. There'll be more on the static modifier in the future. So if I was to run this, we get no output. We're returning a double back to the exact spot in which we call it. We could assign it to a variable or print it directly. Let's say double result equals square the number 3. Then display the result. So 3 squared would give us 9. So when returning something, just imagine that after the method ends, we're replacing that method call with whatever we're returning, in this case 9. Picture it that way. And then we're assigning 9 to our double of result. Or we could just output it directly, if you would prefer to do it that way. Let's print 3 squared. And that would also give us 9. Now let's create a method to cube. We're going to return a double. Double cube. We have one parameter. A double of number. We're going to return our number times number times number. That would cube a number that we're given. And again, we need to add static because we're calling a method from another method that's static. All right, this time we will call the cube method and return the result. So 3 cubed is 27. 3 times 3 times 3 is 27. One last example. We'll create a method to return a full name after being given a first name and a last name. We're going to return a string. We'll call this method getFullName. We'll have 2 parameters, a string of first for first name and a string of last for last name. We're going to return our first name plus a space to separate them plus our last name of last. And again, we have to add static. Okay, let's declare a string variable of full name equals, call the getFullName method, then pass in some arguments. Let's pass in SpongeBob, then for the next argument, SquarePants. And then we'll print the full name. Print full name. Our method returns one long string of SpongeBob SquarePants. The return keyword will return a value after the method ends. It will return that value back to the place in which you call that method. After this method of getFullName is complete, just imagine that we're replacing it with one long string of SpongeBob SquarePants, like this, and then assigning it to this variable. Okay, so I lied. I have one last good example to give you. We'll create a method to verify a user's age. Normally, in the United States at least, you have to be 18 or older to sign up for things, like a credit card. We'll create a method to check a user's age. Again, we're going to use static, because we're calling a method from another method that's static. Let me zoom in. We're going to return a Boolean this time. The name of the method, let's name it age check. And there's going to be one parameter, an integer of age. If we're going to do an age verification check, we could use an if statement. So within our method, we'll write an if statement. If our age parameter is greater than or equal to 18, then let's return true. Else, we're going to return false. This can be simplified to the following. Return age is greater than or equal to 18. You can do it either way. For a beginner, it might be easier to read if we have separate if-else statements, but both work the same. Alright, so we now have a method to check a user's age. So now we can use this method. I will create an integer variable of age. Set it equal to some age. I'll use an if statement. We're returning a Boolean value. I can use that within an if statement. If age check, then pass in an argument. We will pass in our variable of age. If this is true, if age is greater than or equal to 18, we return true. So let's print the following. You may sign up. Maybe we're signing up for a credit card. Else, let's print, you must be 18 plus to sign up. Our age is 21. You may sign up. But if we were 12, that method returns false. You must be 18 plus to sign up. So that's a method, everybody. It's a block of reusable code that is executed when called. Again, I like to think of the parentheses after a method as a pair of telephones talking to each other. To use a method, you have to call it. And well, everybody, those are methods in Java. Hello everybody, in this video I'm going to explain overloaded methods in Java. In Java, overloaded methods are methods that share the same name, but they have different parameters. A method's name, plus its parameters, will give you a unique method signature. Each method signature needs to be unique. No two methods can share the same signature, but they can share the same name. Let me give you a demonstration. Let's say we have a method. It's going to return a double. The method name will be add. We'll add two numbers together. Add is the method name, and then we'll set up some parameters. We'll have double A for the first number, and double B. All we're going to do is return A plus B. It's a simple method. So I'm going to print add the numbers 1 plus 2, and then print it. This will give us 3. What if I would like to add a third number? You can see that Java is already giving us a warning. Expected 2 arguments, but 3 found. So if I were to run this program, we get an error. Actual and formal argument lists differ in length. One solution is that I could create another method, also named add, but it has different parameters, where we accept 3 numbers. So let me just copy this method, paste it, then I'll add another parameter for double C. Return A plus B plus C, and that should work. Now the number is 6. These two methods share the same name, but they have different parameters. So that's actually legal in Java. A method's name plus its parameters will give you a unique method signature. No two methods can share the same signature. With our second method, let's delete the last parameter of double C and attempt to run this, and we'll see what happens exactly. Well, we get an error message. Method add is already defined in class main. Java is saying that we have two methods that share the same name and the same exact parameters. Methods can share the same name, but they need different parameters if that's the case. Now, if I would like to add another number, like 4, I could create another overloaded method, also named add, but this one will have 4 parameters. Double D. Return A plus B plus C plus D. And this works too. Let's go over another example. Let's pretend that we're baking a pizza. We'll have a string variable of pizza. We'll create a method to bake a pizza, but we have to pass in ingredients. We'll declare a method with static. We'll return a string. That's the return type. The method name will be bake pizza. Our parameters are going to be a set of ingredients. For this method, we'll just accept a string of bread. We'll just return our bread variable plus the word pizza. So this could be, for example, a thick crust pizza or a flatbread pizza, so to say. Let's set our pizza variable equal to, call the bake pizza method. Now this method only has bread setup as a parameter and ingredient. Let's say flat bread for the bread. And then we'll print our pizza. System.out.println, our string variable of pizza. Here's what we have. We have a string of flat bread pizza. So when baking a pizza, there's a lot of different ingredients. Let's create another method of bake pizza, but we have a parameter of bread and a parameter of cheese. Let's copy this method, paste it, but we have to change the parameters. We're already receiving a warning. We'll have string bread and string cheese. No pun intended. Let me zoom in. Now those warnings have went away. We have two methods with the same name, but they have different parameters, which is fine. We can do that. So this time, let's return a string of cheese plus a space character plus our bread plus the word pizza. Let's pass in a type of cheese. Mozzarella. I probably misspelled that. Actually, I spelled it correctly. Okay, now we'll bake our pizza. We have a mozzarella flatbread pizza. If there's two or more methods with the same name, we'll end up using the method where the parameters match. We'll create one more overloaded method. We'll create another bake pizza method, but this one will have a custom topping. String topping. We'll return topping plus a space character plus everything we had previously. Then we can pass in a new ingredient. How do you spell pepperoni? I can never spell it. Pepperoni. Now this time we have a pepperoni, mozzarella, flatbread pizza. Alright everybody, so those are overloaded methods. Methods can share the same name, but they need to have a different list of parameters. A method's name plus its parameters will give you a unique method signature, and no two methods can share the same signature. And well everybody, those are overloaded methods in Java. I got a relatively quick video for you today. Today we're going to discuss variable scope in Java. Variable scope is where a variable can be accessed. There's two levels we'll discuss today, local and class. We'll cover local first. Inside of a method, if you declare a variable, it has what is considered a local scope. In this demonstration, let's create a variable of x. X will equal some number such as 1. And then, we can print whatever x is. X equals 1. A variable declared inside of a method has a local scope. And I'll just add a comment that this is a local variable. Outside of the set of curly braces, where this variable is declared, x isn't going to be recognized. That's why if we create another method, we would have to pass it as an argument. Let's create another method. This will be a static method that doesn't return anything. I'm just going to say it's the doSomething method. Inside of other methods, you can declare variables that have the same name. Within this other method, we're going to create an integer variable of x, but x is going to equal 2. So Java isn't giving us any warnings. It is legal to have variables with the same name, as long as they're within different methods. The moment I place this variable within my main method, Java is giving us a warning. Variable x is already defined in the scope, this local scope. Variable x within main has a local scope. Variable x within the doSomething method also has a local scope. And I'll just add a comment that this is a local variable. If I was to print x within this method, and if I was to call this method, what do you think will output? 1 or 2? Take a guess. 2. Within the context of our doSomething method, x equals 2. This method isn't aware of the existence of this variable within this method of main. They each have a local scope. It's kind of like their neighbors. They can't see inside of each other's house. Now, a class variable is declared inside of a class, but not within any methods. You usually see them at the top. Let's create a static variable, an integer of x, where x equals 3. Variable x within this class of main has a class scope. In our analogy of houses, you could say that this variable is out in the street. These two methods can look out their window and see variable x, and that it equals 3. If I was to delete these two local variables and print x, here's the result. X equals 3. Or within our main method, if I was to print x, x also equals 3. Let's say that each method is a house. They're neighbors. You could say that a class variable is outside. They're walking down the street. Both of these methods can look outside their window and see this variable. Now, if you had a mix of both local and class variables that share the same name, let's say int x equals 1, and this was a local variable, And within our method of do something, x equals 2. Let's call the do something method. We'll print x within the main method, and then within the do something method. What do you think the output is going to be? Well, we have 1 and 2. Even though there's a third x variable within the class scope, Java likes to use any local variables first, if they share the same name as any class variables. Within our method of main, this method thinks x equals 1. It's going to use the local scope first. You'll likely want to stick with local variables over class variables. There are a few situations when a class variable would be better, such as if you have constants where the value doesn't change, or when working with object-oriented programming, which is a whole nother topic. So that is variable scope in Java. Anything with the local scope is declared inside of a method, or otherwise within a set of curly braces, and is only recognized within this method. Other methods aren't aware of its existence. That's sometimes why we pass them as arguments to other methods. Class variables are declared inside of a class. They are recognized throughout the entire class. And well, everybody, that is variable scope in Java. Hello everybody, in this video we're going to create a very simple banking program using Java. This video is meant to be a beginner's project to help us understand how methods work. So if that sounds good to you, let's get started. As a beginner, it might be helpful to you to break up your project into separate steps, then tackle this project one step at a time. I'll add a few comments of the different steps our program is going to take. So first we're going to declare our variables. I misspelled that. Then we will display a menu. A user is going to pick a choice from this menu. Depending on what they want to do, they can make a deposit, show their balance, make a withdrawal, so on and so forth. We will get and process user's choice. We'll create a method of showBalance in order to display the balance to the user. Let me zoom in. Another method to make a deposit. Then a method to withdraw funds. We'll just say withdraw. And then we will create an exit message at the end, once the user exits. So again, as a beginner, it might be helpful to you to break up your program into different steps. We'll start with our step of declare variables. Here's the different variables we'll need. We have an account. Our account has a balance, such as dollars and cents. So a double would make sense for the balance, because it includes a decimal portion, cents. So we have our balance. We'll need a scanner because we're accepting user input. Scanner equals new scanner. Type system.in, import this class, import java.util.scanner, and then we are going to close our scanner when we're done with it. Let's take care of that now because I'm probably going to forget. We have our scanner, our balance. We're going to continue this program as long as a user doesn't exit. We'll need a while loop. We will declare and assign a Boolean variable of is running. Set that to be true. Continue this program while is running is true. Then we will accept a choice from the user. This will be an integer. A user is going to pick 1 to show balance, 2 to deposit, 3 to withdraw, or 4 to exit. The user is going to fill this in later using the scanner. Alright, we have declared our variables. Now we'll display a menu to the user. I will print the following. Let's say banking program. Now you don't need to do this, but I like to add some separators using a bunch of asterisks. I just think it makes it look cool. We will lay out the different options. We will have option 1. Option 1 will be to show balance. Option 2 will be to deposit. Option 3 will be to withdraw. 4 will be to exit. And then I'll add another separator. Again, not necessary. I think it would just look more organized. Now we need to get and process the user's choice. We have a variable of choice. We'll need to create a prompt. We will say, enter your choice, then hint 1 through 4. I'll use print instead of print line because I like the user input on the same line as the prompt. We will assign our variable of choice equal to use the scanner called the next int method. Ideally, a user is going to type in a number 1 through 4 to do one of the following. Now we'll process the user's choice. I think an enhanced switch would be great for this. We will create a switch and examine our variable of choice. We're examining our choice against matching cases. If choice equals a case of 1, we'll write an arrow to do something. We'll do this. We're going to call a method to show our balance, because 1 means the user wants to show their balance. We'll fill that in later. Let's write a test message. I'll use system.out.println. Let's say show balance. Case 2 will be for deposit. We'll just print a test message of deposit. Again, we're going to fill this method in later and call it. Case 3 is for withdraw. Case 3, withdraw. Case 4 is to exit. That we can actually fill in right away. It's pretty simple. We'll take our Boolean variable of isRunning and set it to be false. Then we'll add a default case, in case somebody doesn't type in a number 1 through 4. We'll output invalid choice. Let's test numbers 1 through 3 first. Enter a choice. I'll pick 1. That's for show balance. Again, we'll be calling a method later to show our balance. 2 is for deposit. We're depositing. 3 is for withdraw. 4 is to exit, but it doesn't do anything currently. Then any other choice, such as 5, prints out invalid choice. We want this program to continue running as long as isRunning remains true. So let's enclose our code within a loop. A while loop. While isRunning, you don't necessarily need to say equals true. If it's a Boolean, you could just say the Boolean variable's name. While isRunning is true, then do all this code. So I'm going to cut our code currently and paste it within the while loop. Now we can test isRunning. 1 is to show balance. We show our balance. 2 is to deposit. We deposit. 3 is to withdraw. Withdraw. 4 is to exit, and we should exit. Processed finished with exit code 0. We know that that works now. Our next step is to show balance, and this is going to be a method. Outside of our main method, we're going to create a new method of show balance. This has to be a static method because our main method is also static. There will be no return type. The return type is void. The method name will be show balance. There's going to be one parameter, a double of balance. When we call this method, we have to pass in our balance variable. Within this method, we're going to use a printf statement. And I'll zoom in a little. Within this printf statement, pick a unit of currency you would like to use for this banking program. I'll use American dollars. We need a placeholder. We'll use a %, and then F to display a double. F means floating point number. We will display our balance. And from the beginning, I'm actually going to set my balance equal to 0. We're going to be testing it. Then let me zoom out. For case 1, we're going to call the showBalance method, but we have to pass in our balance variable. Alright, let's test it. Enter a choice. I'll pick 1 to show our balance. Here's what we got currently. $0 and a bunch of zeros after the decimal. We are forgetting that new line character too, so let's add a new line character to the end before I forget. If you would like to display 2 digits after the decimal, for example, normally when you display a floating point number using printf, you display 6 digits after the decimal. To limit it to 2, we can add the following. After our placeholder, our percent sign, we're going to add 0.2. And to your choice, I will type in 1 to show our balance. Our balance is $0 and 0 cents. We're displaying 2 digits after the decimal. Let's change our initial balance to be $10.99. And to your choice, I will type in 1. Our balance is $10.99. I think I'm also going to add a separator before displaying the balance too, to help with readability, although it's not necessary. So I'm going to cut one of these lines where we display a bunch of asterisks and print it right before displaying the balance. Let's show our balance, and here's our balance, $10.99. And we have some of those separators before and after, which I think looks nice. Our showBalance method is complete. I'm going to collapse this method. We don't need to code within it anymore. Our next method is to make a deposit. We'll create a method of deposit. Oh, and then be sure to set your balance back to 0. We will create a static method. The return type is going to be double. We will declare this method as the deposit method. There will be no parameters, but we will be returning something, a double. Inside of this method, I will create a local variable. The data type is double. The name will be amount. A user is going to type in an amount, the amount that they're depositing, using this method. This method isn't going to work properly until we return something. Add return statement. Just temporarily, so everything runs fine, I'm just going to return 0. We'll take care of this later. I just want everything to run and compile fine. We will prompt a user to type in an amount. I will use print instead of print line. That's my own preference for prompts. Enter an amount to be deposited. Now, here's one issue. We're accepting user input from a user. Amount equals, if I attempt to use our scanner, scanner.nextDouble, there's an issue. Our method isn't aware what the scanner is, because we declared the scanner within a separate method, our main method. Methods can't see inside of each other. There's a few different options. One, we could create a local scanner within this method. You know, scanner equals new scanner and all that. I don't like the idea of creating several different scanners within this project, because then we're leaving them all open to accept user input. So why don't we do this? Let's take our scanner, move it from this local scope, and put it within a class scope. So let's cut our scanner within the main method, and stick it within the main class. But it does need to be static, because some static methods are using it. This one scanner is accessible throughout the whole program now, and that warning goes away. So I think this would be better than creating several different scanners and leaving them all open throughout this program. We're just going to reuse the same one. At this point, we're going to verify the amount that the user types in. I'll use an if statement first. If a user types in an amount that's negative, well, they can't make a deposit. They can't deposit negative money. That's stupid. So we will check if our amount variable that the user types in is less than 0. If that's the case, we will print the following. Amount can't be negative. And then we will return 0. If the user does type in an amount that's valid, we'll execute an else statement. where we're going to return, let's cut our return statement at the end, we'll return our amount. Now, when we call our method, we can delete this print line statement. If a user selects 2 to make a deposit, we're going to assign our balance variable. Balance equals our balance plus call the deposit method. Our deposit method is going to return a number, an amount. If it's valid, we're going to return it back to the place in which we call it. We will add this to our current balance and reassign it to balance. Our balance will equal our current balance plus the deposit that we make. We can shorten this too. We could just say balance plus equals deposit. Okay, let's do a test run. Banking program, let's show our balance. Our balance is currently 0. We'll select 2 to make a deposit. 2. Enter an amount to be deposited. Let's try and break it first. Let's say -$1 million. Amount can't be negative. Then we're brought back to the menu. Let's try and make a deposit again. Enter an amount to be deposited. Let's say $150 and a nickel, 5 cents. That seems to have worked. Let's show our balance again. And here's our new balance, $150.05. All right, the deposit method is done. We can collapse it. We no longer need to code within it. And now we need a withdraw method. We will declare a new method. It's a static method. We'll be returning a double. The name of this method will be withdraw. There will be one parameter. We will pass in a balance. Double balance. We do need to return something, so temporarily, just so our program runs correctly, I'm just going to return 0. We'll change that later. Within this method, I'm going to create a local variable of amount. Double amount. We will prompt a user. Enter amount to be withdrawn. We will assign our amount equal to, we're going to use our scanner. And remember, it's within the class scope, so we have access to it within this method. Scanner.next double to accept a double. If somebody tries to withdraw money that they don't have, we can check that within an if statement. If the amount is greater than our balance, we're passing in our balance so we know what it is. If somebody tries to withdraw $1 million but they have no money in their bank account, well, they can't do that. We will print insufficient funds. What if they try and withdraw negative money? We can check that within an else if statement. Else if our amount that the user types in is less than 0, we'll output amount can't be negative. Else if everything checks out, we'll return the amount. I will cut our current return statement. We will return the amount that the user types in. Return amount. So within our if statement, return 0. Within our else if statement, return 0. When we reach the end, we do need to return something, even if it is 0. And I'm going to use print instead of print line. So let's go back to our switch right here. We're going to be returning a double. We will take our balance equals, we're assigning it, take our current balance, minus, call the withdraw method. We have to pass in our balance, our original balance. From our current balance, we're subtracting the amount that we're withdrawing. We can simplify this expression too. We could say balance minus equals, then call the withdraw method. All right, let's do a test run. First, we'll make a deposit. I will deposit $100 to keep this simple. I will show our balance. We have $100. I will try and withdraw like a cajillion dollars. Insufficient funds. We don't have a cajillion dollars. Let's withdraw again. I will try and withdraw negative money. Negative $420.69. Amount can't be negative. We can't withdraw negative money. Okay, let's try and withdraw something that's valid. $50.01. That seems to have worked. Let's show our balance. Our balance is now $49.99. The last step is to exit and display a goodbye message. Let's print the following. Thank you. Have a nice day. Just so the user knows that they have exited the program. And for fun, I'm going to add some text decoration, some separators. Not necessary, but I think it'll look nice. Alright, let's run this one last time. Banking program, enter your choice. I will show our balance. We have $0. I will make a deposit. I will deposit $1,000. Show our balance. We have $1,000. I will withdraw. Let's withdraw a single penny, 0.01. Show our balance. We now have $999.99. I will press 4 to exit. And we exit. Thank you. Have a nice day. All right, everybody. That is a Java banking program that you can write as a beginner. Hey there, everybody. In this video, we're going to create a dice rolling program. A user is going to type in a number of dice they would like to roll. Based on the roll of each die, we will display some ASCII art. Then at the end, we will give the user a total, the sum of all the dice that they have rolled. So if that sounds good to you, let's begin. As a beginner, it might be helpful to you to break down a large project into smaller steps. Let's list the order of steps we're going to take. We will begin by declaring our variables. Declare variables. Then we need to get the number of dice from the user. After we have the number of dice, let's check to see if it's greater than 0. We don't want somebody rolling negative dice. Check if number of dice is greater than 0. We will roll all the dice, get the total, or the sum, you could say. The final part of this project, we will display the ASCII art of dice. Alright, here's a rough outline of our project. The first step is to declare our variables. We're accepting user input, so we'll need a scanner. Scanner equals new scanner. Type system.in, import this class, import java.util.scanner, and then close our scanner when we're done with it, scanner.close. We'll be working with random numbers. We'll need a random object to generate random numbers. Random equals new random. Import the class, import java.util.random. We'll need a number of dice. The user is going to fill this in. Int num of dice. How many dice are we rolling? And a total. Int total. We'll sum up all the dice for a total. Alright, now we need to get the number of dice from the user. We'll need some input, but we'll create a prompt first. Enter the number of dice to roll. I'll use print rather than print line. We will assign our variable of number of dice, num of dice. We will use our scanner to accept some user input. We are looking for an integer. We'll use the nextInt method of our scanner. Scanner.nextInt. Now, we need to check to see if the number of dice is greater than 0. So let's take care of that. We'll use an if statement to check that. If num of dice is greater than 0, then we'll roll some dice. We'll get to that momentarily. else we will print the following. Let's say number of dice must be greater than 0. Within our if statement, let's say, just temporarily, you roll the dice. Okay, we're doing a test run. Enter the number of dice to roll. Let's say I try and roll 0 dice. Number of dice must be greater than 0. Let's try this again. Let's say I roll 3 dice. And then we're just printing a test message. You rolled the dice. Okay, we know that that works. We can delete this print statement. We no longer need it. We were just testing it. Now we actually need to roll all the dice. We'll take care of that within our if statement. If the number of dice is greater than 0, then we will roll the dice. We're going to create a for loop that will iterate once based on the number of dice we have. So let's create a for loop. For int I will be our index. Int I equals 0. We will continue as long as I is less than our number of dice. Then increment our index of I by 1 during each cycle. Within this for loop, we're going to generate a random number. I will create a local variable of roll. Roll will equal. Now we'll use our random object to generate a random number between 1 and 6. We will use the next int method of our random object. We will specify our range, 1 through 7. The first number is inclusive. The second number is exclusive. This will give us a random number between 1 and 6 then. Once we have our roll, let's print it temporarily. Let's print you rolled, :space, plus our local variable of roll. Let's say we would like to roll 4 dice. You rolled 5, you rolled 5, you rolled 1, you rolled 2. Then we'll add these numbers together for a sum, or total. Let's take our total. Total equals our total plus our roll. And this is within the for loop. So Java does want us to initialize this variable. So set total equal to 0 when you declare it. So total equals total, whatever it currently is, in this case 0, plus roll. We can shorten this too. We could just say total plus equals roll. We'll use the augmented assignment operator for addition. Then when we escape the for loop, we will print the total. Let's say total, :space, plus our variable of total. Let's do a test run. I will roll 3 dice. We have 3, 2, 2, for a total of 7. 3, 5, 7. Okay, we know that that works. We have rolled all the dice and get the total. Now here comes the hard part. We're going to display some ASCII art based on the result of each die that is rolled. So we're going to declare a method to take care of that for us. Let's do so outside of the main method. We will create a static method that's not going to return anything. The return type is void. Let's name this method print die. Die is the singular version of the word dice. We're going to set up one parameter, int roll. What did we roll? We're going to call this method before we display the output of you rolled, whatever the roll is. We will call the method of print die and pass in our roll. It's going to be a number between 1 and 6. Let's head back to our print die method. Within the print die method, we're going to create some ASCII art. The ASCII art is going to be made of strings. Let's create a string of dice1 equals. Now, instead of a standard string that takes up one line, we're going to create a multi-line string. We need a triple set of double quotes. Anything between these two lines is a multi-line string. It's within here that we're going to create some dice, some ASCII art of dice. So this will be an art lesson today. Let's start with 7 dashes. On the next line, we'll create a vertical bar. And on the other side, we need a vertical bar too. I'm going to shift these dashes over by 1. Same thing with the vertical bar. We need another set of vertical bars, another set, and then we can copy our dashes again. So we should have a shape like this. Right in the middle, we're going to add a bullet point. The easiest way to do this is to pull up the char map application. So if you hold Windows and type R, you can look up char map. Hit enter. If you scroll all the way down to the bottom, and up a little bit, there should be a bullet point. Let's select it, copy it, close character map, and paste that bullet point. Or otherwise, you can find it from someplace else online. Let's print it just once. I'm just going to print dice 1. Let's do a test run. I'm just going to roll 1 dice. And this isn't going to be accurate right away, but we do have an ASCII art of a one-sided dice. Then we need dice 2. Really, we can copy everything for dice 1, paste it, change dice 1 to dice 2, and move this bullet point around. So this is dice 2. Then we need dice 3. Dice 3. There will be a bullet right in the middle. Dice 4. We need the bullets in each corner. And none in the center. That's dice 4. Dice 5. We'll have a bullet point right in the middle, along with the corners. And dice 6. We have 2 rows of bullet points. And those are the dice that we need. Now, we'll create an enhanced switch. What are we examining? So, going back to our parameters, right here, we're examining the roll that we pass in. It's going to be a number 1 through 6. We'll examine our roll against matching cases. If roll matches a case of 1, we'll do this. We will print, rather than print line, dice 1. Dice 1 is this image, this string. If roll matches a case of 2, we will print dice 2. If case is 3, we will print dice 3. 4, if case is 4, print dice 4. 5, print dice 5, and 6, print dice 6. And a default case. We might as well add one. If there are no matches, we'll print the following. We'll say invalid roll. Alright, and that's it. Let's run this. Enter the number of dice to roll. I'll roll 3 dice. And here's what we got. I rolled a 6, a 2, and a 6. Alright everybody, so that is a dice rolling program that you can make using Java. What is going on everybody? In this video I'm going to discuss arrays in Java. An array is a collection of values of the same data type. As a beginner, it might be helpful to think of an array as a variable that can store more than one value. It's a little more complicated than that, but that might be a good way to think of it. Let me give you a demonstration. Suppose we have a string variable, a fruit. Pick a fruit. I will pick an apple. And then, we can print our variable of fruit, which would give me an apple. Well, what if I told you that this variable can store more than one value if we were to turn it into an array? Here's how. After the data type of our variable, add a set of straight brackets. Enclose any values within a set of curly braces. And there we go. We now have an array. We have an array of strings. This array can store more than one value, but they all have to be the same data type. In this case, strings. Let's add some more fruit. Let's add an orange, a banana, and a coconut. The name of your array should be descriptive of what it contains. Let's say fruits instead of fruit. Technically, in the English language, fruit would still be plural, but by adding an S, it's more descriptive that it contains more than one value. I know, English is a weird language at times. If I was to print my array of fruits, here's the result. Well, we get a memory address. Arrays fall under the category of a reference data type. If we access the name of our array, we're given a memory address. Each value within an array is known as an element. To access an element, we have to indicate an index number. After our array name, let's add a set of straight brackets, and then an index number. As is the case with many things in programming, to access the first of something, it usually has an index of 0. That applies to arrays as well. Print our array of fruits at index of 0. That's going to give you the first element of apple. For the next element, that would be an index of 1, which is orange. 2 would be banana. 3, coconut. If we attempt to access an element that doesn't exist, here's what happens. We get an exception. An exception is similar to an error. We have an array index out of bounds exception. This error message appears when you try and access an element that doesn't exist within an array. There is no index of 4. There's only 0, 1, 2, 3 in this case. Now, you do have the capability to change the value at a given index. To do so, we will take the name of our array, in this case fruits, specify an index using the set of straight brackets. At index of 0, let's set that equal to a string of pineapple, rather than apple. And then we'll print it. Print our array of fruits at index of 0. That would give us a pineapple, rather than an apple. By specifying the index, you can change any element. So fruits at index of 1 is now a pineapple. If at any time you need the length of an array, there's a built-in property for that. Let's say we have an integer variable of num of fruits, meaning number of fruits. To access the length of an array, take our array, in this case fruits, use dot, which is the access modifier, then type length. Give me the length of my array of fruits. How many elements are within this array? Take a guess. 4. There's 4 elements within this array. 1, 2, 3, 4. If you ever need the length of an array, use the length property of your array. This will return an integer, which you can assign to a variable if you would like. If you need to print all of the elements of an array, you could use a for loop. Here's how. We'll declare a for loop. We'll create an index of I equal to 0. How many times do we want to iterate this loop? Let's continue as long as I is less than. We need to determine the length of this array. Well, we can use that length property that we discussed. Take our array of fruits, access the length property. This should return the number 4. Continue as long as I is less than 4. Then we will increment our index of I. So our for loop, in this case, is going to iterate 4 times. Let's perform a test run. If I was to print my array of fruits at index of 0, this is what happens exactly. It's going to print fruits at index 0 4 times. Apple, 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 apple. What I need is to print each element of this array. We could use our index of I for that, so replace 0 with I. I is going to change during each iteration of this loop. We're increasing it by 1 after we complete each cycle of the loop. So here's what happens now. We get all the elements of our array. Apple, orange, banana, coconut. This index of I is going to increase after each cycle of this loop, each iteration. Alternatively, Rather than printing each fruit on a new line, we could use print. Then after printing each element, we could add a space character. That would print each element and separate each with a space, if you so choose. There's something called an enhanced for loop. An enhanced for loop will cycle once for each element within an array. We'll start with a normal for loop. To create an enhanced for loop, within the set of parentheses, we will list the data type of each element of the array, in this case strings. Now we need a unique identifier for each element within this array. Since we're working with an array of fruits, let's say fruit, singular. Then we need a colon, then our array that we're iterating through, in this case fruits. Basically we're saying, for every fruit in my array of fruits, do this. Let's print each fruit. Fruit will be the current element we're cycling through. Here's what happens. We print each fruit. We have all the elements of our array of fruits: apple, orange, banana, coconut. This is an enhanced for loop, also known as a for each loop. It simplifies iterating through a collection, such as an array. If you need to sort your array, there's a built-in sort method. We're going to access the class of arrays. You may need to import it. Import class arrays. So make sure you have this import. Import java.util.arrays. This class provides a lot of functionality when working with arrays. There's a built-in sort method. We're going to pass in our array of fruits to this method. We'll end up sorting the elements in this array alphabetically. Originally, the order of our elements was apple, orange, banana, coconut. But after sorting, they're now apple, banana, coconut, orange. They're all arranged alphabetically. Or if these were numbers, they would be arranged in ascending order. There's also a fill method with arrays. We can fill all the elements of an array with a given value. Again, we're going to access the arrays class, call the fill method, pass in our array, comma, the value we're going to fill the array with. Let's fill our array with pineapples. Then we'll use a for each loop to print each element. And here's our new array. We have filled our array of fruits with the value of pineapple. Alright everybody, that's an introduction to arrays. Think of an array as a variable, but it can store more than one value. And well everybody, those are arrays in Java. What is going on everybody? In this video I'm going to show you how we can enter in user input into an array. So let's get started. Before assigning values into an array, our compiler needs to know the size of the array beforehand. We have to first allocate space for the array. Let's begin by creating an array of strings. We'll create an array of strings. We'll enter in some food. I will name this array foods. Equals, add a set of curly braces, and then within this array you can enter in some values. Pick some food that you like. I'll enter in a pizza, taco, and hamburger. The size of this array is 3 elements. Once you set a size for an array, normally you can't change it. This array will have 3 elements. However, all the elements are already filled with values. To create an empty array, you don't want a set of empty curly braces. Then we're creating an array of no elements. Just to demonstrate that, I'm going to print the length of our array foods. Foods.length. This is going to give us 0. And we can't assign any values. Even if I attempt to, let's say foods at index 0 equals a string of pizza. Here's what happens. Well, we have an exception, an array index out of bounds exception. Before assigning values, we'll want to be sure that we're setting a size of the array, even if it is empty. Instead of assigning a set of values, we'll create an empty array. We'll set our array equal to, use the new keyword, type the data type of our array, straight brackets, and within the straight brackets, we'll set a size, a number. So let's say 3. we're creating an empty array that has space for 3 elements, 3 values. Let's try this again. The length of our array is 3. And we can assign the values. So let's say foods at index 1 equals a taco. Foods at index 2 will be a hamburger. I'll print all the foods in this array. We can use an enhanced for loop. List the data type. We're working with an array of strings. For every food in our array of foods, we will print each food. That would give us pizza, taco, hamburger. We have declared and instantiated an empty array and filled in the values later. Let's modify this program so a user can type in some values. Let's delete these lines. If we're accepting user input, we will need a scanner. We'll declare that and instantiate it. Scanner equals new scanner. Within the set of parentheses, type system.in. Import the class for scanner. Import java.util.scanner. And close the scanner when you're done, because I sometimes forget to do that still. Scanner.close. So we have an empty array of 3 elements. We'll create a for loop to iterate over the length of our array of foods. So for, we'll create a counter of int I equals 0. We'll continue as long as I is less than our array of foods length property, which returns 3, because there's 3 elements. Then increment I by 1. During each iteration of this loop, let's do the following. We'll output the following prompt. Enter a food. I'll use print instead of print line because I prefer that. We'll assign our array of foods at index of I. I changes during each cycle. At first, it's 0, then 1, then 2, then 3. We'll set that equal to, use our scanner to accept some user input, call the next line method. Okay, let's perform a test run. Currently, we have an array with 3 empty elements. We'll cycle this loop 3 times, because the length property of the array is 3. Then print all the elements when we're done. Here's what happens exactly. Enter a food. Pizza, taco, hamburger. Here are the elements within our array of food. Pizza, taco, hamburger. Let's say that we change the size of the array. Let's say 4 this time. Pizza, taco, hamburger, hot dog. Pizza, taco, hamburger, hot dog. We're going to make a few changes. Instead of setting a static size for the array, we'll have a user enter in the number of food they would like to enter. We'll replace this number with a variable to determine the size. What we'll do now is we will declare our string array of foods, but instantiate it later once we know the size. We'll output, what number of food do you want? I'll use print instead of print line. I'll also create an integer variable of size. I'll declare it, but not yet fill it in, until after our prompt. Let's set the size of the array that is, equal to, use our scanner, and call the next int method. We are accepting an integer. Once we know the size of the array, we can finish instantiating it. Let's take our array of foods that we've declared, but have not yet assigned, and we'll assign it. Our array is made up of strings. We'll use the new keyword, new, list the data type, string. It's an array, so we need a set of straight brackets. And instead of a number, we're going to use our variable. The user is going to determine what this number is going to be. There's one final step. This is specific for scanners. Since we're accepting an integer, and then we're accepting a string for our user input, we have to clear the input buffer. Next integer isn't going to pick up the new line character at the end. So just to demonstrate that, let's say we want one food item. There's still that new line character within the input buffer. We didn't get the opportunity to enter in a food. We are just going to clear our scanner by using scanner.nextLine, and that will clear it up. All right, let's try this again. What number of food do you want? I want 5. 5 food items. Enter in some food. Pizza, taco, hamburger, hot dog, and sushi. And here's our food. Pizza, taco, hamburger, hot dog, sushi. In summary, to enter in values into an array, you'll likely want to create an empty array, but you need to know the size of the array first. If the size of the array is predetermined, you can always set that to be a number. Otherwise, if one way or another, if a user is going to determine the size of the array, you'll have to get that from the user, and you can set the size of the array to whatever the user types in. Just be sure to do that before filling in the values. If you would like a copy of this code, you can look in the comments section down below. Be sure that you're looking in the playlist. And well, everybody, that is how to enter in user data into an array using Java. What is going on, everybody? In this video, I'm going to show you how we can search through the elements of an array. Let's begin. We'll need an array to work with. To keep this simple, let's create an array of integers. We'll create an array of integers named numbers. Equals, make up some numbers to put within this array. I'll just type whatever comes to mind. Good enough. We'll also need a target. What number are we searching for? Let's say I'm searching for the number 2. I will create an integer variable of target, set it equal to 2. In data structures and algorithms, we'll be performing what is known as a linear search. We're going to use a for loop to iterate through these elements, and then see if there's a match. We'll create a for loop, create an index of I. I will equal 0. We'll continue as long as I is less than our array of numbers, access the length property. That will return the length as a number. Then increment I by 1. I will check using an if statement if our target is equal to our array at the current index of I. At first, I will be 0, and then we increment it during each cycle of this loop. If our target equals the current element, let's print the following. Let's say element found at index plus I, that's our index. In case we find the target, for example 2, we don't need to search through the rest of the array. We could add what is known as a break statement to break out of the loop. If we find the target, break out of the loop. Let's perform a test run. We're searching for the number 2, and we'll be given the index, element found at index 2. Let's look for 1. 1 is found at index 0. 4, which is near the end, is found at index 6. 0, 1, 2, 3, 4, 5, 6. What if we don't find our target? I don't have the number 7 in here. Well, there's no output. Since this if statement is never true, once we reach the end of the array, we don't do anything. So let's add a Boolean variable of isFound and set it to be false. We'll check if isFound is false. If that is the case, we'll output a message that element wasn't found in the array. So if we do find our target, we'll take our Boolean variable of isFound and set it to be true. We have found our target that we're looking for. If we exit the for loop and never find our target, we can check that. We'll say isFound, but we'll use the not logical operator. The not logical operator gives you the inverse of a Boolean value or variable. If isFound is false, if something isn't true, if we don't find the target, then we execute this if statement, where we will print the following. Let's say something such as element not found in the array. Alright, we are looking for the number 7, which does not exist within this array. That would give us this message, element not found in the array. Because isFound was false, we could never find it within this for loop. So we're checking if isFound is not true. What if we have an array of strings and we're searching for an element? Well, instead of using the comparison operator, we have to use the equals method of strings, because strings are a reference data type. So this time, let's say we have an array of strings named fruits. Think of some fruit. I will pick an apple, an orange, and a banana. The target this time will be a string. Let's say I'm searching for an orange. We'll iterate through our array of fruits. The condition for the for loop will be I is less than the length of our array of fruits. Now we can't necessarily say, is our target equal to fruits at index of I? We're comparing two strings, and since strings are reference data types, we would end up comparing the memory addresses of two different strings. We would be saying, are these two memory addresses the same? Are they at the same location? Which isn't the case. If we're comparing the value of strings, we'll use the equals method. Let's take fruits at index of I, call the built-in equals method of strings, and pass in our target as an argument. Now this should work. We are searching for an orange. Element found at index 1. What about a pineapple? Element not found in the array. There was no pineapple. Let's modify this program slightly. We'll accept some user input, but we'll need a scanner. Import the class, java.util.scanner, and close your scanner when you're done with it. Scanner.close. Instead of assigning our target, we'll accept user input. We'll use our scanner, use the next line method, and we will also need a prompt. Let's print the following. Enter a fruit to search for. Just to make this a little more clean, I'm going to move this variable of isFound to the top here. I'll declare our string of target, but not assign it. And then after the prompt, I'll assign our name of target. This is just how I like to arrange things. But it all works the same. Now we can search for an element after accepting user input. And I will convert this to be a print statement instead of print line. Alright, let's search for some fruit. Is there a coconut? Element not found in the array. Perhaps a banana. Element found at index 2. 0, 1, 2. Alright everybody, so that's how to search through an array using Java. Hello everybody, in this video I'm going to explain variable arguments, also known as varargs, in Java. Variable arguments allow a method to accept a varying number of arguments. They make methods more flexible, and there's no need for overloaded methods. Overloaded methods are methods that share the same name, but have different parameters. In this example, I have several add methods. They each have different amounts of parameters. If I was to add a few numbers together, for example, I'll add 1 plus 2 plus 3, well then I would use this method. What if I told you instead of creating several different methods that basically do the same thing, we could instead create one method that accepts any number of arguments? We'll only need to declare one method. We will create one add method that accepts a varying amount of arguments. So let's create a method. The return type, let's say, is an integer. We'll create a method of add. Our method will have one parameter. What is the data type of the values we're sending this method? In this case, integers. We're going to follow the data type with 3 dots, an ellipsis. How this works is that the Java compiler is going to pack the arguments we send it into an array. We'll need a name for this array. Let's say numbers. Just to demonstrate this temporarily, I'm going to print my array of numbers. When we call the add method, we can send any number of arguments. For example, 1, 2, 3, 4. And they're going to be packed into an array. Within this method, we're now working with an array. Let's perform a test run. Let's return void, actually. So we're given a memory address of this array. Now let's actually add these numbers together. We need to cycle through the elements of this array. We can use a for loop or an enhanced for loop for that. So let's return an integer in this case. Let's declare a local variable of sum. I will set that to be 0. Let's create an enhanced for loop. The data type will be int for every number in my array of numbers. Let's take our sum and add the current number. Sum plus equals number. Then at the end, we will return our sum. And there we go. And then we need to print the output. I'm going to cut this and paste it within a print statement. Let's perform a test run. The sum, when we add these 4 numbers together, the sum is 10. And we can pass in any number of arguments. The result is now 21. Basically, the Java compiler is packing all of these arguments into an array when we send them to a method. Then within the context of this method, we would just need to work with this array, one way or another. But it's a lot easier than having several different overloaded methods. Okay, this time let's create a new method. We'll create a method of average. Average will find the average value of whatever we send it. So we will create a static method that's going to return a double this time. The method name will be average. What is the data type of what we're sending? Let's say double. Then we need the ellipsis, the 3 dots, then a unique name for this array. Let's say numbers. So to find the average, we can perform the following code. Let's say we have double sum. I will set that equal to 0. We will create an enhanced for loop. The data type is double. For every number in my array of numbers, do the following. We will take our sum and add the current number. Sum plus equals number. Then at the end, we will return sum divided by. Now, since we're working with an array, there is a built-in length property, numbers.length. To find the average, you take all the numbers, add them together, then divide it by the amount of numbers that you have. Let's perform a test run. I'm going to print, call the average method. Let's find the average of a few numbers. I don't know what that's going to be. So the average of these 4 numbers is 2.5. I can pass in any number of arguments. So the average of these numbers is 4.0. You can even pass in no arguments if you so choose. But with this method that we have created, here's what happens. We're actually dividing by 0 because the length of our array is 0. There's no elements that we're passing in. In this specific example, let's create an if statement. If our array of numbers, if the length of it, we can access the length property, is equal to 0, let's return 0 instead of receiving not a number. We're calling the average method, but passing in no arguments this time. That would give us 0, because the length of our array is 0, because we're passing in no arguments. Alright everybody, so those are variable arguments. They allow a method to accept a varying number of arguments. It makes methods more flexible, and there's no need for overloaded methods. The Java compiler will pack the arguments into an array. When setting up the parameters of a method, Declare the data type and add a suffix of an ellipsis, 3 dots. And well, everybody, those are variable arguments in Java. Hey there, everybody. So today I'm going to explain 2D arrays in Java, also known as multidimensional arrays. A two-dimensional array is an array where each element is an array. It's useful for storing a matrix of data. Let me give you an example. Let's say we have some basic one-dimensional arrays. I will create a string array of fruits. Think of some fruit. I'll add an apple, an orange, and a banana. Then I'll create another separate array. Let's create a string array of vegetables. Think of some vegetables. I will add a potato, an onion, and a carrot. Let's create one more. I will create a string array of meats. I will add chicken, pork, beef. Let's add one more, and fish. These 3 arrays are all separate one-dimensional arrays. Well, what if I told you we can make an array made of arrays, where each element is an array? Here's how. We're going to combine all these arrays together into a grid or matrix. I will create a 2-dimensional array of strings. We will need 2 sets of straight brackets. I will name this 2-dimensional array groceries. And then we need our curly braces. This 2-dimensional array, each element within this 2-dimensional array, is going to be an array. We have fruits, vegetables, and meats. Let's attempt to display these elements. You can use a for loop or an enhanced for loop. Within this for loop, what is the data type of each element? Well, each element is a string array. So we need to list the data type as a string array. Let's give a nickname of each element as foods in our 2-dimensional array of groceries. Let me show you what happens if I print each element within our 2-dimensional array of groceries. I will print each array of foods. Here's what we got. Well, we get a bunch of memory addresses because arrays are a reference data type. We're referring to some place in memory. We'll need to use a nested loop. An enhanced for loop would be good for this. With each of these arrays, what is the data type of each element within each? Well, we're working with strings, so the data type is going to be string. Let's give a nickname of each element as food in our array of foods. During each cycle of this loop, let's print, not print line, each food, and then I'll add a space. Here's what we got currently. We have our first array, and our second, then third. After finishing each array, I'm going to add a new line character. We can use a print line statement for that. Here's what we got now. What we have is a grid or matrix of data. You could say that there's columns and rows. Each row is a separate array. Now, when initializing an array, you don't necessarily need names. Let's remove fruits, copy the elements of this array, including the curly braces, and paste them within this 2-dimensional array. Just for readability, I'm going to place each row on a new line. Let's replace vegetables with the elements, including the curly braces. Same thing applies with meats. And we can delete all this. This would work the same. Groceries is a matrix of data, a grid. Let's print this. And that works the same. If you ever need to access or change an element, you'll need to use 2 indices. For example, let's replace apple with a pineapple. we will take our two-dimensional array of groceries and list two indices. The first index applies to the row. The second index applies to the column. So we're saying at row 0, column 0, we can change it or access it. Let's say that row 0, column 0 is now a pineapple rather than an apple. Then we have pineapple, orange, banana. Let's replace our potato with something else. That would be row 1, column 0. Row 1, column 0 is now celery. Celery, onion, carrot. Let's replace the carrot with celery then. That would be row 1, column 2. 0, 1, 2. Row 1, column 2. Potato, onion, celery. Let's replace pork with eggs. That would be row 2, 0, 1, 2, column 1, 0, 1. Row 2, column 1 is now eggs. We have chicken, eggs, beef, fish. To access or modify an element within a 2D array, you need to list two indices. The first for the row, the second for the column. Okay, now we're going to create a mini project. We'll create a two-dimensional array that resembles a telephone number pad. This two-dimensional array will be made up of characters. The data type is char, and then we have two sets of straight brackets. Let's name this two-dimensional array telephone equals, we have an array of arrays. We'll have 4 rows. And just for readability, I'm going to place each of these on a new line, just so it resembles a grid or matrix. For the first row, we'll have 1, 2, 3. And these are all characters, not strings. We're using single quotes, not double quotes. For the second row, we'll have 4, 5, 6. The third row will be 7, 8, 9. Now for the last row, we'll have an asterisk character, 0, and pound, or hashtag as I like to call it. So here's our matrix, our grid of characters. We have an array of arrays. It has rows and columns. Now let's display our data. We'll need nested loops for this. Our outer for loop is going to be in charge of the rows. What is the data type of each element within this two-dimensional array? Well, each row is an array of characters. That's going to be the data type of the outer for loop. We have an array of characters. Let's give a nickname of each inner array as a row in our two-dimensional array of telephone. For every row in our telephone, do this. Then we'll need a nested loop. What is the data type of each element within each array? They're characters. The data type will be char. Let's say for every number in each array of row, we'll print the following. We'll use print rather than print line. We'll print each number, and I'll add a space character. Let's do a test run. After each row, I'm going to print a new line character. So when we escape the inner for loop, I'll add an empty print line statement. And here's our telephone. We have rows and columns. It's a two-dimensional array of characters. So those are two-dimensional arrays. They're an array where each element is an array. It's useful for storing a matrix of data. We probably won't be using 2D arrays too often, but you should still be familiar with them. And well, everybody, those are two-dimensional arrays in Java. Hello everybody, in this video we're going to create an interactive quiz game using Java. For this project, you'll create an array of your own custom questions, and a two-dimensional array of all the different options for answers that we have. You'll type in a number 1 through 4 depending on your guess. After all of the questions are answered, we will display a final score, depending on the amount of correct guesses that you have. So let's begin. As a beginner, it might be helpful to you to break down your project into different steps. As comments, we'll list all of the different steps we need to take to get this program up and running. The first thing that we need is an array of questions. Questions will be an array. We will also need options. Options will be a two-dimensional array. We will declare our variables. We'll need a welcome message. We will list each question using a loop. I'll just write in parentheses that we will use a loop. Now within this loop, we're going to do a few things. We will list our options, then get guess from user, then check our guess to see if it's correct. At the end of this program, we will display final score. So here's a rough outline of our project. We'll fill this project in one step at a time. Let's begin with creating an array of questions we'll ask the user. The data type will be a string array of questions. Here's where you're going to ask all of your questions. In this project, we'll have 5 questions. They're all going to be very long strings. For our first question, you don't need to type in the same questions that I do. Feel free to come up with your own. Here's a few that I've looked up online. My first question will be, what is the main function of a router? That'll be the first question. I'll put each of these questions on a new line just for readability. The second question will be, which part of the computer is considered the brain? Then I'll go to a new line. What year was Facebook launched? Who is known as the father of computers? Then for my last question, what was the first programming language? All right, here are the questions. Questions is an array of strings, a one-dimensional array. Now we'll create a two-dimensional array of options. We will create a two-dimensional array of strings, named options. We have 5 questions. That means we need 5 arrays. 1 array for each question. I'll place each of these on a new line for readability. Our first array within our 2D array of options will hold all of the options for our first question. Each value within this first array is going to be strings. And I'm going to zoom in a little so we can both read it. What is the main function of a router? Here's where you're going to list all of the different possible answers, but only one of them is going to be correct. I'll say 1 dot space storing files. For option 2, that will be encrypting data. Option 3 will be for directing internet traffic. This will be the correct answer, number 3. Number 4 will be managing passwords. This will be my first array. All the options for question 1. Now for question 2, For question 2, we'll have 4 options. Honestly, I'm just going to copy these and then paste them within each array, just to speed things up. What part of the computer is considered the brain? Here's the different options. Option 1 will be CPU. That's going to be the correct answer. The central processing unit. 2, hard drive. 3, RAM. 4, GPU. Question 3. What year was Facebook launched? Option 1 will be 2000. Option 2, 2004, and that's the correct answer. 2006 or 2008. Who is known as the father of computers? Let's say Steve Jobs, Bill Gates, Alan Turing, or Charles Babbage, and that's the correct answer. What was the first programming language? Either COBOL, C, Fortran, or assembly. The correct answer is actually Fortran. It's the first commercially available programming language. One more thing, we're going to create a one-dimensional array. What are the correct answers? We'll need some sort of key. We could include this with our declare variable step. We will create an integer array of answers. We will list the correct answers as integers. The correct answer to question 1 is directing internet traffic. So we will list 3. For the next question, what part of the computer is considered the brain? That is the CPU. Option 1. Facebook was launched in the year 2004. That's 2. Who is the father of computers? That is Charles Babbage. That's 4. And the first commercially available programming language is Fortran. That is 3. Here are the correct answers. Our key. There's a few more variables we'll need. We will create an integer variable of score. We can set that to be 0 if we would like. And an integer of guess. Guess is going to store whatever the user types in, 1 through 4. So it's going to be an integer. We will also need a scanner to accept user input. Scanner equals new scanner. It doesn't really matter where we declare it, just as long as we declare it before we use it. System.in, and then we will import this class. Import java.util.scanner, and then close our scanner at the end of our program when we're done with it. Scanner.close. Alright, here are the variables we'll need, including our options and our questions. Our next step is to create a welcome message. Let's output the following. Let's say, welcome to the Java quiz game. And then I'll add some separators. A bunch of asterisks, because I think it'll look cool mostly. We have our welcome message, and I'll just perform a test run. It's a good idea to test your code as you're coding it, just to be sure that everything is working fine. And that is our welcome message. Now we'll loop through all of the questions that we have. We'll probably want to use a for loop. We will create an index of I. Int I equals 0. We'll continue this loop as long as I is less than the length of our array of questions. Questions access the length property, which will return a number, in this case 5, because there's 5 questions. We will increment I by 1. As a test, let's print our questions at index of I. I will start at 0, so we're returning the first question at index 0. Then during each iteration of this loop, we will display each question. Let's do a test run. So here are the 5 questions. We're displaying each element of our array of questions. After each question, we have to list all of the different options. That's the next step. We'll display a question, then create a nested loop to display all of the options. I'm going to use an enhanced for loop for this. What is the data type of each value within each array within options? Well, we're working with strings. The inner for loop is going to be an enhanced for loop. The data type of each value is a string. String option, colon, meaning in, array of options at index of I. Options is a two-dimensional array. If we retrieve a value at a given index, we'll be given an array. Display every option in each inner array. So to demonstrate that, let's print each option. So here's what we have. After printing each question, we will loop through and print all of the options. Now, before moving on to the next question, we have to get some user input. We don't want to display all the questions right away, just one at a time. So we will do this within the outer for loop, after printing all of the options. This is where we will get the guess from the user. We will create a prompt to enter your guess, and I will use print instead of print line because I like the user input on the same line. We will assign our variable of guess. Guess equals scanner dot next int. The user is going to type in a number 1 through 4. Then we have to check our guess. Is it correct or not? We can do the following. We'll use an if statement. If our guess is equal to our array of answers, it's a one-dimensional array, at index of I. We're using the index of I because we're still within our for loop. During the first iteration of this loop, I will be 0. So is our guess equal to answers at index 0? If that is correct, let's print the following. Let's say correct. And for fun, I'll add some text decoration. Some of those separators. Again, it's not necessary. I just think it'll look cool. Else, if our guess doesn't equal our answer, well, we can check that with an else statement. If we don't have the correct answer, that means we have the wrong answer. And I will output wrong. And I will just space this out a little bit. All right, let's do a test run. For the first question, the correct answer is 3. I'll type in 3, then we print correct. Which part of the computer is considered the brain? I will intentionally get this wrong. Let's say the GPU. Wrong. And I'll guess the others. Wrong, wrong, wrong. Then we have to calculate a final score. Okay, then we have to display the final score. So after we get the correct answer, we will increment our score by 1, score plus plus. Then we will display the final score. Your final score is... I'll use string concatenation to keep this simple. We'll add our score variable plus the words out of plus we're going to get the length of our questions. Questions is an array. Questions.length property. I'm just going to add a space right before out because I'm forgetting that. Let's run this one last time. What is the main function of a router? That is 3, directing internet traffic. Which part of the computer is considered the brain? That is the CPU. What year was Facebook launched? I'm going to get this one wrong intentionally. I'm going to say 2000. And that is wrong. Who is known as the father of computers? That is Charles Babbage, 4. What was the first programming language? Well, the first commercially available programming language. That would be 3, Fortran. Correct, your final score is 4 out of 5. Alright everybody, so that is an interactive quiz game that you can create using Java. What is going on, everybody? In this video, we're going to create a game of rock, paper, scissors for beginners. So let's get started. As a beginner, when creating a project, it could be helpful to you to break down a project into smaller steps. Just as comments, I'm going to list the different steps that we'll need to take. So let's say first we will declare our variables, then get a choice from the user, get random choice for the computer, check win conditions, who won, ask to play again. Then at the end, we will display a goodbye message. It may be helpful to you as a beginner to list the different steps that your program is going to take, just for more organization. Alright, let's work on step 1. We will declare our variables. We'll need a scanner because we're accepting user input. Scanner equals new scanner. Within the set of parentheses, we will type system.in. Import the class for scanners. Import java.util.scanner. And then we will close our scanner when we're done with it. Scanner.close, because we don't want to leave any resources open. We will be generating random numbers. We will need to create a random object. Random equals new random. And then import this class as well. Import java.util.random. We're going to create an array of choices. They will be strings, rock, paper, or scissors. We will create a string array named choices equals an array. This will be an array of strings. At the first index, we'll have rock, then paper, then scissors. We'll store our choice within a variable. This will be a string. We'll name this variable player choice. I will declare this variable, but not yet assign it. And the computer's choice. String computer choice. We're going to create a while loop that will ask the user to play again when they reach the end. We'll create a string variable of play again, and I will set this to be yes. Basically, while play again is yes, continue the game. Let's work on our next step, get the choice from the user. We need to prompt the user. We'll use a print line statement and say, enter your move. We'll add a set of parentheses that says rock, paper, scissors, just so the user knows what to type in. I'll use print instead of print line, because I prefer user input on the same line. Once we have our prompt, we're going to assign our player choice variable. Player choice equals, we will use our scanner to get some user input. We need to accept a string so we can use the next line method to accept a line of text. In case a user types in any uppercase characters, for example, rock, we could follow this with the to lowercase method, just to make it all lowercase, whatever the user types in. Accept the next line of user input, then make it lowercase, just for consistency. Now we should have our player choice. We need a way to determine to see if this user input is valid. Did the user pick rock, paper, or scissors, or something else entirely? Well, we could use an if statement for that. We're going to be checking to see if our player choice doesn't equal rock, and doesn't equal paper, and doesn't equal scissors. So we can write the following statement. We're going to use the not logical operator first. Not will give you the opposite, the inverse. If player choice, use the equals method, pass in a string of rock. If the player's choice doesn't equal rock, then we'll use the and logical operator. And the player's choice doesn't, again I'm using the not logical operator, equals paper. Again, we're going to use the and logical operator. And just to help with readability, because we're going to have one really long line, I'm going to place these conditions on a new line each. This will help with readability. And take our player choice, not equals scissors. We're linking three conditions together if our player choice doesn't equal rock, and our player choice doesn't equal paper, and our player choice doesn't equal scissors. If all of these conditions are true, that means the user didn't type in something that's valid. So let's do the following. Again, I'm within my set of curly braces. We'll output the following. We'll say something like invalid choice. All right, let's perform a test run. Enter your move, rock, paper, scissors. Let's choose rock. Nothing happens, that's good. Paper, nothing happens. Scissors, nothing happens. All right, I'm gonna type in something that's not rock, paper, or scissors. I choose the gun. Invalid choice. That's good, that's what we want. We're picking something that's not rock, and is not paper, and is not scissors. So we execute this if statement if that's the case. Now for the next step, we have to get a random choice for the computer. We don't need user input this time. We will assign our variable of computer choice equals access our array of choices at a given index. 0 would be rock because it's the first value in our array. 1 would be paper, 2 would be scissors. Well, why don't we use our random object, random, and call the next int method. Then pass in 3. This method of our random object would return a random number between 0 and 2. 0 for rock, 1 for paper, 2 for scissors. Then we'll output it using a print line statement. Let's say computer choice, colon space, then add our variable of computer choice. Let's do a test run. I'll type in rock. The computer picks paper. I will pick paper. The computer picks scissors. I will pick scissors. The computer picks scissors as well. All right, we know that that works. Using this method of our random object, we're generating a random number as the index. Now here's the tricky part. We have to check all the win conditions. I feel like the best way to handle this would be to create an if statement, followed by an else if statement, followed by an else statement. Within our if statement, this will be for a tie. Let's output the following. It's a tie. Our else if statement will be used if you win. We'll output you win. Else will be used for you lose. You lose. If we have a tie, that means the player's choice is equal to the computer's choice. That's how you get a tie. Within the if statement, we can check the following condition. If our player choice variable use the equals method of strings, then pass in the variable of computer choice. We're comparing two strings. They're reference data types, so we're going to use the equals method. You can't use double equals because then you're comparing memory addresses of two different strings. We're going to be using equals, the equals method. If these two strings are equal, we'll print it's a tie. Now for the win conditions, within this else if statement, this is where things are going to get kind of tricky. We're going to list all of the different win conditions within our else if statement. First, we'll check if the player picks rock and the computer picks scissors. If our player choice use the equals method, if the player picks rock, a string of rock, and the computer's choice equals, let me zoom out a little bit, scissors. That means we win. Within our condition of our else if statement, we'll be adding the different win conditions, but temporarily I'm going to add a few else if statements just to help me explain this. So if we pick rock and the computer picks scissors, that means we win. But we will also win if the player picks paper and the computer, let's add that right here, picks rock. That means we also win. And then temporarily, I'll add another else if statement. Else if the player picks scissors and the computer picks paper, that also means we win. We could condense all of these else if statements into one, but we'll do that in a moment. I just want to be sure that it all works first. Let's do a test run. I will pick rock. The computer picks scissors. That means we win. I will pick paper. The computer picks paper. It's a tie. I'll keep playing until I lose. I will pick scissors. The computer picks paper. We win. Let's try scissors again. The computer picks rock. We lose. We know that these different win conditions are working. This is fairly readable, but if you prefer, we can condense all of these steps down together into one else if statement. Optionally, what you could do with our first win condition, let's enclose them within a set of parentheses. Then I will use the OR logical operator. Let me zoom in so you can see it. I'm adding OR to the end. Or, let's take the entire condition within our else if statement, then paste it after the OR logical operator. And these do need to be enclosed within a set of parentheses. And we can delete this else if statement. We'll add the OR logical operator to the end. Cut this condition for the next else if statement, and delete this else if statement. And paste it. So here's our else if statement. There is a lot going on here. This should work too, but if you prefer to keep it the other way just for readability, feel free to do so. If you like to condense some of the code, here's how you could do that. So let me just be sure that everything's working fine. I will pick rock, computer picks rock, it's a tie. I will pick paper, computer picks scissors, you lose. I will pick scissors, computer picks paper, you win. Alright. This else if statement does work. Again, if you would prefer to add more else if statements, feel free to keep it the other way. Now we need to ask the user if they want to play again. After displaying either it's a tie, you win, or you lose, we'll add a prompt. I will use print instead of print line. I'll ask play again. Yes/no. We have one variable we haven't used yet, our play again variable, and currently it's yes. Play again equals use our scanner, use the next line method, and I will take the user's input and make it lowercase right away. To lowercase method. We're going to enclose all of our code right before the variables within a loop, a do-while loop. So we'll say do all this code while some condition remains true. Let's cut all of our code, cut it, and then paste it within this do-while loop. So with the do-while loop, we do all of this code once, and then check the condition at the end. What's our condition going to be? We'll continue playing while our play again variable equals a string of yes. Play again equals yes. One more change we're going to make. If the user picks something that isn't valid, we're going to skip the current iteration of this loop. We can use continue for that. We want to go back to the beginning if a user types in something that isn't valid. Then the last step is to create a goodbye message. We're doing this outside of the while loop, because when we're outside of the while loop, that means we're no longer playing. Let's print the following. Thanks for playing. All right, let's run this one last time. I will pick rock. Computer pick scissors. You win. Play again. I'm going to type yes. Enter your move. I will pick paper. Computer picks rock. You win. I will play again. I will pick scissors. The computer picks rock. You lose. I'm going to type no to play again. And we escaped that do while loop. Thanks for playing. Alright everybody, so that is a game of rock, paper, scissors you can make using Java. Hello everybody, in this video we're going to create a slot machine program using Java. A user is going to bet an amount. For the symbols of our slot machine, we'll be using emojis. If a user gets any matching symbols, they'll receive a payout. Then at the end, we'll give a final balance. If that sounds good to you, let's get started. Alright everybody, when working on a project, it might be helpful to you to tackle your project one step at a time. As comments, we'll list the different steps that our program is going to take. This will give us a rough outline of our project. The first thing we'll do is declare our variables. Then display a welcome message. Display welcome message. We will play if our balance, meaning the money that we have, is greater than 0. If we don't have any money, we can't play. It is a slot machine after all. A user is going to enter bet amount. Then I'll write a few sub-steps underneath here. We need to verify if the bet is greater than the balance. You can't bet money that you don't have. Then verify if bet is greater than 0. You can't bet negative money, so we'll need to check that. Then subtract bet from our balance. Once we subtract the bet from the balance, then we will spin our row. Our row is going to contain emojis, but we'll need to display it. We'll create a method to print our row of emojis. Once we display our row, we need to get a payout if we win something, if we have any matches. Then ask to play again. If the user doesn't want to play, we will display an exit message. Display exit message. So here's a rough outline of our project. We will begin by declaring our variables. We will be accepting user input. We'll need a scanner for that. Scanner equals new scanner. Type system.in within the set of parentheses. Import this class. Import java.util.scanner. Then when we're done with our scanner, we'll want to close it. Scanner.close. We'll need a balance. How much money do we have? I will set that to be 100. 100 as in $100. This could also be done with other units of currency. We'll need an amount for our bet. Int bet. How much are we betting? How much are we risking? Int payout. How much money do we win? We'll be adding our payout to our balance if we win. And a string array named row. Our row is going to contain our symbols, our emojis, that will display to the output window. That's why we're creating a string array, to store all of them. Here are the variables we'll need. We'll move on to the next step. Our next step is to display a welcome message. Let's say something like this. I'll use a print line statement. We'll say, welcome to Java slots. Underneath this line, we'll add another print line statement. I will print the word symbols, and here we'll list all of the different symbols we would like to use within our program. I'll be using emojis. To pull up the emoji menu, if you're on Windows, hold down the window key, then hit the semicolon button. So pick some emojis that you like. Here's a few that I typically see. Cherries, watermelon, lemons, bells, and stars. If you would like to stick to a certain theme, feel free to change these. But these are a few symbols you may see on a slot machine. And I'm just going to work on the spacing a little bit. That looks pretty good. Just to make this a little more fancy, I'm going to add a bunch of asterisks as separators before and after. Not necessary, I just think it looks cool. And that's a good enough reason. Let's perform a test run just to be sure that this looks fine. I think that looks pretty good. Alright, we have our welcome message. Our next step is to play our game if our balance is greater than 0. This can be done with the while loop. While our balance is greater than 0, we will continue playing. Then we have to enter the bet amount. That's the next step. First, we'll display our current balance. Current balance, colon, space. Pick unit of currency. I'll pick American dollars. Plus, we will display our balance variable. We will ask a user for some input. Place your bet amount. I'll use print rather than print line because I like the user input on the same line. We will assign our bet variable, use our scanner to accept some input. Let's say next int. We won't deal with cents, we'll just bet whole dollars. Then we have a couple sub-steps. We have to verify if our bet is greater than our balance. We'll write an if statement. If bet is greater than our balance, we'll output the following. Let's say insufficient funds. We'll want to skip the current cycle of this loop. We'll use continue to go back to the beginning. Then we'll verify if the bet is greater than 0. We don't want a user to bet negative money. Else if our bet, let's say less than or equal to 0. We don't want a user betting no money. Bet must be greater than 0. Else we have to subtract the bet from the balance. We could say balance equals balance minus bet. But we can shorten this using the augmented assignment operator. We can say balance minus equals bet. Within our else if statement, we're going to use the continue keyword to skip the current iteration of this loop. So temporarily within my else statement, I'm just going to print our balance right after, just to be sure that it's all working. Let's do a test run. Okay, welcome to Java Slots. Current balance, $100. Place your bet amount. I will bet money that I don't have, $1 kajillion. Insufficient funds. Current balance, $100. Place your bet amount. We can't bet negative money. I'll bet negative $1. Bet must be greater than 0. Then we're brought back to the beginning. I will bet $10. And our new balance is $90. Alright, we know that that works. We can delete this print line statement. We no longer need it. We were just testing something. Our next step is that we're going to spin our row of symbols, our emojis. After we subtract our bet from our balance, it's here that we'll spin our row. First, I'll print the following message. Let's say the word spinning. Then we will call a method to spin our row. But we will need to declare this method. We will do that outside of the main method. This will be a static method. The return type is going to be an array of strings. String array. And the name of the method will be spinRow. We'll be creating a few local variables within this method. But first, we do need to return something, because we promised that we're going to return a string array. In order for this program to run and compile fine, I will add the following return statement. Return a new empty array of strings. We'll be replacing this later, but we do have to return something in order for this method to at least work. We'll be creating a few local variables. The first is a string array named symbols. equals, then within a set of curly braces, we need our emojis. Let's go back to the beginning, copy our emojis, then place them within this array. They do need to be surrounded with a set of double quotes because this is an array of strings. So let's take a moment to take care of that. Alright, that is good. We will declare a string array named row. Our row is going to be empty. It's going to be a new string array that can hold 3 elements. Row is an empty array that can hold 3 strings, which will be picked at random. We will be generating random numbers. We need a random object. Random equals new random. Then import this class. At the top, import java.util.random. Temporarily, there's something I'm going to demonstrate. Let's display our array of symbols at index of 0. That should output this first emoji, a cherry. I'll just bet $1, doesn't matter. And we have our cherry. 1 should be our watermelon. Watermelon. Then 4 should be our star. Star. We need to choose a random number between 0 and 4. When we select our array of symbols, within the straight brackets, where we list an index, we will take our random object, call the nextInt method. We will generate a random number between 0 and 5. The first number is inclusive, the second number is exclusive. If your range starts with 0, you don't technically need this first number, you could just say 5. Let's run this a few times just to see what happens. So that time I got a bell, a cherry, and a watermelon. If we have more or less emojis, we would need to change this number. Why don't we use the length of our symbols instead? Symbols, then give me the length property of this array. If we were to add more or less symbols, our length is going to change automatically when we run and compile this program. So we'll do a test run again. And that seems to work. We are getting a random symbol each time. Let's delete the print line statement portion of this. We need to generate 3 random symbols. We can use a for loop for that. For int I equals 0, we will continue as long as I is less than 3. Then increment I by 1. We will take our row at index of I. In the beginning, I is going to equal 0, then 1, then 2, then the for loop ends. We will assign row at index of I equal to, cut this line of code. We're picking a random symbol from our array of strings, our array of emojis. At the end, we will return our row. We're returning our array of strings. Just to test it, I'm going to output using print row at index 0 plus row at index 1 plus row at index 2. I just want to be sure that we get 3 random symbols. There we go. We get 3 random symbols. We'll format the output later, so don't worry. We can delete this statement. We were just testing something. Now this method is complete. We can close it. We're returning a string array back to the place in which we called this method. We can assign this array. Back to the beginning, we will assign our string array of row. Our row equals call the spinRow method, and this will return a string array, which we're assigning to row. Once we have our row, we're going to print our row. We'll need to create another method for that. we will create a static method. It's not going to return anything. The return type is void. The name will be print row. There will be one parameter. We accept a string array, which we will name row. After assigning our row, we will call the print row method. But we have to pass in our row. Because we have one parameter, we have to pass in a string array, which we are. So here's where we'll print and display our row of emojis. Let's output the following. I will display a space character, plus, now the string class has a few useful methods. Type string with a capital S, dot, call the join method. For each character within a string, we can join them together with another character. I will join them by a space, a vertical bar, then a space, comma, row. For every string in my string array of row, we're going to join them with the vertical bar, along with a space before and after. Here's the output currently. I'll just bet $1. Here's what we have. We have 3 emojis, each separated with a vertical bar. I'll add some of those separators too, those asterisks. 14 asterisks should be enough. Alright, let's take another look. I'll bet $10. That looks pretty good. I'm happy with that. Our next step is to get a payout, if there's any matches. We can collapse this method. We no longer need it. Now we need to get our payout. After printing our row, we will call a method of getPayout, which we still need to declare. We'll pass in 2 things, our string array of row and our bet. How much money did we bet? We need to declare this method. After the print row method, we will declare a static method. This method is going to return an integer, our payout. The method name will be getPayout. We have to set up the parameters. We're accepting a string array. We will name the string array row. And a bet. Our bet is an integer. Int bet. We do need to return something. Just temporarily at the end, I'm going to return 0. We need to check to see if we have any matches. What we could do first is check to see if all 3 elements match. Are all these strings the same symbol? Here's how we can do that. Let's write an if statement. If our row at index of 0, that's the first symbol. Now you can't use the comparison operator for strings because they're reference data types. You would think you could say if row at index 0 is equal to row at index 1, but you actually need to use equals. If row at index 0 equals row at index 1. If the first 2 symbols match, row at index 0 and row at index 1, well then the first 2 symbols match. But not only that, we have to compare row at index 1 and row at index 2. Do those match as well? We're checking to see if all 3 symbols match. We will use the AND logical operator. And we can copy this check, paste it, and if row at index 1 equals row at index 2. If all 3 symbols match, then we execute this if statement. Why don't we use an enhanced switch? A switch can return something. We'll use the return keyword, create a switch. Within the switch, what are we examining? Let's examine one of these symbols. We could just pick any. I'll just pick the first one. We are examining our row at index 0. All 3 symbols are going to be the same, so it doesn't matter which one you pick. We'll examine this value, this emoji, against any matching cases. The first case will be our first symbol of a cherry. If these 2 values match, we'll do the following. We'll write an arrow, and we're going to be returning something. Let's return our bet times 3, let's say. We get a payout of 3 times what we bet. For our next case, that was a watermelon. The payout will be 4. For a lemon, let's set the payout to be 5. A bell, three matching bells will be worth 10. 3 stars, let's say, is 20. Bet times 20. We'll add a default case too in case there's no matches. Default arrow return 0. Looks like I'm missing a semicolon at the end. If all 3 symbols match, return our bet times a certain amount depending on which symbols match. The getPayout method is going to return an integer. We will assign our variable of payout equal to getPayout. If our payout is greater than 0, we'll do the following. That means we won something if that's the case. Let's output you won, pick a unit of currency, plus our payout, whatever we win. Then we will add that to our balance. Balance equals balance plus our payout. But we can shorten this using the augmented assignment operator for addition. Balance plus equals our payout. Else, if we don't get a payout, if our payout is 0, that means we didn't win anything. We'll output, sorry, you lost this round. Okay, let's do a few test runs. I'm going to keep on running this until we get 3 matching symbols, just to be sure that it all works. I will bet $1. Our message is, sorry you lost this round, and the current balance is $99. I'll bet another $1. You lost, you lost, you lost. It's hard to get 3 matching symbols. Here we go. I have 3 matching cherries. You won $3. And my current balance is $86. Now, if you would like to check to see if the first 2 symbols match, or the second 2, you can add the following code. Let's copy our if statement, paste it, change if to be else if. We'll only be checking the first 2 symbols. We can delete the second condition. If the first 2 symbols match, we'll give a reduced payout. Let's say for 2 matching cherries, that will be 2. For watermelon, that will be 3, 4, 5, and then 10. If the second symbol matches the third one, we'll write another else if statement. Index 1 and index 2 will give the same payout. Hello, this is Bro from the future. There's just one bug that I need to fix. The else if statement where we check if our second symbol matches the third, within our switch, we have to examine one of these 2 symbols. I forgot to change that originally. Both these symbols should be the same, so it doesn't matter which one we pick. I'll just pick the index at 1. Back to the previous else if statement, index 0 is fine, because the first 2 symbols should match. I just needed to fix that. That is all. Let's check to be sure that works. I'll bet $1. So my first 2 symbols match. We have a reduced payout of $3. But if it was 3 watermelons, we would win $4 instead. We can close this getPayout method. We're done with it. Here we'll ask the user to play again, if they would like to continue. We'll create a prompt. Do you want to play again? I'll use print rather than print line. There's one more variable we'll need that I'm forgetting. Let's create a string variable of play again. We will assign play again equal to, use our scanner, call the next line method. We'll want a user to type in either capital Y or capital N. After accepting user input, we'll make it uppercase using the toUpperCase method. Using an if statement, we'll check if play again doesn't equal. For comparing strings, we use equals. If play again doesn't equal a capital Y, then we will break, to break out of the loop that we're in. Then go to the exit message. One more thing we need to add, though. I'm going to place a bet. We get that prompt to play again, but the program exits. After typing in a number, there's still a new line character within the input buffer, because we're using next integer. We need to clear that input buffer. After this line of code, where we call the nextInt method, we can take our scanner, call the nextLine method, to get rid of that new line character. And that should work. I'll bet $1. Then we can play again if we type in Y. We display our current balance, we can place another bet. Hey, I won $50 that time. I'll type N to not play again, then we exit. The last thing we're going to do is display an exit message. We'll take care of that right here once we're out of the loop. Let's output the following. Game over. Your final balance is, pick a unit of currency, then I will add our variable of balance. Okay, let's run this one last time. Welcome to Java Slots. I'll bet $1. Sorry you lost, would you like to play again? I will type Y for yes. Current balance, $99. I will bet $1 again. I lost. I'll just keep playing till I win. Hey, I won $10. We have 2 matching stars. I'll play one more time. I will bet $10. And I won 20. We have 2 matching symbols. I will type in no to not play again. And we get our game over message. Your final balance is $117. So we came out ahead. Alright everybody, that is a slot machine game you can create using Java. Yo, we have finally made it to object-oriented programming in Java. So what is an object exactly? Look around wherever you're sitting right now. You are surrounded by different objects. For example, next to me I have my phone, a cup of coffee, and a microphone. In programming, an object can represent a real-world entity. They can do one of a few things. Objects can hold data, and they can perform actions. The data they hold are known as attributes. The actions that they can perform are known as methods. Objects can have things, and they can do things. Some attributes that a person may have would be a name, their age, their height, and their weight. A few methods, meaning actions that a human could do, a person, well, they could eat and they could sleep. Objects are reference data types. We store the data for an object in a location known as the heap. In this demonstration, we're going to be creating some car objects, but we'll need a class. A class can serve as a blueprint to create objects. So what we're going to do is create a new Java class. We will create a class of car. We have 2 classes, our main class and our car class. A class can behave as a blueprint for creating objects. We'll start by listing the different attributes that a car may have. So what does a car have exactly? Well, a car could have a make, that would be a string. We can assign it if we would like. Think of a car you'd like, or a car you drive. I'll pick my favorite car. The make will be Ford. Another attribute could be a model. And I will pick a Mustang. Cars could have a year, that would be an integer, int year. I'll pick the year 2025. A price, that could be a double. Double price equals, let's say, $58,000.99. A car's engine could be running, that could be a boolean. Boolean is running. I will set that to be true, or false if the car is turned off. Things that an object has, in this case car, these are known as attributes. They are things that an object has. Now, heading back to our main class, we will create a car object. We're already a little familiar with working with objects. For example, a scanner is an object. To create a scanner, we would type scanner scanner equals new scanner. Then you type system.in. Or with random objects, we would type random random equals new random. Now to create a car object, we're going to be utilizing this class. We'll type car, then think of a name for this car. We'll just say car, all lowercase, equals new car. We're following a similar pattern. Car equals new car. We don't need the scanner or this random object. I was just demonstrating something. We now have a car object that we can use. Our car object has these attributes, these things. If I was to print my car object, here's what we can see. Well, since objects are a reference data type, if you were to print your car directly, you get a memory address. If you need to access one of these attributes, you have to follow the object name with a dot. A dot is known as the dot operator. It allows you to access things within an object. If I need the model of my car, I would take my object name, use the dot operator, followed by the attribute name. If I was to print the model of my car, that would output Mustang. Let's print some of the other attributes. Car.make. Who manufactures the car? Ford. What is the year of my car? Car.year. 2025. What's the price? Car.price. $58,000.99. Is my car running or not? Car.is running. False. The car is not currently running. You can modify and change these attributes too. With our car object, let's access the isRunning attribute. I will set that to be true, like we're turning the car on. IsRunning is now true, because we changed the attribute of isRunning. Not only do objects have the capability to hold data, meaning attributes, they can perform actions. They can have their own methods. Going back to our car class, we'll define a few methods. What sorts of actions can a car take? Well, we could start a car. Within this class, we will define a method. We don't need that static keyword this time. We need a return type. We'll say void. We're not returning anything. We will define a method of start. Let's do the following. Let's output you start the engine. We'll create another method. Void stop. Let's say you stop the engine. So now with our car, we can delete these print line statements. We'll take our car object, use the dot operator, call the start method. This should output you start the engine. Or we could stop car.stop. You start the engine, you stop the engine. Not only that, within these methods, let's change one of these variables, one of these attributes. Within our start method, let's take isRunning, set that to be true. Within the stop method, we'll take isRunning, set that to be false. Going back to our main class, before starting the car, let's output car.isRunning. After starting the car, let's output car.isRunning, and then stopping the car, we'll output car.isRunning. The car is currently not running, that's false. You start the engine, the car is now running, that's set to true. You stop the engine, the car is no longer running, that is false. Let's add two more methods. We can start, we can stop, we can drive. We'll create a method to drive. Void drive. let's output you drive the, I'm going to use string concatenation. We'll concatenate the model of the car. So my car is a Mustang. We will create a method to break. You break the plus our model variable, our model attribute. We can delete these lines of code. Let's drive the car, car.drive. You drive the Mustang, and here's the model of the car. And we can break, car.break. You drive the Mustang, you break the Mustang. There's one issue with this, though. With our class of car, every car that we make has the same attributes and methods. We can only create 2025 Ford Mustangs. If I was to create another car object, let's say car2 equals new car, we'll rename the first car as car1. And I'll output some of their attributes. car1.make plus a space plus car1.model. We'll do this with our second car object too, car2. car2.make, car2.model. These cars have the same attributes. It would be nice if we had a way to customize them so that each car is unique, because currently they're all the same. They're different cars, but they have the same attributes and methods, which is kind of lame. That's why in the next video, we're going to discuss constructors. By passing in arguments, we can create unique objects. In summary, an object is an entity that holds data. It has attributes. And they can perform actions. They can perform methods. They have things, and they can do things. And well, everybody, those are objects in Java. Hey, today we're talking about constructors in Java. A constructor is just a special method within a class. It's used to initialize objects. By using a constructor, we can create objects with unique values. When you create an object, you can pass arguments to a constructor to set up the initial values. Here's a demonstration. What we're going to do is create a new class. Let's go to File, New, Java Class. Let's create a class of students. This will be the student class. What are some attributes that a student should have? They should have a name. Let me zoom in a little so you can read it. An age, int age. A GPA, meaning grade point average. Let's create a Boolean of is enrolled. That is good enough for now. There's one issue with this. Let's say that all students that I create using this class, they're all going to be named SpongeBob. Going back to my Java file, I'll create a few students. We type the name of the class, a name for this object, let's say student1 equals new student, the name of the class again. Then we'll create a second student, student2. I'm going to output student1's name, student1.name, as well as student2's name. The issue that we have is that all students that we create, all student objects, they're all named SpongeBob. What if we would like to give each object a unique name? Well, we can do that with the help of a constructor. A constructor is just a special method within a class. To set up a constructor, we type the name of the class, in this case student. You need a set of parentheses, then a set of curly braces. We automatically call this constructor when we instantiate an object of that class. When we say new, then the name of the class, parentheses. Behind the scenes, we're calling this constructor. And we can pass in arguments. Within the set of parentheses, we can pass in arguments. So let's pass in, what are we missing? A name, age, GPA, is enrolled as well, but we'll take care of that momentarily. Let's pass in a name, age, and GPA. Student 1's name will be SpongeBob. SpongeBob's age will be, let's say, 30. He seems about 30. SpongeBob's GPA can be 3.2. That's pretty good. We have a warning. Our constructor isn't set up to take these arguments. Going back to our constructor, since we're receiving arguments, we need a matching set of parameters, just like any other method. We have a string for name, integer of age, double GPA. We'll take care of these three first. We have string name, int age, double GPA. To assign some of these attributes, we're going to use the this keyword, this dot, the name of the attribute, this dot name equals our parameter of name. This dot age equals the age that we receive. This dot GPA equals the GPA that we receive. Going back to our Java file, we can now construct an object. If I attempt to run this currently, we are receiving a warning. Our constructor expects 3 arguments, but we don't pass in any. 0 are found. If I were to run this, we get this error message. Actual and formal argument lists differ in length. In order for us to create a student object, we have to pass in these 3 things: a string for the name, an integer for the age, and a double for the GPA. If we are missing these 3, we can't construct an object. But previously we could without the constructor. For our second student, let's pass in a name of Patrick. Patrick will be 34. Patrick's GPA isn't too good. It's a 1.5. Alright, let's test this. We're printing student 1's name and student 2's name. We get SpongeBob and Patrick. Let's display some of the other attributes. We have name, age, GPA. We'll do this with student 2 as well. Student2.age, student2.GPA. SpongeBob. SpongeBob is 30 years old. SpongeBob's GPA is 3.2. These are all the unique attributes of our student object, student 1. Student 2's attributes are Patrick, age is 34, GPA is 1.5. With the this keyword, this refers to the object we're currently constructing or otherwise working with. Imagine that when we construct student 1, imagine we replace the this keyword with the name of the object. We're assigning student 1's name equal to the name that we receive. Same thing applies with our age and our GPA. The same thing would apply with student 2. When we construct student 2, imagine during the process we replace this with student 2. This refers to the object we're currently working with or constructing. With these parameter names, they don't necessarily need to be the same as your attribute names. Just to demonstrate, let's rename name as A, age as B, GPA as C. This.name equals A, this.age equals B, this.GPA equals C. This should work too. Each object still has their unique attributes. But I like to keep the parameter names the same as the attributes. It makes the code easier to read and understand. We haven't assigned this attribute of isEnrolled. Each object that we create using this constructor, let's assign this object's isEnrolled attribute equal to. You don't always necessarily need to assign arguments to these attributes. For example, let's just say that when you become a student, you are enrolled. That is true. We don't necessarily need to pass in an argument for that. Going back to our main class, let's print take student 1's isEnrolled attribute and then print it. We'll do the same thing with student 2, Patrick. When we create a student object, we're automatically setting isEnrolled to be true. They are enrolled in classes. And that applies to Patrick as well, student 2. Let's create another student object, just so that we get the hang of this. Repetition is going to help you remember. Let's create student 3. Student 3 is an object. New, student. To create a student, we have to pass in three things: a string for the name, an integer for the age, and a double for the GPA. Student 3 will be Sandy. Sandy is 27, let's say. Sandy is smart, she'll have a 4.0 GPA. And then we'll print student 3's attributes. Student 3.name, student 3's age, student 3's GPA, student 3 is enrolled. Our object of student 3 has these attributes: Sandy, 27, 4.0, and true. If your class has any methods, for example, all students have the method to study. Void study. I'll just output the following. Let's take our name attribute, but I'm going to use this.name plus the text of is studying. Let's delete these print line statements. We'll take student 1, call the study method. Then we'll do this with student 2 and student 3. SpongeBob is studying, Patrick is studying, Sandy is studying. After assigning values to your attributes using a constructor, you can use them within methods too, or change them. This refers to the object we're currently working with. If student 3, meaning Sandy, was to call her study method, imagine we're replacing this with student 3, student 3's name attribute. Alright everybody, those are constructors. They're a special method found within a class to initialize objects. You can pass arguments to a constructor when you initialize them. They're used to set up the initial values when you construct an object. A constructor is automatically called when you create a new object, but you need a matching set of arguments if there's any parameter set up, just like any other method. By using a constructor, we can create objects with unique values. And well everybody, those are constructors in Java. What is going on, people? Today I'm going to explain overloaded constructors. Overloaded constructors allow a class to have multiple constructors with different parameter lists, much like overloaded methods. They enable an object to be initialized in various ways. Here's a demonstration. We're going to create a new class. Let's go to File, New, Java Class. We will create a class for users. We will create a user class. Let's say that users have three things. They will have a string of username, a string of email, and an integer, int age. Let's say that when we create a user object, these three fields are optional. If these three attributes are optional, we may or may not receive them when we construct a user object. So let's do this. Let's create a constructor if somebody were to create a user object with just a username. To create a constructor, we type the name of the class, in this case user. We need to set up a parameter for our username. We will receive a string of username. We will assign this.username equal to the username that we receive as an argument. Let's go back to our main Java file. We will create a new user. Let's say user1 equals new user. We're receiving a warning though. In order to create a user object, we have to pass in a string of username. Let's say that our user is going to be SpongeBob because that's the first thing that came to mind for me. We'll use this constructor where we have a username. We can also set up the default values for our attributes too. Let's say this.email equals a string of not provided. This.age equals 0. Going back to user1, I will output the following. User1 dot username, user1's email, user1's age. Here's what we got currently. Username is SpongeBob, email is not provided, age is 0. These attributes were optional. When we construct this object, we're just assigning them to some default values. What if we create a user that has an email? Well, we could create another constructor with the same name, but we need a different set of parameters. This is very similar to method overloading. You can have methods with the same name, but they need different parameters. Not only do we have a string of username, we'll have a string of email. Our email attribute equals the email that we receive. We can use either of these constructors depending on the arguments that are passed in. Let's create a second user. User, user2 equals new user. The username will be Patrick. Patrick's email is, let's say, p*@. Patrick is probably still using AOL for some reason. Let's say AOL.com. Then we'll print user2's attributes. User2.username, user2.email, user2.age. Here's what we got. We have all the attributes for user1 and user2. Patrick, p*@AOL.com. Our age is still 0. We can create different objects with a varying number of arguments. Let's create a third user. This time we'll have a parameter for our age attribute. I'm just going to copy this because I'm lazy. We'll have an int age. We will assign our age variable with the age argument we receive. We'll create user3. User3 equals new user. Username will be Sandy. Email will be scheeks@gmail.com. Then an age, let's say 27. Then I'll print user3's attributes. User3.username, email, then age. Here is all of Sandy's attributes. Username, email, age. Let's set up a constructor that accepts no arguments. This will be kind of an anonymous profile. This.username will equal guest, or a guest profile. This.email equals not provided. This.age equals 0. Now we could create a user object, then pass in no arguments. User4 equals new user. This time we don't have any arguments. Then I'll display user4's attributes. Username. Email. Age. Here's what we got. Username guest. Email not provided. Age is 0. In a way, by creating an object and passing in no arguments, you can set up some default values. Alright everybody, those are overloaded constructors. They allow a class to have multiple constructors. They just need different parameter lists. They enable objects to be initialized in various ways, by passing in a varying amount of arguments. This would be great in a situation where some fields are optional when creating an object. And well everybody, those are overloaded constructors in Java. Hey everybody, in this video I'm going to show you how we can create an array of objects using Java. It's pretty useful at times, and you should probably know how to do it. We'll begin by creating a new class. Let's go to File, New, Class. We will create a car class. Let's say that cars have the following attributes. We'll just pick 2 to keep it simple. A string of model and a string of color. We'll need a car constructor. We will pass in a string of model and a string of color. We will assign this.model equals the model we receive. This.color equals the color that we receive. We'll add one method. Void drive. All cars can drive. We'll output the following using a printline statement. You drive the plus this.color plus a space plus this dot model. Okay, we are done with the car class. We'll construct a few car objects. Let's start with car1. Car1 equals a new car. We have to pass in a model and a color. Think of some cars that you like. I will pick a red Mustang for one car. Let's create car2. Car2 equals a new car. I will pick a Corvette. That is blue. One more car. Car3. Car3 equals a new car. A yellow Charger. Alright, we have our three car objects. We can create an array, but for an array you have to list the data type of what you're storing. We're going to be storing car objects. The data type of the array is going to be car objects, car. Then for an array we need a set of straight brackets. What is the name of this array going to be? Well, I think cars would be appropriate. Cars equals, if you're creating an empty array, you're going to use the new keyword, list the data type of car. Within the straight brackets, specify the size of this array. Let's say 3 elements max. Or we could go ahead and just assign these right away too, using a set of curly braces. Let's place car1, car2, and car3 within this array. We'll place these 3 car objects within this array of cars. Now you could use a for loop to iterate through this array. Here's how. We'll start with the standard for loop. We'll need an index, int I equals 0. We'll continue as long as I is less than our car's length property, then increment I by 1. We'll access our array of cars at index of I, which is going to increase each time, but it starts at 0. We will call the drive method. And let's see what happens. You drive the red Mustang, you drive the blue Corvette, you drive the yellow Charger. Now an enhanced for loop would probably be more appropriate for this. If you want to use an enhanced for loop, type for, parentheses, curly braces. What is the data type of each element within this array? Car objects. We'll need a nickname for each element within this array. Let's say car, colon, think of colon as in, then our array of cars. For every car object in our array of cars, do the following. We'll take each car object, call the drive method. And that's going to do the same thing. You drive the red Mustang, you drive the blue Corvette, you drive the yellow Charger. Another thing you can do too when creating an array of objects, you can pass in anonymous objects, rather than first instantiating the objects, then assigning them to the array. Here's how you can do that. For each element, we're going to call the car constructor with the new keyword, call the car constructor, then pass in the details for each car, the necessary arguments. We'll pass in our Mustang, that's red. That's the first element. I'll just copy it to save some time. Then we're creating a new car, but this will be a Corvette. That's blue. And I'll put each of these on a new line just for readability. And then we have our Charger. That's yellow. And this will do the same thing too. We have our 3 cars. Constructing a new object without giving the object a unique identifier, like car1, car2, or car3, these are known as anonymous objects. So within an array, you can create anonymous objects, if you would rather not give each of these cars a unique identifier. Another thing you could do too with an array of objects is let's change the color of each car using our enhanced for loop. Car.color, let's change the color to be black for each car. We'll use another enhanced for loop to display each car. Car.drive. You drive the black Mustang, you drive the black Corvette, you drive the black Charger. Alright everybody, those are a few things you can do with an array of objects in Java. Hello everybody, today I'm going to explain the static keyword using Java. Static is a keyword. It modifies a variable or method so that it belongs to the class rather than any specific object. we see the static keyword within the main method. When you modify a variable or method with the static keyword, static is used to create utility methods or other shared resources. Let me give you a demonstration. We're going to create a new class. Let's go to File, New, Class. We'll create a friend class. We will create some friend objects, because you're lonely. Let's say that all friends will have a name attribute, string name. We need a constructor. It's the same as the class name, parentheses, curly braces. When we construct a friend object, we have to pass in a string of name. We will assign this object's name attribute equal to the name parameter that we receive. Let's construct two friends. We'll say friend1 equals new friend. But we have to pass in a name. Pick a name. My default is SpongeBob, because most people know who SpongeBob is. If I was to output friend1's name, then it should be SpongeBob. We just want to be sure that it works. Yes, it does. SpongeBob. Now, going back to our friend class, let's say we would like to keep track of how many friend objects we create. Well, that could be an attribute. Let's say we have an integer of num of friends, meaning number of friends. Whenever we create a friend object, we will increment number of friends by 1. Num of friends plus plus. So going back, let's output friend1's number of friends attribute, num of friends. So this should be 1. Yep, num of friends is 1. We have one friend. But what if we create a second friend object? I'll just copy this line of code, paste it, change friend1 to friend2. We'll pass in a new name, let's say Patrick. We'll print friend1's number of friends and friend2's number of friends. How many friend objects have we created? We have created 2, but what's the output? Well, it's 1 for both. Here's why. Each friend object has their own copy of the number of friends variable. We're incrementing each copy of number of friends by 1. When we create the object of friend1, we're incrementing its attribute of number of friends by 1. Same thing applies with friend2. When we create friend2, friend2's number of friends is 0, and we're incrementing it by 1. What if we would like to keep track of the total amount of friends that we created and store it within one variable? Well, there is a way we can do that, and that is with the static modifier. So going back to our friend class, we're going to precede the data type of this attribute with the static modifier, static int number of friends. Rather than all objects, all friend objects, having their own copy of number of friends, they're all going to share 1. So going back, let's print number of friends now. It's 2. We have 2 total friends. If I was to create a third friend, friend3, friend3 will be Squidward, and then I'll output friend3's number of friends. We have 3 total friends. We are receiving a suggestion. When accessing a static variable or calling a static method, it's actually best to do so through the class itself, rather than any object created from that class. Instead of saying, friend1, then accessing the static member, we will instead use the name of the class, in this case, friend. It's better for clarity to access a static member by the name of the class itself rather than any object, because you and other developers will know that this is a static attribute or method. To display the static variable, we would want to access it by the class name, then access that static attribute. How many friends do we have now? 3. Let's create a fourth friend. Friend4 will be Sandy. Then display the number of friends we have. Now we have 4 friends. Going back to the friend class, it's as if all these objects are sharing the same variable, but rather than any one object having ownership of this variable, rather the friend class owns it, and all objects have access to it. Methods can also be modified by the static keyword. We will create a static method that doesn't return anything. The return type is void. This method will be the showFriends method. We'll just output the following. We'll output you have plus. Normally, when you access an attribute, you type this dot the name of the attribute, such as, name. If you're working with a static attribute, you don't need this. For example, this dot number of friends, you don't need this. We even have a warning here that friends.this cannot be referenced from a static context. If you're working with a static attribute, you don't need this. This refers to the object you're currently working with, but since this attribute belongs to the class, we don't need this. You have your static attribute of number of friends, then the words total friends. To call a static method, type the name of the class, in this case friend, dot the name of the method, show friends. You have 4 total friends. Let's create another friend, friend 5. Friend 5 will be Gary. Friend.showFriends. You have 5 total friends. Another place in which you see static members is through the math class. For example, let's say you would like to round a number. You would type the name of the math class, math.round, and you can round a number. Round is a utility method. We access it through the class name of math. You don't need to go ahead and create a math object such as math1 equals new math, and then access it through this object. That would be silly. Round is a static method. It behaves as a utility method. We can access it through the class name, and we don't need to create any math objects, because that's stupid. And to prove this, let's go to the math class. I'm going to hover over math, jump to source. Here's the math class, and let's find the round method. I'm going to do a search for it. Here's the round method. So round is a method, and we have that static keyword. Round is a utility method for the math class. We can access it through the name of the class. All right, everybody, so that is the static keyword. It modifies a variable or method so that it belongs to the class, rather than any specific object. It's commonly used for utility methods or shared resources among objects created from that class, such as the number of friends. All those friend objects share the same attribute, rather than each of them having their own copy. And well, everybody, that is the static keyword in Java. What is going on, people? Today we got a very important topic to discuss today, and that is inheritance. Inheritance is where one class inherits the attributes and methods from another class, much like how a child can inherit traits from a parent. Well, in programming, we could do something similar. One class, a child class, can inherit traits from a parent. Here's an example. We're going to create a few classes, but we'll start with a new class of animal. Let's go to New, Class. I will create an animal class. What do animals have? Let's say that all animals are alive. They will start by being alive. Is alive. Let's create a constructor of animal. I will set is alive to be true when we construct a new animal object. But not only are all animals alive, all animals can eat. They will have an eat method. Void eat. We'll print something like the following. The animal is eating. Easting. Eating. That is good enough for this class. So what we're going to do is create 2 more classes. File, new, class. We will create a dog class and a cat class. Dogs and cats are types of animals. Our animal class will be the parent. The dog and cat class will be its children. In order for a class to inherit all the attributes and methods from another class, after the class name, you will use the extends keyword. Then specify the parent class. Dog extends animal. Our dog class will inherit all these traits, these attributes and methods, from the animal class. The cat and dog class don't have anything within them. Let's see if they actually do have these attributes and methods, even though there's nothing within them. Let's create a dog object. Dog equals new dog, and a cat. Cat equals new cat. Let's print our dogs Is alive variable. Is my dog alive? I sure hope so. Cat dot is alive. Look at that, they're both true. They should also be able to eat. Dog dot eat method, cat dot eat method. The animal is eating, the animal is eating. Even though these classes of dog and cat don't have anything within them, since they extend to the animal class, we're specifying that the animal class is the parent. The cat and dog classes are the children of the animal class. They inherit all these attributes and methods from its parent of animal, even though they don't have anything within them. This isn't as useful if you only have a few classes, such as 2, because, you could just copy and paste all this code within each, and then just change the constructor. But imagine if you had hundreds of classes, hundreds of children. You'd have to do that for hundreds of classes. But not only that, if you have to make any changes to say, this animal is eating, you'd have to make that change for hundreds of classes. And we are repeating ourselves a lot. It'd be a lot easier if we could just make that change in one place. If we have to change the to this, all of the children classes will inherit this updated method. We're following the dry principle. Don't repeat yourself. We're writing the code once and just reusing it. All the children classes will inherit this updated method. But not only that, each child class can have their own unique attributes and methods too. Let's say that all dogs will have 1 life. Int lives equals 1. They will also have their own unique speak method, void speak. When our dog uses the speak method, let's output the following. Let's say the dog goes woof. Then within the cat class, cats will have 9 lives. And they can speak, but they will say something different when they speak. Let's output the cat goes meow. Going back, let's output our dog object's lives. How many lives does our dog have? Same thing applies with our cat. Cat.lives. Our dog has 1 life, our cat has 9 lives. They also have their own unique speak methods. Dog.speak, cat.speak. The dog goes woof, the cat goes meow. There's also the concept of multi-level inheritance. We'll create a new class to serve as a sort of grandparent. A child class will inherit from a parent will inherit from a grandparent. So let's change this program around a little bit. We're going to create a new class. File, new, Java class. We will create a class of organism. Animals will extends the organism class. Let's cut our isAlive variable and the constructor. If you inherit from the animal class, you will get an eat method. If you inherit from the organism class, you are alive, and that's it. But we need to change the constructor. Animal inherits from organism, dog and cat inherit from the animal class. So from the perspective of our dog and cat class, the organism class is, you could say, a grandparent. Going back to our main Java file, let's take a look at our isAlive variables. Dog.isAlive. Same thing with our cat. Cat.isAlive. Yes, our dog is alive, and our cat is alive. Let's take this a step further. Let's create a class of plant. Plant is going to inherit from the organism class, because plants are a type of organism, but they're not related to animals. Let's create a new class of plant. Let's say that if you're a plant, you get a method to, well, plants don't eat, but they can photosynthesize. Photosynthesize, I think I spelled that right. Probably not, but who cares? If you're a plant and you photosynthesize, then the plant absorbs sunlight. Hey, this is Bro from the future. I forgot to extend the organism class. So let's take care of that. Heading back to our main Java file, let's create a plant object. Plant equals new plant. Our plant object should have an isAlive attribute, isAlive, which it inherits from the organism class. That's true. And plants can photosynthesize. Plant.photosynthesize. The plant absorbs sunlight. It's kind of like we have a whole family tree. Dog and cat inherit from animal, animal inherits from organism, and plant inherits from organism. But animals and plants aren't related. They're siblings, but they're not the same. Going back to our main Java file, let's see if our dog has a photosynthesize method. Dog.photosynthesize. Looks like they can't. We do not have a photosynthesize method for dogs. They do not inherit this method because they're not related to plants. Alright everybody, so that's inheritance. It's where one class inherits the attributes and methods from another class. A child class will inherit all the attributes and methods from a parent class. Parents can also be considered children too, and inherit from a, let's say, grandparent class. You just have to use the extends keyword. And well everybody, that's inheritance in Java. Yo, so let's get started. Today I gotta discuss the super keyword. Super just refers to the parent class when using inheritance. A child class is also known as the subclass. The parent class is also known as the superclass. Super just means parent for all intents and purposes. The super keyword is used within constructors and method overriding. Method overriding is a whole nother topic that we'll discuss. We're more focused on constructors in this topic. We use the super keyword to call the parent constructor to initialize attributes. Let me give you an example. We'll be creating a few different classes. Let's go to File, New, Class. We will begin by creating a class of person. Person will be the parent, the superclass. Let's say that any person object has the following attributes. They will have a string of first, meaning first name, then string last, meaning last name. We'll need a constructor. It's going to be the same as the class name, person, parentheses, curly braces. When we construct a person object, we will need to pass in the following arguments: a string for first name, first, and a string for last name, last. This object's first name attribute, this.first, equals the argument that we receive for first. Same thing applies with last. This.last equals the argument we receive for last. And then we'll create one method in this demonstration. This method won't return anything. We will name the method showName. All we'll do is output the following: this.first plus a space plus this.last. Okay, let's test this class out. Person equals new person. But we do have to pass in a first and last name. I've already used SpongeBob for too many examples, so let's mix it up. This time I'll pick Harry Potter. Or feel free to pick a different franchise that you like. So, one person from Harry Potter is Tom Riddle. We have a person object with this first name and this last name. First, last. Our person is going to have a showName method. Showname. Then call it. There we go. There's our person object's first and last name. Tom Riddle. Our person class will be the parent class. We'll create a few other classes to inherit from this person class. We're going to create a class of student that's going to inherit from the person class. The student class will inherit these attributes and methods. Let's create a new class of student. Student will extends the parent, or superclass, of person. Since student is inheriting from person, student is going to have a first and last name already, and a showName method. What other attributes does a student have that a person might not? Well, students have a GPA, a grade point average. We'll declare that as an attribute, double GPA. We're going to create a student constructor. Let's say that when we create a student, we need to pass in a string for first name, string first, string last, and double GPA. What's their grade point average? Now, rather than assigning our first and last name within this constructor, such as this.first equals first, this.last equals last, and this.GPA equals GPA, we are receiving a warning. There is no parameterless constructor available in person. We're not able to assign these attributes of first and last within the constructor for student. This is because student inherits from the person class. Since the constructor of our parent requires a first and last name, we have to pass these arguments to its parent of person. How we can do that, going back to the child class, we're going to be using the super keyword. Any arguments that the parent requires, we have to send the parent these arguments from the child constructor. And how we can do that is use the super keyword, and then pass in those arguments of first and last. And now Java is happy. Super just refers to the parent. Imagine that we replace the super keyword with person. Think of it like that. And now this should work. Going back to our main file, we should be able to create a student object. Student equals new student. We have to pass in a first name. First name will be Harry. Last name will be Potter. Then we have to pass in a GPA, because our student constructor requires it. Harry Potter has a 3.25 GPA, let's say. Our student object should have these attributes, this method, and this attribute from the student class of GPA. Let's test it. Student.showName. This student's name is Harry Potter, and they should have a GPA. Let's print student's GPA attribute. 3.25. But not only that, let's create a method to display their GPA. Within the student class, we will create a method that doesn't return anything. It will be showGPA. We will output the following. Let's say this.first plus a string, apostrophe s, so Harry's GPA is plus this.GPA. Let's take our student object, call the showGPA method that we have declared. Harry's GPA is 3.25. Let's create one more class. We will create an employee class. Class employee. Employee will inherit from the person class. Employee extends person. Since employees aren't studying, they're not students, they instead get a salary. We will create an integer attribute of salary. And then we need that constructor for our employee object. All employees will require the following arguments. A string for first name, string first, a string for last name, string last, and an integer for our employee's salary. I will attempt to assign these attributes for our employee. Again, it's not going to work, but let's try it. This.first equals first. This.last equals last. This.salary equals salary. Again, we're receiving that warning. There is no parameterless constructor available in person. Since employee extends person, and our person constructor requires a first name and a last name, we have to send our person constructor these arguments first and last. So again, going back to our employee class, we will call the constructor of our parent using the super keyword, and then passing in those arguments, first and last. Let's create a method within our employee class, void show salary. Let's output the following. We'll say this dot first, this person's first name, apostrophe s, we'll create the employee of Hagrid. Their salary is, pick unit of currency, I'll pick American dollars, plus this dot salary. Now we'll need to construct an employee object. Employee equals new employee. We have to pass in a first name, a last name, and a salary in order to construct an employee object. We're going to pick Hagrid. Hagrid's first name is actually Rubius. Last name, Hagrid. Hagrid's salary will be $50,000, let's say. All right, let's take our employee, call its show salary method. And there we go. Rubius, also known as Hagrid, Rubius' salary is $50,000. In conclusion, super refers to the parent class. Student and employee inherit from person. Since the constructor of the parent of person requires a first name and a last name, any children objects that we create, we have to call the constructor of the parent and pass in those arguments to satisfy Java. If the parent didn't require these arguments, then you wouldn't need to. And well, everybody, that is the super keyword in Java. What's going on, people? Today I'm going to discuss method overriding using Java. Method overriding is when a subclass provides its own implementation of a method, rather than use one that's inherited from a parent. It allows for code reusability, and you can give specific implementations of a method. Let me give you a demonstration. We'll be creating a few classes. File, new, class. We will begin by creating a class of animal. Then a new class of dog. A class of cat. Then finally, a class of fish. Dog, cat, and fish are going to extend the animal class. After the class name type extends animal. So let's do this with cat and fish. The dog, cat, and fish classes are all children of the animal class. Animal class is the parent class. There's not a lot we have to write with this example. If a child class inherits from the animal parent class, they will inherit a method to move. Let's define a method of move. All we'll say is, this animal is running. We can keep the dog, cat, and fish classes empty for now. So going back to our main Java file, let's construct a dog object. Dog equals new dog. A cat object. Cat equals new cat. And a fish. Fish equals new fish. All three of these animal objects, dog, cat, and fish, should have a move method. Let's take our dog, call its move method. Same thing with the cat and the fish. Cat.move method, fish.move method. Currently, when we run this program, we get the following output. Our dog is running, our cat is running, and our fish is running, but fish don't have legs though. They can only swim. The move method that the fish class inherits isn't appropriate for that class. This animal is swimming would be more appropriate. So why don't we do this? Within the fish class, why don't we do some method overriding? Specifically for the fish class, we will create a unique move method only for this class. We will define a new move method, where we will say, this animal is swimming. However, it is good practice to add this annotation of @override so that you and other developers know that this method is being overridden. Our fish class does inherit a move method from its parent of animal. If you have the same named method defined in a child class, you'll use that one first. It has precedence. Going back to our main Java file, let's call the move method for our fish. Our dog is running, our cat is running, but our fish is swimming. Within the fish class, we have overridden the move method. We have given a specific implementation for this method just for this one class. The cat and dog classes will use what's inherited from their parent. Not only is it good practice to add this annotation of @override, but let's say that you misspell this overwritten method. Rather than move, let's say moves, even though it should be move. We're receiving a warning that this method does not override the method from its superclass, its parent. If you didn't have this annotation, you may not notice that you misspelt this method and you're not actually overriding it. Adding the @override annotation provides a system of checks and balances when overriding method. This error will go away once we actually are overriding a method. Alright everybody, so that is method overriding. It's when a subclass provides its own implementation of a method, rather than use one that's already defined. It allows for code reusability, and you can give specific implementations of a method. We'll be seeing method overriding again with the toString method coming up in a future topic. And well everybody, that is method overriding in Java. Hello everybody, today I gotta explain the toString method using Java. The toString method is inherited from the object class. Whenever you create an object, behind the scenes, the object class is a superclass. The toString method is used to return a string representation of an object if you were to output it directly using system.out.println. The default behavior of the toString method is that it returns a hash code as a unique identifier for that object, but it can be overridden to provide meaningful details, which is why we've learned about method overriding in the last video. In this demonstration, let's create a new class. File, New, Class. We will create a car class. Let's say that all cars should have the following attributes: a string of make, who manufactures the car, a string of model, what's the model of the car, int year for the year, and string color for the color. We'll need a constructor, and then we'll assign these attributes. We have a string of make, a string of model, an int of year, and a string of color. Then we'll assign these attributes. This.make equals make, this.model equals model, this.year equals year, this.color equals color. That looks good enough for now. Going back to our main Java file, we'll construct a car object. Car equals new car. But we have to pass in the details for our car constructor. Our car constructor requires a make, a model, a year, and a color. So pick a car that you like. I like Ford Mustangs. I'll pick a Ford Mustang. The make will be Ford. Model will be Mustang. I need a year, 2025, and a color. I'll pick the color red. Car is an object. If I were to output my car object directly using system.out.println, here's what you'll see. If you output your car directly, technically you'll be given a hash code, a unique identifier for that car object. Hashing is kind of an advanced topic that I don't want to introduce right now, but typically with hashing, it's a unique identifier that uses the object's memory address to calculate a hash. You don't need to know any more than that right now. But wouldn't it be useful if we were to print our car object directly, we were given the details of the car? Normally what we would have to do is output something like this. This is if we wanted to output the details of the car. We could say something such as car.color, that would be first, plus a space character, plus car. What should be next? Let's say the year. Color, year, then make and model. Car.make plus a space plus car.model. This println statement is giving us meaningful details of this car object. This is the output. Red 2025 Ford Mustang. It would be nice if we were to print our car object directly using print or println. We could be given these details instead. Well, we can do that with method overriding. Going to our car class, we will be overriding a method. We need the @override annotation. We do need this keyword of public. This is a publicly accessible method. The return type is string. The name of the method is toString. Everything within this println statement, we're going to cut and delete this println statement. Going to our car class within the toString method, we have to return a string because we set the return type to be a string. We promised that we would return a string. Let's paste all the details of that car. We'll need to replace car with this. This refers to the object we're currently working with. Then add a semicolon to the end. If we were to print our car object directly using this println statement, or a print statement, or even printf, instead of that hash code, we're instead given meaningful details of that car that we've customized. The car's color, year, make, and model. We have overridden the toString method that's normally available to all objects. Let's construct another car object. Let's rename car as car1. We'll have car2 equals new car. Pick some different details for a car. I will pick a Chevrolet Corvette. The year will be 2026, and the color will be blue. I'll print car1, then print car2. Here's car1 and car2. Car2 is a blue 2026 Chevrolet Corvette. Alright everybody, so that is the toString method. Objects inherit from the object class. The object class does have a toString method, but it can be overridden so that when you print an object directly, you can display meaningful details, such as the details of that object, instead of displaying a hash code if you were to print the object. It's pretty useful at times. And well everybody, that is the toString method in Java. Alright everybody, it's about time we get into abstraction. Overall, abstraction is the process of hiding implementation details and showing only the essential features. Think of it like this. If I'm teaching somebody how to drive, I'm not going to open up the hood of the car and explain how the engine works. I'm instead going to tell the user that the gas pedal is to drive and the brake is to stop the car. Abstraction is the process of hiding implementation details. A user just needs to know what the gas pedal is and what the brake is. We can make classes and methods abstract by using this abstract keyword. This provides a few benefits. Abstract classes can't be instantiated directly. Abstract classes can also contain abstract methods, which must be implemented. They can also contain concrete methods, which are the opposite. These are real and physical methods, you could say. Concrete methods are inherited. So I know that's a lot. Let me give you an example. We're going to be creating an abstract class that can't be instantiated directly, meaning we can't create any objects from this class. In this demonstration, we're going to create some shape objects. Shape is going to be the parent. Then we'll have circle, triangle, and rectangle classes as its children. So we're going to go to New, Java class. We will create a shape class. Then a class for circle. A class for triangle. Then a class for rectangle. Our shape class is going to be abstract. We can't create any shape objects. Before the word of class, we will add this keyword of abstract. We can't create any shape objects. It's an abstract class. Now, circle, triangle, and rectangle are going to extend the shape class. Circle extends shape. Circles are a type of shape. Same thing applies with triangle and rectangle. Let's attempt to create a shape object. Shape equals new shape. And we get an error message. Shape is abstract. It cannot be instantiated. Since shape is an abstract class, we can't create any objects from this class. It adds a little bit of security to our program. We don't want anybody creating any generic shape objects. We want them to create a certain kind of shape, a circle, a triangle, or a rectangle. But we can create some circles, triangles, and rectangles, so let's do so. Circle, circle equals new circle. Triangle, triangle equals new triangle. Rectangle, rectangle equals new rectangle. We can create circle, triangle, and rectangle objects, just not shape, because it's an abstract class. That's good though, because we don't want people creating any shape objects. It's too generic. We want a user to pick a certain kind of shape. Abstract classes can contain abstract methods, and concrete methods. An abstract method is a method which must be implemented by its children. Within our shape class, we will define an abstract method. Use the abstract keyword. Let's list a return type of a double. Every child class of the shape class needs an area method. I'll add a comment that this is an abstract method. Abstract. So within our circle class, we get an error message. Circle must either be declared abstract or implement the abstract method of area. Circle is going to inherit this abstract method of area from its parent of shape. We need to implement this method, so let's do so. This is going to be an overridden method. We need the annotation of override. We need to define a method of area. But we'll fill it in momentarily. Just for now, I'm going to return 0. And now that error message goes away. Since we inherit from the shape class, and there's an abstract method of area, we need to implement this method. This helps to ensure consistency among the children classes. You can see that we're missing that same method with triangle and rectangle. So why don't we copy this code, where we override the area method, and paste it. We'll be filling these in later. Going back to our shape class, abstract classes can contain abstract methods and concrete methods, which are kind of the opposite. Concrete methods are defined and inherited within an abstract class. Let's define a method of display. This method doesn't return anything, the return type is void. We'll just output the following. This is a shape. I'll add a comment that this is a concrete method. In an abstract class, a concrete method is inherited. Within our circle, triangle, and rectangle classes, we don't need to implement it. We don't need to override this method. It's inherited. Going back to our main Java file, if I was to take my circle object, call the display method, we get the following output. This is a shape. And that applies with triangle and rectangle too. Triangle.display, rectangle.display. This is a shape, this is a shape, this is a shape. This concrete method of display was inherited from the shape class, their parent. Now we'll define the area methods. Area is an abstract method. That means that the children classes have to define it. To calculate the area of a circle, we'll need a radius. We'll define that as an attribute. All circles will have a radius attribute. Double radius. And we'll need a constructor, a circle constructor. When we construct a circle object, we have to pass in a double for the radius. This .radius equals the radius we receive. Now the formula to calculate the area of a circle will be, we're going to return access the math class, access the constant of pi from the math class, times radius, times radius. That's how to calculate the area of a circle. Now for our triangle, we need the following. A double for base, a double for height. We need a constructor. Parameter 1 will be double base. Parameter 2 will be double height. This dot base equals base. This dot height equals height. For the area, we will return 0.5 times base times height. Then we have a rectangle. Double length, double width. We need our constructor of rectangle. Parameter 1 will be double length. Parameter 2 will be double width. This dot length equals length. This dot width equals width. Return length times width within the area method. And we're good. Let's go back to our main class. We're missing those arguments. We have to pass them in. For our circle object, let's say the radius is 3. For the triangle, the base and height will be 4 and 5. The rectangle, the length and width will be 6 and 7. We are going to output using system.out.println, take our circle, call the area method. Then do this with triangle and rectangle. Here's the area of each of our shapes, our circle, our triangle, and our rectangle. So that's the abstract keyword. Abstraction is the process of hiding implementation details from a user and showing only the essential features. That's why we've created a shape class that's abstract. We can't directly create any shape objects. We want a user to create a certain kind of shape, whether it's a circle, a triangle, or a rectangle. A shape is too generic. An abstract class can contain abstract methods, which need to be implemented by the children classes, or concrete methods, which are inherited, and the children classes will have access to it. Alright everybody, so that is abstraction and the use of the abstract keyword in Java. Alright, what's going on everybody? In this video I gotta explain interfaces using Java. An interface is very similar to an abstract class. In fact, there's a lot of overlap where you could use either one, but there's a few key differences. An interface is a blueprint for a class. It specifies a set of abstract methods that any implementing classes must define. One key difference is that by using interfaces, we can achieve multiple inheritance-like behavior. Normally with inheritance, a class can only have a single parent, but by using interfaces, a class can have multiple parents, like 2, 3, or more. So in this demonstration, we're going to create two interfaces. Let's go to File, New, Java Class. Rather than creating a class, we're going to create an interface. We will create an interface of prey, and the other for predator. File, New, Java Class, Interface, Predator. We're going to be declaring some methods, but not defining them. If a class inherits from the prey interface, they will have to finish defining a method of flee. The return type will be void. If you're considered prey, you need a flee method to run away. If you're a predator, you need to define a method to hunt, because you're a predator. Now we'll be creating three classes. File, New, Java Class. The first class will be Rabbit. Then Fish. We'll create a Fish class. And Hawk. Going to our Rabbit class. Rabbits are typically considered prey, not predators. Unless you count that one rabbit from Monty Python and the Holy Grail. That's the exception. Our Rabbit class is going to implement the prey interface. We get a warning message. Class Rabbit must either declare abstract or implement abstract method flee. Since the Rabbit class is implementing the prey interface, we have to finish defining this method that's declared within the prey interface. It's kind of like a contract. The prey interface is telling the Rabbit class, hey, if you're going to implement me, you need to define this method of flee. We'll need to do that in order to create Rabbit objects. We're going to be overriding this method using the override annotation. This method will be flee, void flee. And we'll want to add this access modifier of public. It's a publicly accessible method. In this method, we're going to output the following. Let's say the rabbit is running away. And that error should go away. Let's go back to our main class. We'll create a rabbit object and test it. Rabbit, rabbit equals new rabbit. Let's take our rabbit object, have it call the flee method. And this should work. Yes, the rabbit is running away. Now let's go to our hawk class. Hawk will implement the predator interface. But we have to override this method of hunt, because with the predator interface, it's kind of like we're signing a contract. If hawk is going to implement the predator interface, then we have to finish defining this method. We will add the override annotation and define this method. And then again, we do need an access modifier. We'll pick public. Let's output the following. The hawk is hunting. Let's create a hawk object. Hawk equals new hawk. Our rabbit is fleeing. Let's take our hawk object, use the hunt method. Okay, we have the rabbit is running away, the hawk is hunting. Now, rabbits don't have a hunt method, and hawks don't have a flee method. Now, one key difference with interfaces compared to abstract classes is that you can implement more than one interface. So fish, they eat smaller fish, and they flee larger fish. They could be considered both prey and predators. We will implement two interfaces. Implements prey, comma, predator. Then we need both of these methods. We have to finish defining both. Again, we're going to use the override annotation. We will create a publicly accessible method, a flee, where we will print the fish is swimming away. And we need a hunt method too. Add the override annotation. This is a public method of hunt, where we will print the fish is hunting, let's say. All right, let's test it. We will create a fish object. Fish equals new fish. Our fish can flee, and our fish can hunt. The fish is swimming away, the fish is hunting. Our fish object implements both the prey and predator interfaces. It has to define these two methods. So that's one key difference with interfaces compared to abstract classes. A class can inherit more than one interface. Normally with inheritance, you can only have one parent. But this is a way around that using interfaces. Fish are considered both prey and predators. Alright everybody, so that is a quick introduction to interfaces. An interface is a blueprint for a class that specifies a set of abstract methods that implementing classes must define, and it supports multiple inheritance-like behavior. There's a lot of overlap where you can use abstract classes or interfaces. You should be familiar with both. And well everybody, that's a quick introduction to interfaces using Java. So yeah, it's about time I explained polymorphism using Java. Polymorphism is a Greek word. Poly means many, morph means shape. Together, you get the concept of many shapes or forms. It's a general programming concept. Objects can identify as other objects of different types. Objects can be treated as objects of a common superclass. A dog identifies as a dog, but it can also identify as an animal. It can also identify as an organism. It can also identify as an object. It can identify as more than one thing. In this topic, we're going to create a few vehicle objects. Let's create a few classes, file, new, Java class. We will create a superclass of vehicle. This class doesn't have to be abstract, but let's make it abstract. We can't create any vehicle objects. We will declare an abstract method that doesn't return anything. The return type is void. If you're a vehicle, you need a go method. So what we're going to be doing is creating a few different types of vehicles. A car, bike, and boat class, which will inherit from the class of vehicle. So let's create these classes, file, new, Java class. We will create a car class that extends the vehicle class. But there is an abstract method of go that we need to define. We will use the override annotation. The method will be return type of void, go. all we'll do is output you drive the car. All right, let's do this with a few other classes. I'll just copy this method because we'll reuse it. We'll create a bike class. Bike extends vehicle. And we need that method of go. You ride the bike. And a boat class. File, new, Java class, boat. Boat extends vehicle. You sail the boat. That is good enough for now. Going back to our main Java file, let's create these objects. Starting with our car. Car equals new car. Bike equals new bike. Boat equals new boat. Each of these objects has a go method. For example, let's have our car object use its go method, followed by bike.go method, and boat.go method. You drive the car, you ride the bike, you sail the boat. So let's say we would like to have a race. We're going to place all of these objects within an array, our car, bike, and boat objects. So what should the data type of the array be? Let's attempt to create an array of car objects and place our bike and boat objects within that array, and we'll just see what happens exactly for learning purposes. I will create an array of cars. The data type is car. It's an array named cars equals curly braces. Let's stick our car, bike, and boat objects within here. We're already getting a few error messages. Incompatible types. Bike cannot be converted to car. Bikes and boats don't identify as cars. Cars identify as cars. That's one of the shapes that bikes and boats don't have. They don't identify as cars. If this were an array of bikes, bikes equals our array of objects, well then we have another error message. Car cannot be converted to a bike. And you can assume the same thing applies with boats. Cars and bikes don't identify as boats. What we could do is declare our array of what they have in common. Well, our car, bike, and boat, they all extend the vehicle class. You could say they also identify as vehicles. We're going to change the data type of our array to hold vehicles. We have an array of vehicle objects. And then let's change our array name to be vehicles. Cars identify as cars, but also vehicles. Bikes identify as bikes, but also vehicles. Boats identify as boats, but also vehicles. That's the one thing they all have in common. They're all extending the vehicle superclass. They're also considered vehicles. That's another one of their forms, their shapes. For every object within this array, I would like to have each object use its go method, like we're racing. Well, what we could do is use a for each loop. What's the data type of the array? Well, it's vehicle. We have an array of vehicles. We will give a nickname of each vehicle as vehicle in my array of vehicles. For every vehicle in this array of vehicles, let's take each vehicle, call the go method, take every vehicle object, call its go method. Here's the result. You drive the car, you ride the bike, you sail the boat. Oh, and another thing I'm forgetting. Polymorphism can also be achieved through using interfaces. Let's delete our vehicle class. We'll create a new Java class. This will be an interface of vehicle. Rather than extending the vehicle class, we will implement the vehicle interface. We will declare a method of go that doesn't return anything. These methods do need an access modifier. Let's just say public. So polymorphism can be achieved this way too, through using interfaces, if you prefer interfaces. In summary, polymorphism means many shapes. It's where objects can identify as themselves, but also other objects. Objects can be treated as objects of a common superclass. And well, everybody, that is an introduction to polymorphism using Java. What's going on, people? Today I gotta explain runtime polymorphism, also known as dynamic polymorphism. How I would explain it in a single sentence is when the method that gets executed is decided at runtime based on the actual type of the object. In this demonstration, a user is going to pick a type of animal they want as a pet, a dog or a cat. But that's going to be determined at runtime, after the program is already running. We'll create a total of 3 classes. First, we'll create an animal class, which will be a parent class. We will create a class of animal. We might as well make this an abstract class for good practice. We don't want anybody creating any animal objects. We will have an abstract method. The return type is void. This method will be speak. When an animal speaks, they'll say something unique. We'll create a dog class. File, new, Java class. We will create a class of dog that extends the animal class. But we do need a speak method. We will use method overriding. The return type is void. With our speak method, we will output the following. The dog goes woof. Alright, then we need a cat class. File, new, Java class. We will create a class of cat. Cat extends animal. And we'll just copy the speak method, just to save a little bit of time. When the cat speaks, we'll output the cat goes meow. That's good enough for this example. Since animal is an abstract class, we can't create any animal objects. I'll attempt to do so. Animal equals new animal. And we get an error message. Animal is abstract, cannot be instantiated. That's good though. Animals are too generic. We would rather have a user create a certain kind of animal, either a dog or a cat. In this demonstration, we're going to have a user pick if they want a dog or a cat, but we don't know which one they're going to pick. So why don't we do this? Let's declare an animal object, but not instantiate it. We will assign our animal equal to a new dog or a new cat based on the user input. So, animal. This will either be animal equals a new dog or animal equals a new cat based on the user input. We will declare an object that's at least an animal. We'll accept some user input. We'll need a scanner. Scanner equals new scanner. We will pass in system.in and import this class, java.util.scanner. We'll need a prompt. Would you like a dog or a cat? We'll say 1 equals dog, 2 equals cat. I'll use print rather than print line because I like the input on the same line. Let's declare a variable of choice. This will be an integer. We'll use our scanner, call the nextInt method, and then we'll do the following. We'll examine if our choice variable is equal to 1. If it is, we'll finish instantiating our animal object, but we'll assign it to be a new dog object. Then we will have our animal use its speak method. So if it's a dog, it should go woof. Else if choice is equal to 2, then we will instantiate our animal object as a new cat and have our animal use its speak method. You could add an else clause, but it's not really necessary. This is good enough for now. Before running the program, we don't know what kind of animal we're going to create. It's either going to be a dog or a cat. If I select 1, we get a dog. The dog goes woof. If I select 2, we get a cat. The cat goes meow. The actual method that we call is determined at runtime, after the program is already running. Before we run the program, we know that we're going to use a speak method. We're just not sure which one. So that's runtime polymorphism. It's when the method that gets executed is decided at runtime, based on the actual type of object that we create. And well, everybody, that is an introduction to runtime polymorphism using Java. Alright everybody, today I'm going to be explaining getter and setter methods using Java. Getter and setter methods help protect object data, and they add rules for accessing or modifying that data. Here's a demonstration. We're going to create a class of car. File, new, class. We will create a car class. A few attributes that cars could have include a string of model, a string of color, and an int, let's say price. Then we'll need a constructor. We'll have three parameters: a string of model, a string of color, and an int of price. We will assign this.model equals model, this.color equals color, this.price equals price. Let's construct a car object. Car equals new car. Pick a model, a year, and a price. I've already used red Mustangs for too many examples. I'll pick something else. Let's say a Charger that is yellow, and the price will be $10,000. I don't know if that's good or not. We don't even know the year of the car. Anyways, so we have our car object. And then let's output these attributes just to test them. Car.color, I'll add a space character too, plus car.model, plus a space character, plus car.price. I'm intentionally not adding a unit of currency. So here's our car. I have a yellow Charger, and the price is 10,000. 10,000 of a unit of currency that you choose. But that's not important. With our car object, its attributes are publicly accessible, meaning we can view and change them easily. To demonstrate, let's say that the model of our car is now a Corvette. We have a yellow Corvette that is $10,000. We don't want the model of our car to magically become a Corvette. Once we assign its model to be Charger, we don't want it to change. What we could do when declaring these attributes is add this access modifier of private, preceding the data type. Private string model, private string color, private int price. We can't access them. And let's test that. You can see that the font color already changed to red. I will attempt to print the car's color, model, and price. Color has private access in car. Model has private access in car. And price has private access in car. Since these attributes are private, we can't normally access them outside of the car class. But there is a way around that, and that is by using getter and setter methods. Getter methods make a field readable. Setter methods make a field writable. Use get to read, set to write. We'll set up some getter methods first. I would like the car's color, model, and price. Here's how we can do that. Within the car class, we will create a method. We'll start with the model. The return type will be string, because our model is a string data type. We'll create a getter method, following this naming convention. Get, then the name of the attribute, model. All we're going to do is return this dot model. And then we'll do this with the color and the price. And I'll just copy this method because I'm feeling a little lazy. We have get model, get color, return this dot color, and get price. Return this dot price. Oh, and this returns an integer, not a string, because our price is an integer. Let's go back to our main Java file. Rather than accessing these attributes directly, because we can't, we're going to call these getter methods get model if you need the model, get color if you need the color, get price if you need the price. Replace car.color with car.getColor, and this is a method. Car.getModel, and car.get price. And that should work. Yep, we can now read those attributes. We have a yellow charger, and the price is 10,000. Another thing you can do too with getter methods, you can add additional logic. So with our getPrice method, let's instead return a string. We will return a unit of currency, I'll pick American dollars, plus the price. Let's see how that changes. Again, we are calling the getPrice method. There we go. Yellow charger, $10,000. Getter methods make a field readable, and you can add additional logic when retrieving one of these attributes. And in this demonstration, I just added a $sign just to keep it simple. Then we have setter methods. Setter methods make a field writable. Going to our car class, we have model, color, and price. I don't want the model attribute to be writable. Once we've declared the model of our car, we don't want to change it. Our charger can't magically become a Corvette, even though that'd be pretty cool. But the color you could change, you can paint your car, and the price. You can sell your car for a different price. We'll declare setter methods for our color and price, but not the model, because we don't want this attribute to be writable. So let's scroll down to the bottom. Following a similar pattern, we're going to create a method. The return type is void. This will be setColor. We have one parameter, a string of color. We will assign this .color equal to the new color that we receive. We'll do this with our price too. Void set price. We'll have one parameter, an int of price. This .price equals price, the new price that we receive. Okay, let's test these things. I'll attempt to access our color directly. Car.color equals, I don't know, blue. That's the first thing that came to mind. And car.price equals, you know what, the car's on sale, it's $5,000. Well, I can't change these. We still have that red text for color and price. Because the color and price attributes are still private. Instead, we're going to call these setter methods. We will set the color, and then pass in that new color, rather than assign it directly. Set color, pass in a new color. Set price, pass in a new price. 5,000. Then using our getters, we should be able to print these attributes. Yes, we now have a blue charger, and the price is $5,000. We don't have a setter method set up for the model. That's good though. We don't want the model to change. We only have set color and set price. If I attempt to access a set model method, we shouldn't be able to change it, because we never declared a set model method. It doesn't exist. But if you did want to change the model, if you want this attribute to be writable, well then you could add a setter method. Void set model. We'll pass in a string for the new model. This .model equals model. And then you could change it. We have a blue Corvette for $5,000, which is really cheap. But you know what? I don't want the model to be writable, just readable. If you don't want an attribute to be writable, when you declare it, you can also add this keyword, a final. That adds an extra security measure. One last thing we should do. With the price, let's add some additional logic. So with our price, let's do the following. Let's add a check. If our price is less than 0, then let's output the following. Price can't be less than 0. Else, if everything checks out, if our price is 0 or above, then we'll assign this .price equals the price that we receive as an argument. Let's test it. I'll change the color of my car to be blue, but the price is going to be -$100. We get that message. Price can't be less than 0. The color changed, but not the price. It stayed the same at $10,000. So those are getter and setter methods. They help protect object data and add rules for accessing or modifying that data. Getter methods make a field readable. Setter methods make a field writable. Depending on your object's attributes, you may want some to be readable or writable or both. It's up to you. And well, everybody, those are getter and setter methods using Java. All right, let's do this. Today I got to talk about aggregation in programming. Aggregation represents a has-a relationship between objects. One object contains another object as part of its structure, but the contained object or objects can exist independently. Basically speaking, an object can contain another object, but those objects can exist independently. What we'll do for this demonstration is create some book objects. Then we'll create a library object to contain the book objects. The books and the library can exist independently. That's aggregation. The library object will have book objects. We'll create a new class of book, file new class, book. And a class for library, file new class, library. Let's design our book objects. Let's say that books have a string of title and an integer for pages. You could include an author too if you would like, but I don't want this example to be too big. We'll need a constructor for our book objects. We'll set up the parameters. We need a string of title and an integer for pages. This.title equals title. This.pages equals pages. If you would like, you can set these attributes to be private, but that might be overkill for this lesson. Why don't we create a method to display the book's info? This method will return a string. We'll define a method to display info. We will display the info of this book. Let's return the following. Let's return this.title plus a space character plus this.pages and a string of the word pages. And I think I'm going to enclose the number of pages within a set of parentheses. You can also use a printf statement, if that's easier for you, but I want to try and keep this beginner friendly. Okay, that's good enough for the book class. Let's create a few book objects. We'll start with book 1. Book 1 equals a new book. But to construct a book, we have to pass in at least the following: a title and a number of pages. So I've picked out a few books already. Feel free to choose your own if you would rather choose different books. For the first book that I'll pick, I will pick The Fellowship of the Ring. This will be all one string. And the number of pages, at least according to Wikipedia, is 423. Then we'll create another book object. This will be book 2. Book 2 will be The Two Towers. The number of pages will be 352. And then book 3. Book 3 will be The Return of the King. The number of pages will be 416. All right, we have our independent book objects. Then what we'll do is stick them all within an array. We'll create an array of book objects named books equals, then within a set of curly braces, we can place our book objects within here. Book 1, book 2, book 3. We have an array of book objects. Before moving on, let's test the display info method of each of these books. So we'll need a print statement. book1.display info. So we should get book 1, The Fellowship of the Ring, 423 pages. I'm just going to make one change. I'll put the right parenthesis at the end. That's better. Let's display book 2. The Two Towers, 352 pages. Book 3. The Return of the King, 416 pages. You could also loop through this array using an enhanced for loop. The data type of each element in my array is book. For every book in my array of books, we'll print, take each book, call the display info method. And here's all the books that I have in my array. The Fellowship of the Ring, the Two Towers, the Return of the King. And we can delete this for loop. We no longer need it. Now we're going to create a library object. Our library object will contain our array of book objects, because libraries contain books. Going to our library class. What should libraries have? Let's say that our library should have a name. What's the name of the library? Maybe a year in which the library was established, int year. And libraries should contain book objects. We will create an array of book objects named books. We'll need a constructor for the library class. We'll need the following: a string for the name of the library, an integer for the year of the library, when was the library built, and an array of book objects. This .name equals name. This .year equals year. This .books equals the books that we receive, this array. All right, going back to our main Java file, this is where aggregation is going to come in. We will create a library object. Library equals new library. But we have to pass in the following as arguments to the constructor: a name for the library, a year for the library, and an array of book objects. So for the library, I'm going to say the NYC, the New York City Public Library. After a quick Google search, this library was built in the year 1897. Then we also need an array of book objects. I will pass in my array of book objects named books. This is aggregation. Our library object has book objects. Within the library class, let's also create a display info method for the library. We'll make it a little bit different. This method won't return anything. Let's say the return type is void. We'll name this method display info. We'll display the following information about this library. Let's output the following: this.year of the library, plus a space character, plus this.name. You can also use a printf statement if you would prefer to use that. I'm trying to keep this as beginner-friendly as possible. So let's test this. We will take our library object, call its display info method. The 1897 New York City Public Library. Then within this method of display info for the library, let's also list all the books that it has. This library has aggregated a whole bunch of book objects, so then we can display them or use them for something. Let's output the following. Let's output books available. Then we'll use an enhanced for loop. The data type of what we're iterating through is book objects. For every book in my array of books, take each book, call the books display info method. And then we do have to print it using a print line statement, because this method returns a string. There we go. Let's test it. So after calling the display info method of the library, we should display the information of the library, including its books, the 1897 New York City Public Library, and we display the books available, which are the array of books that we have created. So that's aggregation. It represents a has-a relationship between objects. Our library object has book objects within it. There's another similar concept called composition. With aggregation, if you were to delete this library class, for example, I'll delete it. Well, these book objects can exist independently outside of the library. The books aren't built into the library, so they can exist independently, which is a key difference compared to composition, which is the next topic we'll cover. And well, everybody, that is aggregation using Java. Hey everybody, in this video I'm going to explain composition to you in programming. Composition represents a part of relationship between objects. For example, an engine is part of a car. An object can be part of another object. This allows for complex objects to be constructed from smaller objects. In this demonstration, we're going to create a car object. The car object is composed of an engine object. We will create a class of car and a class of engine. We'll begin with our class of car. What sorts of attributes should cars have? Let's say a string of model, an int of year, and an engine object. Engine, engine. We'll need a constructor. We'll pass in a string for the model, an int for the year. Now for the engine, we're not going to be passing in an engine object. Let's say that when we construct a car object, we have to pass in a string for the engine type. Is it an inline engine? Is it a V6? That sort of thing. We will assign this.model equals the model that we receive. This.year equals the year that we receive. Now with our engine, this.engine, we're going to call the constructor for a new engine object. And then we can pass in our engine type. But we still, however, have to set up the constructor for our engine class. When constructing a car object, we will also be constructing a new engine object. So let's go to our engine class. Let's say that engines have a string of type. You could say engine type, but that would be redundant, I would say. Let's just say type. Then we need a constructor. For our engine class, we will need a string of type to pass in. This.type equals type. So going back to our car class, when we pass in a string for the engine type, you could say that this is type. This term is kind of ambiguous though, because a user is going to think that the type is for the car type rather than the engine type. So when you pass arguments, your parameter names can be different from the argument names that you pass in. We simply rename them when this constructor receives that argument. But type refers to the engine type. Alright, so this is a basic demonstration of composition. Now we'll construct a car object. Car equals new car. And then we have to pass in the following. A string for the model, an int for the year, and a string for the engine type. Pick a car that you like. This time I will pick a Corvette. The year will be 2025. And for the engine, I will pick a V8 engine. Then let's see if we have these details. I'm going to output my car objects, model, and these attributes I did not set to private, but you can set them to private and use getters and setters if you would like. So we have model, year, and we have an engine object. Here's what we have. We have our model, Corvette, year 2025. Now for the engine, our engine is an object. It's a reference data type. So if you output it directly, you're given a hash ID to represent that engine object. So if we need the type of engine, we're going to access our engine object, then get the type. So following our engine object, we will use that access modifier, that dot. Then access the type, the attribute. So the engine type is a V8. So it's like we have an object that's composed with another object. Our engine is part of our car. You know what, let's create a method for the engine. We'll create a start method. Void start. We'll output the following. Let's say, using a print line statement, you start the plus this dot type, meaning type of the engine, plus the word engine. Then going to our car class, let's create a start method for the car class. Void start. When we start the car, we also start the engine. Let's take this dot engine, call its start method. And then we can output something else too if we would like. Let's output the plus this dot model plus the words is running. Now, if we start the car, let's take our car, call it start method, and we should get the following. You start the V8 engine, the Corvette is running. Now, a key difference with composition is that if we delete our car object, that should also delete our engine, because our engine is part of our car. So to demonstrate that, I'm going to delete our car object, and we no longer have access to the engine. Alright everybody, that is composition. It represents a part of relationship between objects. For example, an engine is part of a car. This allows for complex objects to be constructed from smaller objects. And well everybody, that is composition using Java. Well, look who showed up today. I gotta talk about wrapper classes. Wrapper classes allow primitive values, such as integers, characters, doubles, booleans, those sorts of things. Wrapper classes allow these primitive values to be treated as objects. We're basically wrapping primitive values within an object, kind of like a Christmas present. Generally, you don't need to wrap primitives unless you need an object for some reason, like if you're using a collections framework in Java. And wrapper classes also give you access to a lot of useful static utility methods. So let me give you a demonstration of wrapper classes. The method of creating wrapper classes I'm about to show you is actually depreciated, but it's going to help you visualize how this works, wrapping a primitive within an object. The modern approach is using a technique called autoboxing, but the method I'm about to show you is a good way to visualize this whole thing. So let's say we have an int of a, variable a. A equals 123. We can treat this primitive as an object by using a wrapper class. Here's how. Rather than declaring this variable as an int, we will use the wrapper class of integer. Integer variable a equals a new integer. And then we're going to pass in that number, that integer, as an argument. A is an object. We're passing in that primitive data type, that int, as an argument to the integer class. So a is an object, but it does contain a primitive value. Again, this is depreciated as of version 9, so you shouldn't do it this way, but this is a good way to visualize it. Then if you need a double, we'll use the wrapper class of double. Let's say variable b equals a new double. Then we'll pass in a double. 3.14 is good. Then we have char, which is character, that's the wrapper class. Character c equals a new character. Then pass in a character. I'll pass in a $sign. We'll add one more. Let's say a boolean. We will use the wrapper class of boolean. Boolean d equals a new boolean. Then pass in a boolean value. Here's just a few examples. These are all objects, a, b, c, and d. By wrapping these primitives within an object, that allows us to use these primitive values within collections frameworks, such as array lists, which we'll talk about in the next topic. The modern way to use wrapper classes is actually just to assign them directly to their primitive values. The class of integer a equals 123. Double b equals 3.14. Character c equals a $sign character. And then d equals true. This technique is called autoboxing. We're directly assigning these primitives into an object using a wrapper class. Now this is very similar to how we declare and assign strings. To create a string, you would say string, let's say e equals a string of characters, such as the word pizza. You can see that there's a similar pattern. We have always created strings this way. But with autoboxing, it's a similar process. These are all reference data types. They're a type of object. There's also a technique called unboxing to convert a wrapper class back to its primitive. This is unboxing. So let's say we would like to convert our object of a, it's an integer object, back to its primitive. Let's say int x equals, all you gotta do is set it equal to your object. In this case, our integer object of a. This is unboxing. We're taking a primitive that's wrapped in an object and unboxing it, or unwrapping it, and setting it back to its primitive. If we were unboxing a double, we would say double some variable equals b. Or chars, char x equals our character object of c. And then boolean, boolean x equals d. Again, this is autoboxing. We're wrapping up a Christmas present. We're wrapping up a primitive within an object. And then unboxing is removing it. We're opening the Christmas present. Now, these wrapper classes themselves do have some pretty useful utility methods that are static. Let me demonstrate a few you might be interested in. But there would be too many to cover in just this one video. If you ever need to convert a primitive data type into a string, there's a toString method of these utility classes. So let's say we have string A, string B, string C, and string D. I can convert an integer into a string using the integer wrapper class. It's accessed statically, so we type the name of the class, integer, call the toString method, which is static, and then pass in an integer like 123. So let's do this with a double. We will access the double wrapper class, call the toString method, and then pass in a double, 3.14. Then to convert a character to a string, we would use the character wrapper class, character to string, and then pass in a character. And then boolean. We will access the boolean wrapper class, call the toString method, and then pass in a boolean. So strings can be concatenated together. We should be able to do the following. Let's say string x equals a plus b plus c plus d. And then we'll output whatever our variable x is. We get 123, 3.14 at false. It's all one long string. It's because we use these wrapper classes to convert these primitive data types into strings. If you ever need to convert a primitive to a string, then use that primitive data type's wrapper class and call the toString method. Then you just need to pass that value in as an argument. Then it's going to spit out a string for you. Now, on the other hand, to convert a string to a primitive data type, there's another useful utility method of wrapper classes. So what we'll do is parsing. We will have an int of a double of b, a char of c, and a boolean of d. Int a will equal, we're going to call the integer wrapper class, call a static method of parse int. We can convert a string to an integer. I will convert a string of 123 to an integer. Now with doubles, you will call the double wrapper class, and we will parse a double. We'll pass in a string of 3.14. Now characters don't have a parse method. What you could do instead is with any string, let's say we have a string of pizza, strings do have built-in methods, one of which is the char at method. Return the character at the first position, where index is 0. Again, character doesn't have a parse character method, so you would have to use char at, which is unrelated to wrapper classes. So then with the boolean, we would access the boolean wrapper class, call the parse boolean method, and we can convert a string representation of a boolean, such as true, into an actual boolean. And then let's output them. Now we shouldn't be able to add these together, much like what we did when we used the toString method. For example, string x equals a plus b plus c plus d. This isn't going to work, because we're mixing and matching different data types. And then if I was to output x, that would give us a compilation error. To convert a string to its primitive data type, there's various parse methods to handle that within our wrapper classes. It depends on the data type you're working with. There's a couple other miscellaneous utility methods within wrapper classes. I'll just cover two more. So let's say we have a char of letter. Pick a letter. I will pick the letter lowercase b. I'm going to use a printline statement we can check to see if our letter actually is a letter. We can access the character wrapper class, call the isLetter method, and then pass in our letter. This returns a boolean, true or false. Is this character a letter? That is true. This would be useful for verifying user input. What if this was a $sign? Is this a letter? Well, this returns false. That is not a letter. I'll switch this back to lowercase b. There's also a built-in method to check to see if this letter is uppercase or not. There's a built-in utility method of the character wrapper class to check to see if this is uppercase or not. Character is uppercase, and then pass in our letter. Is it uppercase? Currently it isn't. That is false. But if it were uppercase, that returns true. Some of these utility methods of the character wrapper class would be great for verifying user input, like a username or a password. Alright everybody, so those are wrapper classes. We're basically taking a primitive and wrapping it in an object, kind of like a Christmas present. In the next topic, we're going to be working with array lists, and array lists only work with objects. So we need to utilize these wrapper classes in order to work with array lists. And wrapper classes do provide some useful static utility methods that you can always access. Alright everybody, and those are wrapper classes, and in the next video, we're going to cover array lists. Alright people, it's about time we get to array lists in Java. An array list is a resizable array that stores objects. You can store primitives. If so, you'll be using autoboxing, which we learned about in the last topic on wrapper classes. Arrays are fixed in size, but array lists can change. They're dynamic. Here's how to create an array list. First, we'll follow our similar pattern with creating many objects in Java. Array list, let's say list equals new array list. We will need to make one import. Import java.util.ArrayList. Following the type of array list, we're going to use the diamond operator. This has to deal with generics, which is a future topic, but for now, we're going to specify what type of object we're going to be storing within our array list. And you can always use the appropriate wrapper class to store primitives. For example, if you need to store integers, you can say integer. And then we do need that diamond operator after the second array list. You don't also need to specify the data type within the second diamond operator. Java can infer that. You're going to follow this pattern to create an array list. This array list can store integers. You just have to specify that type. So for example, let's take our list and add a few numbers. 3, 1, and 2. And then we can print our list, our array list. I will print our list. And we have 3 numbers, 3, 1, 2. Now, if you were storing doubles, you would set the type to be double and use the double wrapper class. 3.14, 1.99, 2.01. I'm just making up numbers here. There we go. So let's store strings. Let's create an array list named fruits. We will store the names of some fruit. So the array name is going to be fruits. And then we will print our array list of fruits. Think of some fruit. I will add an apple, an orange, a banana, and a coconut. That should be good enough for this example. And now we have an array list of strings named fruits. Apple, orange, banana, coconut. To add an element to an array list, you can use the add method. Add is a built-in method of array lists. To remove an element, you can use the remove method, then specify an index. So let's take fruits and remove the element at index 0. That should get rid of our apple. Then we have orange, banana, coconut. If we were to remove the element at index 1, that should get rid of our orange. Apple, banana, coconut. There's also the set method. Take our array list of fruits, call the set method. At a certain index, let's say 0, we can set that element to be something else. Let's replace apple with pineapple. Replace the element at index 0 with pineapple. Then we have pineapple, orange, banana, coconut. Or index 1 would be apple, pineapple, banana, coconut. That's the set method. With an array list, to get an element at a certain index, you can use the get method, then specify the element number. Get the element at index 0. That's going to return apple. Get the element at index 1 would be orange. 2, banana. 3, coconut. You can also get the size of an array list. Take your array list, call the size method. That will return the total amount of elements within your array list. So my array list has 4 elements. To sort your array list, you will use the collections framework, call the sort method, and then pass in your array list. Our array list is named fruits, and then you do need to import this class. java.util.collections. After sorting our array list, let's print it. Print my array list of fruits. So these all should be in alphabetical order, starting with A for apple, B for banana, C for coconut, O for orange. So that's how to sort an array list. You can use the collections framework. You could use an enhanced for loop to iterate through all the elements of an array list. So the data type of my array list is strings. We specified that type. For every fruit in my array list of fruits, let's print each fruit. And here they are: apple, banana, coconut, orange. Alright, so now we're going to cover an exercise. We'll create an array and accept user input. A user will enter in all the food that they want within this array list. So to help us with this exercise, we will need a scanner. Scanner scanner equals new scanner. Pass in system.in. Import this class. And then be sure to close your scanner at the end because I tend to forget. Scanner.close. We'll need an array list. Again, we'll follow a similar pattern with creating objects. Array list. Let's say list equals new array list. Using the diamond operator, we're going to specify the type of what we're storing within this array list. We'll stick with strings. Let's rename our list as foods. We'll be storing some food, well, at least the name of food. We'll create a prompt. We'll ask a user, enter the number of food they would like to store. Enter the number of food you would like. And I'll use print rather than print line for the user input. We'll create a variable of num of food to store the number of food that we're going to store. Equals, take our scanner, call the next int method to get the next integer from the user. Once we accept an integer, we should clear the input buffer because there's going to be a new line character within there. Take our scanner, call the next line method to clear it. Let's do a test run. Enter the number of food you would like. I'll just say 3. And that seems to work for now. We have the number of food we're going to store within this array list. In my example, let's say I would like to enter 3 food items. Well, we could use a for loop to iterate 3 times. We will ask a user to enter in a food 3 times then. So we can use a for loop for that. Within our for loop, we're going to create a counter of I, meaning index. We could set that to be 0 or 1. Let's stick with 1. We'll continue this for loop as long as I is less than or equal to our number of food variable. If I would like to enter in 4 food items, this would be 4. So we should iterate this loop 4 times. We will increment I by 1 during each cycle of this loop. During each iteration of this loop, we will ask for a food item. I'll use print rather than print line. We will ask a user to enter food number, then I'll add plus our index of I. So during the first cycle, I is going to be 1, then 2, 3, 4, so on and so forth. Then I'll add a colon, then a space. We'll create a local variable of food. This will be of the string data type. We will set this equal to use our scanner, called the next line method, to get a line of text from the user. Once we have our string of food, we're going to add it to our array list of foods. So take your array list of foods, call the add method to add an element. We will add our string of food to our array list of foods. And then once we're done, let's print our array list using a print line statement. We will print our array list of foods. Alright, let's test it. Enter the number of food you would like. I'll say 4. So we should ask for 4 food items. Enter food number 1. I'll say pizza, hot dog, hamburger, and then taco. And here's my array list of food. Pizza, hot dog, hamburger, taco. Alright everybody, those are array lists. An array list is a resizable array that stores objects. You can store primitives. You're just going to use Java's auto-boxing feature if that's the case. Once you have your array list, there's various methods to add, remove, or set elements. And well everybody, those are array lists in Java. Today I'm going to talk about exceptions using Java. An exception is an event that interrupts the normal flow of a program. These exceptions pop up if you do things like divide by 0, you can't find a resource for some reason, or if there's a mismatch with the input type. Let's say the program asks for a number and you type in a string of characters. These sorts of events interrupt your program. They're called exceptions. There's a way that we can handle them, and that is by using a few blocks of code. Try, catch, and optionally, finally. So any code that's considered dangerous, where it might interrupt your program, you can surround with a try block. Here's an example. So let's say I'm going to take the number 1 and divide it by 0. Mathematically speaking, you can't divide by 0. That causes an exception. More specifically, an arithmetic exception. I'm actually just going to copy this and save it. This code is dangerous. It's interrupting our program by causing an exception. We can gracefully handle this exception so that it doesn't interrupt the normal flow of our program. Any dangerous code, we're going to surround with a try block. Try and a set of curly braces. There we go. However, if we have a try block, we also need a catch block. We will catch any exceptions, but we're going to list the specific kind of exception we're going to catch. Well, let's catch that one exception, that arithmetic exception. This is the type. We're setting up a parameter here. Arithmetic exception is the type. We will give this exception a name of E for a nickname. If we encounter this exception, we can take a different course of action instead of interrupting the program. So let's do the following. Let's output, you can't divide by 0, idiot. So if we run this again, it shouldn't interrupt our program. We catch this exception and output this text instead. So any code that's dangerous, where it might cause an exception, you can surround with the try block. You can add more than one catch block to catch and handle specific exceptions. So this time we're going to accept some user input. We'll need a scanner. For now, I'm going to write the scanner outside of the try block. Near the end of this video, there's a feature called use with resources. I'll show you how to do that later. Scanner equals new scanner. Type system.in, and then import this class. Import java.util.scanner. Anytime you accept user input, it's almost always dangerous code, because a user can type in anything. This time, let's prompt a user to enter a number. And I will use print. Let's create a local variable of int number equals use our scanner, call the next int method to accept an integer. And then we'll just output our number. Enter a number. How about no? I'm going to type in the word pizza instead. Well, we get an exception. An input mismatch exception. Java was expecting an integer, but we typed in a string instead. We can handle these exceptions too. And I'm just going to copy the name of this exception, because we'll reuse it. let's catch the following. Let's catch any input mismatch exceptions. This is the type. We will give this exception a nickname of E. So this exception we actually do have to import. Import java.util.input mismatch exception. In case there's a mismatch with the data type, we're asking the user for a number, but they type in a string. Let's output the following. Let's say that wasn't a number. Let's try it again. Enter a number. I'll type in the word, I already did pizza, let's do taco. That wasn't a number. And our program finished with no problems. You can catch and handle more than one exception. There is a catch-all statement that you could add. You could catch all exceptions, exception E. Using this by itself isn't good practice. You want to let a user know exactly what went wrong. If all else fails, and there's an exception that you don't anticipate, you could just say, something went wrong. You could technically use this by itself. Enter a number. For example, I'll type in hot dog. Something went wrong. This does prevent our program from being interrupted. It is good practice to let the user know what went wrong exactly. I'm looking at you, Microsoft. Catching all exceptions acts as some sort of safety net. You should only do it at the end, in case there's something you don't anticipate. It is better to catch and handle specific types of exceptions, because you can let the user know what went wrong exactly. Now, there's also the finally block. This is optional. Finally will always execute, whether there's an exception or not. This is where you might clean up any resources. For example, with my scanner, I forgot to close it. We can actually close it within the finally block. When we're done with our scanner, let's close it. Because if we encounter an exception, we might not close the scanner. Other times finally might be useful is if you open a file within a try block, then you'll want to close the file when you're done with it. You can do that within the finally block. For testing purposes, I'm just going to add this always executes. All right, let's do a test run. Enter a number. I'll type in 123, and then we output 123. See, that finally block does execute. This always executes. If we encounter an exception, enter a number, I will type in taco. We get our exception message for input mismatch, and then that finally block does execute. Finally is quite often used for cleanup, cleaning up your program when you're done with it. When you open a file or resource, you want to close it. We'll have more practice with this on the next topic of file handling. Now, there's also try with resources. And actually, Java is recommending this. Rather than declaring our scanner outside of the try block, we can place within a set of parentheses. And then Java is automatically going to close those resources when it's done opening them. So this works too. So enter a number, 123. Enter a number, pizza. That wasn't a number. All right, everybody, so those are exceptions. They're events that interrupt the normal flow of a program. Exceptions occur when you divide by 0, you can't locate a resource, or there's a mismatch of the input type that a user types in. You'll want to surround any dangerous code with a try block. Anytime you accept user input or try and locate an external resource, that's almost always dangerous code. Try any dangerous code, catch any exceptions, and optionally, you can add finally to do any resource cleanup. And well, everybody, those are exceptions in Java. Alright everybody, in this video I'm going to show you how we can write a file using Java. After doing some research, I've encountered 4 popular options. The first way I'm about to show you is the most simple, and it's what I'll be demonstrating in this topic. We'll be using a file writer object. It's good for writing small or medium-sized text files. There's also buffered writer. This has better performance for large amounts of text. Print writer is best for structured data, like reports or logs. Then there's file output stream, which is best for binary files such as images or audio files, files of that nature. In this topic, I'm going to cover file writer, just so we get the hang of the basics. I might make videos on the other writers, but I haven't decided yet. Here's how we can write a basic file using Java. we'll need a file writer object. File writer, I'll name this file writer just writer for short, equals new file writer. Then we need to pass in a file path or a file name. Let's create a file named test and include a file extension. Let's say it's a txt file, a plain text file. Now you could include an absolute file path. I'll show you how to do that later. Our plain text file, a test, is going to appear in our source folder. Reading or writing files is kind of unpredictable. You could consider that dangerous code. Any dangerous code we want to enclose within a try block. Try, this dangerous code, catch any exceptions that might interrupt our program. With modern Java, you can try and open up some resource. Add a set of parentheses after try. We will try to open up a file writer object. So, file writer, writer equals new file writer. Then we have our file name, including the extension. Now we do have to import this class. Import java.io.filewriter. If for some reason we can't write this file, we might encounter an exception. We will catch any I/O exceptions. I/O meaning input-output. Catch any input-output exceptions. That's the type. We will give this exception a nickname of E. Then we do have to import this class too, in order to work with I/O exceptions. Java.io.ioException. In case there's a problem writing this file, we'll catch this exception if it comes up. This acts as more of a safety net. If we encounter this exception, we can say something generic such as could not write file. But it is best practice to handle specific kind of exceptions first. Momentarily, we're going to add a catch clause for a file not found exception, in case we can't locate a file path, but we'll take care of that in a moment. Within the try block, in order to write a file using Java, using file writer, we will take our file writer, which we named writer, call the write method, and then pass in a string. Let's say I like, then pick your favorite food. As you know, my favorite food is pizza. Then after writing this file, if we don't encounter any exceptions, we'll print a confirmation message. Let's say the following. File has been written. All right, let's test this. File has been written. Since we didn't specify a file path, your file is likely going to be within your source folder. And here's mine, test.txt. And it says the following, I like pizza. Now, you could pick a different location. For example, you could use an absolute file path. So let's say I would like to write this file to my desktop. So what I could do, I'm going to go to my desktop. I'm going to get the file location on my desktop. I'll just right-click on one of these folders. Go to Properties, copy this location. Then I'm going to paste that file path. You'll likely need to use double forward slashes. Java interprets a single forward slash as an escape sequence, so you may need to use double slashes. When I write this file, it should be at this location, this absolute file path. Let's test it. File has been written. Let's go to my desktop, and here's that file. Test. It says, I like pizza. Let's say that we get the file path wrong. Instead of desktop, I'll misspell this as desto. Run this again. We encounter that exception, could not write file. That's because Java couldn't locate this file path. I misspelt it. Now, when handling exceptions, it is best practice to catch specific types of exceptions first. Here we're relying solely on our safety net that catches all input-output exceptions. Another kind of exception that we can catch is the following. File not found exception. We will give this a nickname of E. Then we do need to import this class, java.io.filenotfoundException. This is if we can't locate a file or a file path is invalid. So let's output the following. Could not locate file location. Let's try that again. Remember that my file path is misspelled. Could not locate file location. Let's spell this correctly this time. I'm going to delete this file. Maybe I'll add another line of text. I like pizza. It's really good. Okay, let's try that again. File has been written. Going to my desktop. Here's that file. And it says, I like pizza. It's really good. For better organization, what you could do is create a string of file path and set that equal to a string. We're going to cut everything within our file writer and paste it within the string. We're going to assign the string of text equal to a string variable, a file path. Then we'll pass in the string variable to the file writer. And instead of passing in a string literal to the write method of our file writer, for better organization, let's create a string of, let's say, text content equals, and then we'll cut our text. And then pass in the text content. Let's see, I'll add another line. I like pizza. It's really good. Buy me pizza. Okay, let's run this again. File has been written. Go to our test file. And here's our test file. I like pizza. It's really good. Buy me pizza. If you have a string that takes up multiple lines, another option is to write a multi-line string by using a triple set of double quotes. So this is if you have a lot of text. This time I'm going to write a poem. Roses are red. Violets are blue. Booty, booty, booty. Rockin' everywhere. Alright, so this is a multi-line string. You use a triple set of double quotes. That's if you have a lot of text to write. Okay, let's test it again. File has been written. Let's go to our desktop, open this file, and here's our poem. Roses are red, violets are blue, booty, 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 rockin' everywhere. Alright everybody, so that is how to write a file using Java. To write small or medium-sized text files, you can use a file writer, but you will need a try and catch block. And well everybody, that's how to write a file using Java. Hey everybody, in this video I'm going to show you how we can read a file using Java. After doing some research, there's 3 popular options. The first, and which I'll demonstrate in this video, is to combine a buffered reader and a file reader both together. This technique is best for reading text files line by line. Buffered reader can't read a file by itself. You can say that it acts as a middleman between the program and the file system. It helps us read files more efficiently. And a file reader is what actually reads the file. So we'll be using these two together, which I will demonstrate momentarily. Another technique is to use a file input stream, which is best for binary files, such as images and audio files. Then there's also random access file. That's best for reading or writing specific portions of a large file. So use this if you need to read something specific from a big file. In today's video, we're going to combine a buffered reader and a file reader together. But first, we need a file to work with. Pick a location where you would like to read this file from. For me, I'm going to create a file on my desktop. I will create a new text document. I'll name this test. And what should our file say? Think of something to write. So there's a poem that I like to use. Roses are red. Violets are blue. Booty, booty, booty. Rockin' everywhere. We will need to name this file, including the file extension. I'm going to right-click, go to Properties. This file is a plain text file, a txt file. I'm going to copy this location. I will create a string variable named filePath equals, then within a set of quotes, because we're working with strings, I will paste that file path and include the file name, including the extension, test.txt. Now we're going to be combining a buffered reader and a file reader together. First, we will create a buffered reader object. Buffered reader, we'll name this reader equals new buffered reader. we will need to import this class. Import java.io.bufferedReader. We can't create a buffered reader object without first passing in a reader object, which is why we'll be combining this with a file reader object. Within the constructor, we'll be passing in an object, a new file reader object. And then we do need to import this class too. Import java.io.fileReader. Within the constructor of our file reader, we're going to pass in that file path, that string. When reading and writing files, you'll need try and catch blocks. You can see that Java is already giving us a warning. When working with files, it's considered dangerous code, because you don't know if you'll actually locate that file or not, or reading or writing that file might be unsuccessful for some reason. We will use a try and catch block. Try this dangerous code, catch any exceptions. With modern Java, you can use with resources. We will add a set of parentheses after try, copy the snippet of code where we create a buffered reader object, and then paste it within that set of parentheses. Remove the semicolon. When using try with resources, you'll automatically close this reader when you're done with it. We're going to catch any file not found exceptions within the catch block. So catch file not found exception. That's the type. We will give this exception a nickname of E within the parameter, and we do need to import this class as well. Import java.io.filenotfoundException. If for some reason we can't locate this file at this file location, let's output the following. Could not locate file. To catch all other input-output exceptions, we'll add another catch block. This will act as a safety net. We will catch any I/O exceptions. I/O exception. We will give it a nickname of E. This is where we'll say something went wrong. And import this class as well. Just temporarily within our try block, I'm going to output that file exists. So let's test it. That file exists. So that file is at this file location on my desktop. For some reason, if we can't locate that file, let's say that I misspelled desktop as desto, run this again. Well, we get that exception, that file not found exception, could not locate file. Let's make sure the file path is correct. Now here's how to actually read the file. Within our try block, let's create a local variable of line. We'll be reading our file line by line. Since we're reading this file line by line, we'll be using a while loop. During each cycle of the while loop, we're going to write the following within a set of parentheses. We're going to set our string of line equal to, use our buffered reader object, call the read line method. We're taking our reader, reading the current line. This will return a string, which we're assigning to the string variable of line. After reading one line, our reader is going to point to the next line. However, if we run out of lines, the readLine method is going to return null. So we're going to continue reading lines while line does not equal a value of null. Use the reader, read each line, assign it to this variable of line. If we run out of lines, if this is null, we'll escape the while loop. During each cycle of the while loop, we'll output each line. It's going to be a string. And now this should work. Let's test it. And here's our poem. Roses are red, violets are blue, booty, 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 rockin' everywhere. So that's one way in which you can read a file using Java. You can combine a buffered reader and a file reader. It's best for reading text files line by line, but there's other methods you should be aware of too, such as file input stream and random access file. I'm not sure if I'll make videos on these yet. And well everybody, that's how to read a file using Java. Hey everybody, in this video we're going to create an audio player using Java. Let's get started. Alright, let's get started everybody. Now in this following project, what I'm about to show you isn't compatible with MP3 files, but you could easily convert an MP3 file to a WAV file. You can do that online. Otherwise, to play an MP3 file, you'll need an external library or framework such as JavaFX. And I do have another video on that. If you need some sample of music, you can always use YouTube's audio library. These songs are free to use, as long as they're within the context of YouTube. You can search for songs, find one that you like, and download it. This is the song I picked. It's currently an MP3 file. I'll need to convert it to a WAV file. You can easily look up an MP3 to WAV converter. Select a file. Convert to WAV. Convert. Download. For convenience, I'm going to put this on my desktop. I'll delete the MP3 file. And we now have a WAV file. To make this even more convenient, I'll place this WAV file within my source folder so that I don't need to use an absolute file path. So, we're ready to begin. Once we have a WAV file, we're going to create a string for our file path. You can use an absolute file path or a relative file path. Since this WAV file is right next to my main Java file, I can use a relative file path easily. We're going to copy the name of this file. We're going to copy path, file name, and then paste it within the string. The song that I picked is A Caring Friend, and this is a WAV file. Be sure to include the extension too. Once we have our file path, we'll create a file object. But we have to pass in our file path as an argument to create a file object. File equals new file. Then within the constructor, we will pass in our file path to the file constructor. Then be sure to import this class for file. When handling files, it's considered dangerous code. Because accessing files can be unpredictable, we'll use a try and catch block. Try this dangerous code, catch any exceptions. One exception that we may run into is an IO exception. We'll give it a nickname of E. Then be sure to import this class. This catch statement will act as a safety net to catch any unexpected IO exceptions. Here we'll output something went wrong. It is better to handle specific kinds of exceptions first. We will do that momentarily. Within the try block, we will create an audio input stream object. That's the first step to playing audio. The type of this object is audio input stream. Let's name this object just audio stream. Equals, we will access the audio system class. We're accessing it statically. So we type the name of the class. Call the get audio, let me zoom out a little, get audio input stream method. And then we will pass in our file object. Be sure to import this class too. We'll be doing a lot of importing, so get used to it. Now with the get audio input stream method, we have to add a catch clause for any unsupported audio file exceptions. Well, we can write a catch block for that. Catch the following exception type, where the type is unsupported audio file exception. This is if somebody tries to use an audio file that's not supported, not one of the following. We will give this a nickname of E, import this class, then we'll output the following. Audio file is not supported. Be sure to import the audio input stream class too. Now, when you open this audio stream, you do want to close it. So in modern Java, you can use try with resources. Add a set of parentheses after try. We will cut the snippet of code and paste it within the set of parentheses. Delete the semicolon. If you use try with resources, you'll automatically close this object when you're done with it. You don't need that finally clause. So now we're going to create a clip object. Clip equals access the audio system class. We're doing it statically. Call the get clip method. Import this class for clip. In simple terms, a clip is like a music or sound player. It allows you to load an audio file and then play, pause, stop, or reset the audio. So it gives you some controls. And we do need a catch clause for this too. for any line unavailable exceptions. So let's add that catch clause. In case we encounter a line unavailable exception, which we will nickname E, you might encounter this exception if another resource is trying to access that audio file, or if it's unplayable for some reason. It's unavailable. We could output something such as unable to access audio resource. Then import this class as well. There we go. Once we have our clip, it gives us some controls, but we do have to use it to open the audio stream object. We will take our clip object, call the open method, and then pass in our audio stream object. The clip object, which is our player, is going to open our audio stream. Now we're not going to play it quite yet. Before we actually do play it, I'm going to add another catch clause. We're going to catch any file not found exceptions if we can't locate our audio file. File not found exception of E. We'll output could not locate file. Import this class too. So we have 4 catch blocks. The last one acts as a safety net. Now let's be sure that we can locate this file first. So temporarily, let's output no problems detected. I'm going to run this program. Could not locate file. If that's the case, with our relative file path, we're going to access the source folder, then access that audio file. There it is, no problems detected. If this file is unsupported, let's say it's MP3, I'll bring back my MP3 file, move it to my source folder, then I'll switch this to MP3. Then we should get an unsupported audio file exception if that's the case. Yes, audio file is not supported, because we're trying to use an MP3 file. So let's switch that back to WAV, or whatever yours was originally, and delete our MP3 file. We were just testing it. Alright, now we're actually going to play the clip. Now, one last thing that I'm going to add, it's optional. I'm going to add a finally block. Once we're done with this program, we can output the following. Let's just say bye. This will make sense in just a moment why I'm doing this. There's one problem we're going to encounter when we play our audio. Now to actually play the audio, we're going to take our clip object, call the start method to start the audio. Here's what happens when I run this currently. The music may play for just a brief second. We print bye, then exit the program right away. The issue that we're running into is that our program doesn't wait for the audio to finish. Once we start the clip, we immediately end the program. So we need some way to keep the clip open, and there's a bunch of different options. You could use threading within a while loop to check to see if the clip is still running, but I haven't taught that yet. So here's another option. We'll create a prompt for the user to play, stop, reset, or quit the audio program. The audio will continue playing unless the user decides to stop or quit the program. So we'll need a scanner to work with to accept user input. Scanner equals new scanner. Pass in system.in. Import this class. Now, if you open a scanner, you do want to close it when you're done with it. You can do that within the finally block like this. Scanner.close. With modern Java, you can use try with resources, which will automatically close any resources. And we can do that with our scanner too. Let's cut our scanner, paste it within the try block. Now be sure to include the semicolon. Our scanner is going to automatically close when we're done with this program, because we're using try with resources. You can use try with resources if an object implements the auto-closable interface. Scanner and audio stream both do. Clip doesn't, so we'll keep that within the try block. Rather than start our clip, let's create a string variable of response. We'll create a while loop. While our response equals, let's say, capital Q. Now we want to say while our response doesn't equal capital Q. We'll use the not logical operator. And to make our while loop happy, we do have to initialize our response. We'll set that to be an empty string. So a user is going to type in a response. As long as it's not Q, meaning quit, we'll continue the program. Within the while loop, we'll give a user a few options. Let's output the following. Let's say P equals play. Let's copy this print line statement. S equals stop. R is to reset. And Q is to quit. Then we will ask a user to enter your choice. I'll use print rather than print line to keep the user input on the same line. We'll take our response, which is a string, set it equal to, use our scanner, get the next character by calling the next method. In case a user types in a lowercase character, we can make it uppercase by method chaining the to uppercase method. All right, we'll do a test run. And let's be sure that we start the clip, just temporarily, clip.start method. What's likely going to happen is that we'll start the audio clip, and it won't stop until we press Q to quit. So here's the audio. Hopefully you can hear me. Once I press Q, the program's going to stop. It's because the program closes down and exits. Now we want to give the user a few options after they type in their response. We can use an enhanced switch for this. Let's also be sure that we delete the start method of our clip. We don't want the audio clip to start until the user presses P to play. We will create a switch. We will examine our response. Does our response match any cases? If our response matches a case of P, we'll write an arrow to do the following. Take our clip, then call the start method. If our response matches a case of S, that means stop. Take our clip object, call the stop method. If our response matches a case of R, do the following. Take our clip. To reset, you're going to call the set microsecond position, then pass in 0. Do pay attention to the capitalization. S is lowercase. If our response matches a case of Q, take our clip, call the close method to close the clip. Then if there's no matching cases, let's output the following. System.out.println, invalid choice. All right, and that should be everything. Enter your choice. Just to be sure that the default case is working, I'm going to type taco. Invalid choice. We'll press P to play. S to stop. P to play again. R to reset. And Q to quit. Alright everybody, that is an audio player that you can write using Java. What's up everybody? In this video we're going to create a working game of Hangman using Java. A user is going to guess certain characters, and we'll see if there's a match within a secret word. Near the end of this video topic, we'll be importing a file of words, and one of those words will be secretly selected. So let's get started. Alright, let's get started everybody. Near the end of this video, we'll have our program choose a random word from a list of words. But to keep this program simple in the beginning for testing purposes, let's create a string variable of word. Here we'll select a word that we're going to use throughout the program just for testing. Pick a word. For me, I'll say, you know what, let's go with pizza. So this will be my word. So we have our word. We'll be accepting user input, so we need a scanner. Scanner equals new scanner. Pass in system.in. Import the scanner class. And close your scanner at the end of the program. Scanner.close. Here's where we'll be working with array lists. We will create an array list of characters. To do that, we type array list, then specify the type within a set of angle brackets. We can't use primitives such as char. We'll have to use the wrapper class of character to store characters. I will name this array list word state equals a new array list. Use the diamond operator, set of parentheses, semicolon. We'll need to import this class. Now, within the diamond operator, you don't need to list character again, even though that does work. Java can infer what the type is. In the beginning, our word state is going to contain a bunch of underscores, and we're going to fill them in one letter at a time by guessing. We'll also need a variable to keep track of our wrong guesses. Int wrong guesses. This will initially be 0. We'll set that equal to be 0. Within our array of word state, we're going to add an underscore for every letter within our word. We'll create a for loop that will cycle once for every letter in our word. Here's how we can do that. So we'll start with a basic for loop, create an int of I for index equals 0. We'll continue as long as I is less than, take our word, and strings have a built-in length method. Return the length of this word. So in this case, it's going to be 5, because there's 5 letters in this word. Then increment I by 1. During each cycle of this for loop, we're going to take our array of word state and add a character by using the add method. We will pass in an underscore character. Be sure you're using single quotes, not double quotes, because these are chars technically, not strings. All right, let's do a test run. I'm going to output our word state to see what we have. So we should get 5 underscore characters. And we do. 1, 2, 3, 4, 5. P-I-Z-Z-A. Throughout this game, by guessing letters, we'll be filling in this word state by replacing the underscores, if there's a match. Let's change this word, just so we know that everything's working. I will pick watermelon, because that's the first thing that came to mind. So watermelon has 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we know that that works. I will switch it back to pizza, delete this print statement, and we can move on. Word state is an array list made up of characters. Currently, they're all underscores, but we'll be replacing each with a character if we get the correct guess. After the for loop, why don't we create a welcome message? Let's say, welcome to Java Hangman. Now, you don't need to do this, but I'm going to add some decorators. Just a bunch of asterisks, before and after. Again, you don't need to, but I think it looks cool. Let's make sure everything looks okay. Welcome to Java Hangman. For our hangman, we're going to display some ASCII art. Outside of our main method, we're going to declare another method that's in charge of returning ASCII art based on the number of wrong guesses that we have. This will be a static method. It's going to return a string. We'll name this method getHangmanArt. We will have one parameter. We have to pass in how many wrong guesses we have. Then, depending on the number of wrong guesses, we'll return a certain image, represented as a string. Within our getHangmanArt method, we'll be returning a string representation of our ASCII art. We can best do this with a switch. Now, a switch can return something. We'll use the return keyword, create a switch, end it with a semicolon. Within our switch, what are we examining? We're examining the number of wrong guesses. This will be a number 0 through 6. We'll need a case for each of those numbers, for each of those guesses. Depending on how many wrong guesses the user has, we'll display one of a few images. So here we'll be working on our art skills today too. If we have a matching case, where wrong guesses matches a case of 0, that means they have no wrong guesses. Case 0, arrow, meaning do this, will return the following. In Java, you can write a multi-line string, but you have to use a triple set of double quotes. And I'm just going to line these up. Within this triple set of double quotes, I'll have 3 empty lines between them. we won't display anything if the number of wrong guesses is 0. Then for case 1, if a user has 1 wrong guess, we'll display our man's head, represented by an O. If wrong guesses is 2, we can represent that with case 2. We will draw the man's body, represented by a vertical bar. Case 3 will be the left arm. For the left arm, we'll use a forward slash. For case 4, that'll be for the right arm, we'll use a backslash. In Java, a backslash is actually an escape sequence. To display a backslash, we have to use double backslashes. Case 5 will be for the left leg. It's kind of like we're assembling Exodia, if you know the reference. And then case 6 is for the right leg. We'll need 2 backslashes. We'll want a default case if there's no matching cases. We'll just return an empty string, just to make Java happy. Alright, and this method is done. Based on the number of wrong guesses, we'll return one of a few strings. Let's test it. I'm going to use a printline statement, call our getHangmanArt method. We'll start with 0. 0 wrong guesses. We should end up displaying 3 empty lines. If wrong guesses is 1, we should display the hangman's head. 2. 2 is for the body. 3 is for the left arm. 4 is for the right arm. 5 is for the left leg. And 6 is the full body. That's when we lose. When wrong guesses is 6. Alright, we know that the getHangmanArt method works. I will collapse it because we're done with it. To get the art for our hangman, we just have to call this method, then pass in the current number of wrong guesses. Let's delete this printline statement, we no longer need it. Now, when we print our word state, let me show you. We get this ugly formatting, where we have a set of straight brackets, then all the underscores are comma separated. We can customize that. So here's what we'll do. After our welcome message, we'll output the following. We'll output the word, colon, space. I'll use print. I want to stay on the same line. We'll create a for loop, an enhanced for loop. For every character in our array list of word state, we're going to display an underscore with no formatting. Using an enhanced for loop, we have to list the data type of what we're cycling through. We're cycling through an array of characters. Char, a common convention with enhanced for loops, is to name each letter C, because we can't use char because that's a data type. And character is kind of long, so C is short for characters. For every character of C in our array list is named word state. We'll do the following. We will output our character of C plus a space. So then when we output this, let's use print rather than print line, because we want them all in the same line. That's much better. That output looks a lot nicer. Each letter is an underscore. They're all separated with a space. When we guess each letter, we'll be flipping these underscores to its matching character, if they do match. I'll add an empty print line just so we go down to the next line. Okay, for the next part, we'll have a user guess a letter. We'll need some user input. We'll need a prompt. Guess a letter, colon, space. I'll use print, not print line. We'll create a variable of guess. Guess will be a letter. We'll need to accept user input. We'll need to accept user input using our scanner. Scanner.next. Next we'll get the next character. Now, since we're working with lowercase characters, we can method chain the to lowercase method, just to make it lowercase if somebody types in an uppercase character. To lowercase. Okay, to lowercase method. Using next, the user input's going to be a string, not a character. We can easily convert that to a character by using the char at method. But we have to pass in an index. We're only accepting a single character, so we'll use char at 0. We're telling Java, with the string that the user types in, give me just the first character, and convert it to be a char. So guess is going to be a single letter. It'll be of the char data type. Alright, then let's test it. I will output our guess. I will guess an uppercase p. We'll end up outputting a lowercase p, which is good. How about a z? Yep, our guess is z. If I were to type in a full word, like pineapple, we still end up with just the first character in our string. Which is good, though. Let's delete this printline statement. We no longer need it. For this next part, we're going to check to see if our guess matches any letters within our word. We'll use an if statement for that. If, take our word, it's a string, in this case pizza, we'll use the built-in index of method, and then pass in our guess. So basically with the index of method, it's going to return the index within the string of the first occurrence of the specified character. For example, let's say I guess the letter Z. Well, Z is in the word pizza. It's at index 2. That's the first occurrence. If my guess was Z, index of is going to return the number 2, because that's the first occurrence of Z. We will check if the first occurrence is greater than or equal to 0. That means there's a matching letter if that's the case. If there's a matching letter, we'll output correct guess. And then I'm just going to add a new line character to the end. All right, let's do a test run. I will guess the letter Z. That's a correct guess. But are there any X's? There is not, so we don't output correct guess. If it's the wrong guess, we can output, using an else statement, wrong guess. Then I'll add a new line character to the end. Let's try that again. I will guess an X. Wrong guess. There are no X's in the word pizza. Okay, so within our if statement, if we get the correct guess, we're going to change our word state to reflect it. That's one less letter that the user has to guess. We're going to cycle through the length of our word using a for loop. For int I equals 0. We'll continue as long as I is less than our word's length by calling the length method. Then increment I by 1. We have to see where there's a match exactly, which index within our word. We'll use an if statement. We will take our word, in this case pizza, call the char at method, then pass in our index of I. During each cycle, I is going to increment, but during the first cycle, it's going to be 0. So we're saying, take our word, in this example pizza, give me the first character. So for pizza, that would be the letter P. Is that equal to, using the comparison operator, our guess? So let's say I do guess P. The first character of my word is P. That means that they match. We're going to take our array list of word state, and we're going to update it by using the set method. We have to pass in an index and a new value, our guess. Let's test it. So with the word pizza, are there any Z's? Correct guess. Oh, then we have to output it too. We're going to continue playing as long as wrong guesses is less than 6. Once wrong guesses is 6 or greater, then the game ends. So let's cut this portion of code. Cut it, don't delete it. We'll write a while loop. While our wrong guesses variable, wrong guesses is less than 6. We'll continue playing this game. Within the while loop, we'll paste all that code again. Let's do a test run. Guess a letter. I'm going to guess Z. So that should update our word to reflect two Z's, because my word is pizza. But if there's no matching letters, it doesn't get updated, because there's no matches. Let me fill this in. P-I-Z-Z-A. And we get the full word. Alright, that's good. So far, so good. So, we'll need to keep track of wrong guesses. Within our else statement, we're going to take our variable of wrong guesses, increment it by 1, using the increment operator. Then, back to the beginning of the loop, we're going to display our hangman art by calling the getHangmanArt method. This method will return a string, so we can put that within a print statement. Let's use print, call the getHangmanArt method, then pass in the number of wrong guesses. Let's do another test run. We have 3 empty spaces, because we haven't displayed any parts of the hangman yet. I will guess the wrong letter, X. We get the head of the hangman. I'll guess some more wrong letters. C, V, B, N, M. At the end, we'll have to display the full hangman when we lose. Let's display the right letters. P, I, Z, A. Okay, good. What happens when we lose if wrong guesses is 6 or greater? So, outside of the while loop, our while loop ends right here. We'll write an if statement. If our variable of wrong guesses is greater than or equal to 6. Okay, we will again use a print statement, call the getHangmanArt method, and then pass in the number of wrong guesses. We'll also display a game over message. Game over. Then display the word. The word was colon space plus our original word of pizza. Let's do a test run again. I'm going to guess the wrong characters. Alright, game over. We display the full hangman. The word was pizza. I think I'm going to make a few changes. I'm going to remove these new line characters. It's a little too much space, I think. Alright, we're good. So, how do we win? Let's add that after the for loop. If we get a correct guess, we'll check to see if our word state doesn't contain any lowercase characters. So take our array list of word state, call the contains method, and then pass in an underscore character. But we want to check to see if our word state doesn't contain any lowercase characters. We can prefix this with the not logical operator, an exclamation point. If our word state, doesn't contain any lowercase characters, that means that we guessed all the letters, and we win. If that's true, let's display our hangman one last time. System.out.print, getHangmanArt, pass in the number of wrong guesses, and we'll display you win. And display the word again. The word was colon space plus our word. Then we'll want to break out of this loop, because we're stuck in a while loop. We can use a break statement after we win to break out of the loop. Alright, let's see what we're working with. I'll guess a few wrong letters. X, C, V, B, N. Alright, one more wrong guess and I lose. Game over, the word was pizza. Alright, I'll actually win this time, but I'll guess a few wrong characters. Q, W, E, R, T. I'll guess some correct characters. A, Z, I, P. You win, and we display our current score. The current state of our hangman. We display you win, the word was pizza. In this next part of this video, we're going to create a more advanced version of this program by importing a file of words. A word is going to be randomly chosen from a file, instead of just setting one in the beginning. Okay, everybody, in this next section, we're going to create a file that contains all the words that we can possibly use for this hangman game. Within our project folder, why don't we create a new file? File, new, file. I'm going to name this file words, and this will be a txt file. For all the different possible words in this game, place within this file. You can copy and paste them from somewhere online if you would like. Just to make reading this file as simple as possible, I'm going to list all the words on a separate line. So think of some words, or like I said, copy and paste them from somewhere. I'll just add several. Apple, orange, banana, coconut, pineapple, grape, lime, lemon. That's good enough. In my project folder, I have this file, words.txt. Temporarily, with my game, I'm going to write a multi-line comment and just comment all of this out until we're ready to bring it back in. At the top of my hangman game, I will create a string named file path. This will contain either a relative file path or an absolute file path. Since this file is in my project folder, I just have to list the file name, words.txt. We're going to read this file line by line. We'll store each word in an array list. We'll create a new array list. Array list. The data type is going to be strings. So string. I will name this array list words equals new array list, diamond operator, parentheses, semicolon. Now we'll actually need to read this file. Reading files is considered dangerous code because it's highly likely that something can go wrong. We will write a try with resources block. We need that set of parentheses after try. We will catch any exceptions. When you try with resources, you'll automatically close any resources listed within the set of parentheses. Within the set of parentheses, we will create a buffered reader object. Buffered reader, which we will name reader for short, equals new buffered reader. Now, a buffered reader by itself can't read files. We do have to pass in a file reader to the constructor. New file reader. Then within our file reader constructor, we will pass in our file path, the location to that file. Now our file reader object wants us to catch any file not found exceptions. We'll place that within our catch block. File not found, exception of E. Then we'll output, if we can't find this file, could not find file. We'll add another catch block just as a safety net. We'll catch any IO exception E exceptions. This is where we'll say something went wrong. This just acts as a safety net if there's something we don't anticipate. So we have our reader object. Within the try block, we will create a local variable, it's a string, of line. We will read this file line by line using a while loop. While, within a set of parentheses, assign our line equal to, use our reader, call the read line method. If we run out of lines, this is going to return null. While the value that's returned does not equal null, we'll continue reading this file. Reader is going to give us each of these words line by line. We're going to assign them to our array list of words. Take our array list of words, call the add method. We will add the current line. If there's any white space after these words, this will pick that up, and our program will consider them to be characters. We will use the trim method after line to trim that white space. Let's perform a test run. I'm going to output our array list of words. Yep, and here's our words, all within an array list. Let's delete that line. We're going to choose one of these words at random. We'll need a random object. Random equals new random. Import the class. Here's where we're going to choose our word. I'm going to copy this from the previous code and paste it. Rather than setting our word to be a hard-coded string, we're going to take our array list of words, call the get method. But we have to specify an index. With our array list, return a string at a given index. That index is going to be randomly generated by using this random object. We will pass in a random object, call the nextInt method to generate a random integer. The range of random numbers is going to be dependent on the size of our array list of words. Take our words, call the size method. So with our file, I have, let's see how many words, how many strings. 1, 2, 3, 4, 5, 6, 7, 8. The size method of words is going to return the number 8. Just imagine that I'm replacing this with the number 8. Return a random index between 0 and 8. That's kind of how that works. And then let's output our word for testing purposes. What is my word? This time my word was pineapple, but it's likely going to change every time you run it. Apple, lime, apple again, pineapple, grape. It really likes pineapple for some reason. Let's delete this print line statement. We'll integrate our code back into the program again. We can delete that multi-line comment. And let's run this program one last time. We should now have a randomly chosen word. I don't know what it's going to be. For me, it's 6 letters. I'll guess some of the vowels. A, there's one A. E, I, O, U. It's probably orange, but I'm going to guess some more wrong letters for testing purposes. Okay, game over. The word was orange. Let's run it again. This one is 7 letters. A, E, I, O, U. It's coconut. C-O-C-O-N-U-T. You win. The word was coconut. Alright everybody, that is a game of Hangman that you can code using Java. Hello there everybody, in this video I'm going to show you how we can work with dates and times using Java. This serves as more of an introduction. We can work with local dates, times, date times, and UTC timestamps. Let's get the date right now using local date. We will create an object of local date. Let's name this date for short. Equals access the class of local date. Call the now method. If I was to output our date object, we'll print our date. That's going to give you the current date, whatever it is right now. I'm filming this video December 17th, 2024. Post the date that you're watching this in the comment section down below. That is local date. There's a local time to get the time. Let's replace date with time, local time.now. And rename this as time, because that's more appropriate. Print the time. Currently the time for me is a little after 9 a.m. 9 hours, 29 minutes, 52 seconds, and a bunch of milliseconds. To retrieve both the date and the time, you can use datetime. Local datetime. Local datetime.now method. Print the current date time. And currently for me, it is December 17th, 2024, at about 9:30 in the morning. You can also use UTC time. That's a little different. We will create an instant object, instant equals access the class of instant, called the now method, and print our instant object, which will give us the current date and time in UTC. December 17th, 2024, in UTC time, I think that's 3 p.m. It's in military time. That's how to get either the current date time, or UTC timestamp. When you output the current date and or time, it's kind of ugly and hard to read. Well, we can write a custom format to display our date time. Here's how. Here we'll create a custom format for our date time. We will need the current date time, local date time. We will name this datetime equals access the class of local datetime called the now method. Then we'll need to create a formatter object. Datetime formatter, we'll name this formatter, equals datetime formatter. I'm just going to copy it. Call the of pattern method, and then we're going to pass on a string. Let me move the cursor so you can see this. Within the string, we will write pattern letters. What is the pattern in which we would like to display our date and our time? If you go to the official Java documentation, there's an extensive list. Here's a few beginner-friendly ones. For the day, type 2 Ds, dash for the month, 2 capital M's, for the year, dash YYY, Y, 4 Ys. This will display the day, the month, and the year. I'm an American, so we display the month first, followed by the day. So I'm going to switch this around, but you can keep it as it originally was if you prefer. So that's how to display the date in that format. Month, day, year. Now for the time, you can do the following. For hours, do 2 capital H's, colon, minutes is 2 lowercase m's, colon, then for seconds, it's 2 lowercase s's. That is a good pattern. We will create a new string named newDateTime equals, take our current date time, it's an object, call the format method. We are going to pass in our formatter to format our date time to this pattern. Once we have our new date time, we're going to print it. Let's output our new date time, and it should be in that format. Yeah, that looks pretty good. December 17th, 2024, about 9 in the morning, 9:30, at least for me. Instead of getting the time and date right now, we can create a custom datetime object. Here's how. So we'll start with a local date. Local date, I'll name this object date, equals local date, we're accessing the class statically, we'll call the of method. Depending on the date you would like to create, we'll pass them in as arguments. Let's say I would like to pick Christmas of 2024. The first argument corresponds to the year. I will pick 2024. The next is for the month, 12 meaning December. Then the 25th of December. I'll type in 25. All right, just to test it, I'm going to output it. Let's print our date. The year is 2024, December 25th. You can also use datetime. Let's switch local date to local date time. We need a few more arguments. So let's say noon on Christmas Day. That would be 12. For the minutes, 0. For the seconds, 0. Then let's print this again. Let's output our date. Well, technically it should be date time, but that still makes sense. Here's our date time. December 25th, 2024, at noon, 12 p.m. You can also compare dates too. Let's copy the snippet of code, paste it, rename the first date as date 1, the second date as date 2. For the second date, let's set that to New Year's Day, 2025. The month will be January, the 1st of January. At midnight, that would be 0. Let's print date 1 and then date 2. So we have Christmas, December 25th, 2024, and New Year's Day, January 1st, 2025. All right, now to compare dates, we can use the following. We'll use an if statement. Let's check if date 1, call the isBefore method. Dates have a built-in isBefore method. Pass in date 2. Is date 1 before date 2? And that is true. Let's output date 1 plus a string of is earlier than plus date 2. Let's check that. Our first date, Christmas, is earlier than New Year's, our second date. Else if date 1 let's just copy this. Date1 is after date2, then we'll output something different. Date1 is later than date2. So let's change date1 to be January 2nd of 2025. The 2nd of January is later than New Year's Day, our second date. You can also check if they're equal. Let's add else if. Let me scroll down. Date 1 is equal to date 2. And then we'll say that they're equal. Date 1 is equal to date 2. Let's set these to be the same. New Year's Day at midnight. New Year's Day at midnight is equal to New Year's Day at midnight. This could be good for some sort of alarm clock, checking to see if two date times are equal. Alright everybody, so that is an introduction to working with dates and times using Java. Well, hello again friends. Today I gotta explain anonymous classes in Java. So what is an anonymous class? It's a class that doesn't have a name, meaning it cannot be reused. It's when you want to add custom behavior without having to create a new class, because it can be really inconvenient to create a new class just for one object, if that one object is different from the rest, in one way or another. They're often used for one-time uses, when utilizing features such as timer task, the runnable interface, or callbacks. These are more advanced Java topics. So let me demonstrate why an anonymous class would be useful. Let's begin with this example, where we create a dog class. File, new, Java class. We will create a class of dog. Let's say that in this dog class, there's a single method, a speak method. Void speak. All we'll do is output the following. The dog goes woof. And then let's create a dog object. Dog equals new dog. We'll take our dog object, have it use its speak method, which will output the dog goes woof. So what if there's a unique kind of dog? It's different from the rest. Let's say it's Scooby-Doo. Now Scooby-Doo, he doesn't speak dog, he speaks English. If I want Scooby-Doo to say something else, I'd have to override this method. So one option would be to create a new class. Again, this is me not using anonymous classes. You'll see their usefulness in just a moment. Let's create a new Java class. Let's create a talking dog class. I know it's kind of a weird example. So our talking dog class will extends the dog class, and then we'll override the speak method. Override void speak. Then we'll output the following. Scooby-Doo says, what's he usually say, Rutro or something? Rutro. I think that's how you spell it. But you get the idea. Going back to our main Java file, I can create a talking dog object. Talking dog equals new talking dog. That's a lot to type. And then I can have my talking dog use its speak method. Our dog goes woof, and Scooby-Doo, our talking dog, says rutro, like uh-oh. It is a lot of work to create a whole new class just for one unique object. Our talking dog of Scooby-Doo is the exception. So rather than creating an entirely new class just for this one object, just for Scooby-Doo, our talking dog, let's instead create an anonymous class. We'll take our talking dog class and delete it. Instead of creating a talking dog object, let's create another dog object, but it's going to have some unique features that set it apart from other dogs, such as the ability to speak English. Let's rename dog as dog1. We'll create another dog named dog2 equals new dog. Add a set of parentheses. Now to create an anonymous class, you're going to add a set of curly braces. Then make sure there's that semicolon at the end. Within the set of curly braces, you can define any unique features or override any methods. Dog2 is going to be different from all other dogs with its speak method. So let's override that method. at override void speak, and then we'll say Scooby-Doo says Ruh-roh. Dog 1 is going to speak, and dog 2. The dog goes woof. Scooby-Doo says Ruh-roh. So instead of creating an entirely new class just for one dog, Scooby-Doo, we can create a normal dog and just override one of the methods using an anonymous class. So those are anonymous classes. It's a class that doesn't have a name, and it cannot be reused. If you need to reuse a class, you're better off just creating a new class. It allows you to add custom behavior without having to create a new class, which is what we did with the speak method. Anonymous classes are often used with timer task, which we'll talk about in the next video, the runnable interface, and callbacks. So it is an important topic that you need to know, going forward at least. To create an anonymous class, after you construct an object, add a set of curly braces. Within that set of curly braces, you can define new behavior. And well, everybody, those are anonymous classes in Java. So yeah, I gotta talk about timers and timer tasks in Java. Timer is a class that schedules tasks at specific times, or periodically. Timer is useful for sending notifications, scheduled updates, or repetitive actions. When you need to schedule a task at a specific time, you can use the timer class. Now, timer task is the task that's going to execute when our timer says so. In order to use timer task, you're going to extend the timer task class, and then define your task. And we're going to be doing this by using anonymous classes, which we learned about in the last video. We'll begin by creating a timer. We need a timer to, well, keep track of the time. Let's say timer equals new timer. And then import these classes. I'm pretty sure you're used to importing these by now. We're going to select the timer from the utility package. Alright, we have our timer. Then we need a timer task. What are we going to do when the timer is up? Let's just say task. Timer task equals new timer task. Import the class. Alright, so here's the situation. With our timer class, we have to implement the run method. To override the run method, we could create a child class from the timer task class, but here's a better option. We're going to create an anonymous class. After the set of parentheses, we will add a set of curly braces, then add that semicolon to the end. Within this anonymous class, we can update or change the behavior of our timer task object. What we'll do is override the run method. Override. To overrun this method, this will be public void run. It's the run method. When we execute our task, what would we like to do? Let's output the following. Let's just say hello. So our task is to print hello. But we have to do it when our timer says so. So they work together. Let's say I would like to say hello after 3 seconds. To do that, we're going to take our timer, call the schedule method, and then there's 2 arguments we're going to pass in. Our task. What are we going to do? That's the first argument. The next argument is the delay. After how many milliseconds will we execute this task? I said 3 seconds, let's say 3,000 milliseconds then. After a delay of 3 seconds, 3,000 milliseconds, do your task that we're passing in. So after 3 seconds, we'll output hello. Or if this were 1,000 milliseconds, it would only take a second. Hello. You can also schedule at a fixed rate. Our timer can do things periodically. So let's repeat our task of saying hello. More than just once. So we have our delay. You know what? I'll set that to be 0. The next argument is for the period. What is the delay in milliseconds between repetitions? Let's say 1,000 milliseconds, so 1 second. Starting immediately, 0 milliseconds, print hello every 1,000 milliseconds, every second. Let's try it. hello, 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 hello. I think you get the idea. Or you could add a delay. That's the second argument. Let's say after a delay of 3,000 milliseconds, 3 seconds, repeat this line of code every 1,000 milliseconds, 1 second. So now there's going to be a delay of 3 seconds. Then we output hello every 1 second. Now, how do you cancel this timer once it's started? Well, you can use the cancel method. Where should we add that exactly? Well, we can add that within our task. We'll need some sort of stopping condition, kind of like a while loop. So let's say this. I would like to say hello 3 times. I'll create a local variable of count. I'll set that to be 3. IntelliJ wants me to make this final. You don't have to. I'll keep it as is. So again, we are within our anonymous class. We're declaring a variable to use within the context of our task. Within the run method, we'll output hello, decrement our count by 1, count minus minus. Then, using an if statement, this is how we're going to escape. If our count is less than 0, then let's say task complete. And then to cancel the timer, we will take our timer object called the cancel method. All right, let's try it. I'll set the delay to be 0 so it starts immediately. Every 1,000 milliseconds, print hello. Whoops, it looks like that's less than or equal to 0. I fixed it. All right, so starting immediately, the delay is 0. Every 1,000 milliseconds, print hello, but only do it 3 times. And then we cancel the timer to stop, because we don't want to say hello forever. And here it is. 1, 2, 3, task complete. All right, everybody, so that is timer and timer task. Timer is a class that schedules tasks at specific times or periodically. It's useful for sending notifications, scheduled updates, or other repetitive actions. Timer task is the task you're going to perform when the timer says so. In the next video, we're going to use timer and timer task to create a countdown timer. All right, everybody, so that is both timer and timer task in Java. Why, hello there, everybody. In this video, we're going to create a countdown timer program using Java. This is meant to serve as more of a mini project to get us used to working with timer tasks. Let's begin. We'll accept user input, but we're going to set that up near the end. It's going to be easier for us to understand this program at first if we set the countdown timer to be a raw number, like 10. To work with timer tasks, we'll need a timer to keep track of the time. Timer equals new timer. We'll be importing our classes as we go along. Be sure to do that. Import them from the Java utility package. Then we'll need a timer task. Timer task, I'll name this task for short, equals new timer task. Be sure to import this class. Now there's one issue though. With our timer task object, we have to override the run method. One option, although it's not the best, is to create a new class and then inherit from the timer task class. So this would be the parent class, and then we can override the run method. But since we don't plan on reusing that class, what we could do instead is use an anonymous class. After the set of parentheses, add a set of curly braces, then add that semicolon to the end. For a one-time use, we can override the run method of our timer task object, because we only plan on using it once, so we can write an anonymous class, rather than create a whole new class that we're only going to use once. So we will override the run method, public void run. When our timer executes our task, what would we like to do? Well, we're going to output a number, the number for our countdown timer. So within our anonymous class, let's create an integer variable of count. For the time being, let's set this to a low number like 5. IntelliJ wants us to make this variable final, but we'll be accepting user input momentarily, so you don't need to do that. My IDE of IntelliJ is recommending that. You can just ignore that. So let's say that our count is going to start at 5, and will decrement by 1, then display Happy New Year when count is 0. So why don't we do the following? Within our run method, we'll output our count variable. At first, it's going to be 5. Then we'll decrement count by 1, count minus minus. We'll need to escape the run method. Well, we can do that with an if statement. We will check if our count is less than 0. If it is, let's output Happy New Year. And then to stop our timer, we'll take our timer object, call the cancel method. Now we have to set up our timer. We will do that outside the timer task anonymous class. So right here is good. We will take our timer, call the schedule method. Schedule will take a task, our timer task, and execute it after a delay. Let's set the delay to be 0. Now this is only going to run once. There's a better method for this. Let me just demonstrate. So we get the number 5, and our program stops. So what we're going to use instead is schedule at fixed rate. The schedule at fixed rate method. But there's 3 arguments we have to pass in. First is the task, the delay, and then the period. We have our task, the delay is 0. What is the period in between executions? Let's set that to be 1000 milliseconds. Every 1 second, 1000 milliseconds, perform your task. And our task is to display our countdown, whatever the count currently is. Alright, let's test this. Again, we're setting our count to be 5 initially, but we'll be accepting user input momentarily. We start at 5, and we're going to count down to 0, then display Happy New Year. Alright, after 0, we display Happy New Year, and our program exits, because we canceled the timer. Now, if we don't cancel the timer, I'm just going to cut this momentarily. It's going to continue forever. We keep on displaying Happy New Year, and we're going into negative seconds. So that's why we need to cancel the timer, so that it stops. Alright, now we'll accept user input, because we want a user to type in the number to count down from, rather than us programmers just typing in a random number. So we will need a scanner. Scanner equals new scanner. Then pass in system.in, import this class, and then we'll need a prompt. Let's output the following. Enter number of seconds to count down from. I'll use print rather than print line. Let's create an integer variable of response. Set that equal to, use our scanner, call the next int method to get the next integer from the user. Then we will set our count variable equal to the response, whatever the user types in. So now the user can type in a number, and we can count down from that number, rather than just placing a random number here. Alright, let's test this. Enter number of seconds to count down from. Let's say 10. We're going to count down from 10. So we start at 10, and we're going to count down to 0. Zero, Happy New Year, and then the program exits. So you can type in any number. You could even set this to a higher number, like 60. But I'm not going to make you wait that long. Alright everybody, that is a countdown timer program that you can write as a mini project using Java. Hello there everybody. In this video, I gotta cover generics in Java. Generics, it's a concept. It's where you can write a class, interface, or method, and it's compatible with different data types. There's 2 things we need, a type parameter and a type argument. So with type parameters, it's a set of angle brackets with a letter inside, for example, t. Basically, this acts as a placeholder, and it gets replaced with the real type. Now on the other hand, type arguments, with various objects and data structures, you'll see a pair of angle brackets with a type inside, such as a string, but it really can be anything. It can be an integer, or a boolean, really anything. Type arguments specify the type. We send arguments to parameters. Really, our type parameter is just acting as a placeholder. Anything that uses this type parameter it doesn't know the data type that it's going to receive. It's set up to receive really anything, or a primitive using a wrapper class. Let me give you an example of where you already see generics being used. For example, array lists. To create an array list, we add a set of angle brackets after array list, and we have to specify the type. What is this array list going to store? For example, strings. We would write the data type of string. Let's say that this array list is named fruits. Fruits equals new array list, and then we need a set of angle brackets again, parentheses, semicolon. In modern Java, within the second set of angle brackets, you don't necessarily need to type the data type again. Java can infer that, so you can leave it empty. This is the diamond operator. We have an array list that can store strings. We have specified the type argument. And now we can store some strings within our array list. So let's take our array list of fruits, call the add method, and add a few names of fruits, such as an apple. Let's do 2 more. Apple, orange, banana. Currently, the way that we set up this array list, it's compatible with strings, because that's what we set the type argument to be. Now, if I set this to be integers, well, we can't store strings anymore, but we could store numbers. 1, 2, 3. That's fine. Let me change that back. Generally speaking, an array list data structure can store all sorts of different data types, but when we create one, we have to specify what we're storing. That's the type argument. It's because within the array list class, we have a type parameter set up, a set of angle brackets with a letter inside. In many cases, you'll see T meaning type, for type parameter. So let's actually take a look at our array list. I am going to locate array list, jump to source. Here's the class for our array list. There's a lot of advanced Java in here. Don't worry about that. But what I want you to pay attention to is the type parameter that comes after the array list class name. We have angle brackets and a letter inside. In this case, E, meaning element, because an array list has elements of data. By using this type parameter, our array list is set up to store elements of various types. We just have to specify what the type is going to be when we actually do store data. And in my example, we're using strings. But like I said before, we can change the data type of what we're storing. We just have to change the type argument. I'll store booleans. True, false, true. I don't know what that has to do with fruits, but I'm just trying to prove a point here. So now what we're going to do is actually use type parameters. So let's delete our array list. Using generics, you can write some logic within a class, interface, or method, and it's compatible with many different data types. So what we're going to do in this example is create a class of box. Class box. We'll be using a type parameter to store all sorts of different things within our box. We can store a string within our box, an integer, a double, a boolean, even more complex objects. So we will set up a type parameter with a set of angle brackets, then type T. T is a common convention, meaning type. Let's say that when we create a box object, our box is going to act as a container. We'll store a value inside. Our box is going to be a reusable class. We won't always know what the data type of what we're storing is going to be. So what we could do is set the data type to be T. Let's say that this variable is an item. We're storing an item within a box. With T, it does mean type, but I like to think of it as thing. We're storing a thing, an item, within our box. We don't know what this thing is going to be. But really, it means type, and that's not as fun. T, item. We don't know what the data type is. If it's always going to be a string, we could just set this to be a string. But what if somebody is storing an integer, an int? Or we can use the wrapper class of integer. We don't know what the type is going to be. Let's create a method where we will set our item. Let's say that this is public, void, it's not going to return anything, set item. We'll have one parameter. What's the data type of what we're receiving? Well, we don't know, so we're going to use our type parameter of T. T is the data type. It's generic. We will receive an item. Let's take this dot item and set it to be the item that we receive. we'll create a method to get our item. Public, now we're going to be returning an item. The data type is t, so the return type is also going to be t. We're returning a value of the t data type. We will create a method to get item. We will return this .item. We can put things in our box, and we can get things from our box. Alright, this class is done. Our box class is set up to be reusable. We can store all sorts of different things, so to say, within our box. We will attempt to create a box object. For now, let's say box equals new box. But there's one step that we're missing. We have a warning here. Raw use of parameterized class box. We need to set up a type argument. What are we going to be putting in our box? What's its data type? Our box class wants to know. So we will use a type argument. After the class of box, add a set of angle brackets, then type what we're going to store. So let's say we're going to store strings within our box. Values of the string data type. And then we do need the diamond operator after the second box. And we're good. We now have a box object. But it's set up to store strings. Let's add some items to our box. We've even created a few methods for this. Set item. Let's take our box, call set item, but we have to pass in a string. Let's add a banana to our box. And then we will get the banana from the box using the getItem method. And now I want to get the banana. Box.getItem. Here we go. We have our banana. We have successfully retrieved the banana from the box. Our box class is compatible with all sorts of different data types. This time, let's store an integer. We will use the wrapper class of integer, but we can no longer add a banana to the box because it's a string. I'll attempt to do so. String cannot be converted to integer. Unfortunately, bananas are not numbers, but I can add the number 3 to our box. We have the number 3 within our box. If I attempt to add a double, like 3.14, we get a warning. Incompatible types. Double cannot be converted to integer. So I would have to set the type argument to be double, to add doubles to our box. 3.14. Basically, with our box class, we're writing the logic of how a box works. You put something in, and you can take something out, and it's compatible with different data types. We just have to use a type argument when creating a box object. We have to let Java know what we're storing within it exactly. Alright, let me give you another example. Now with type parameters, you can have more than one type. We can have 2 or more different types. Usually the common convention is to use u after t. So we're going to create a new class. File, new, Java class. We will create a class of product. Here we're going to write the logic of how a product works. With a product, you have an item and you have a price. We will set up a type parameter. Let me zoom in. We'll have one type of t, and a common convention for the second type is u, because in the English alphabet, the letter u comes after t. If you had a third argument, that would be v by common convention. So we'll just stick with t and u. We will have a generic type of item and another generic type of price. We don't know if our item is going to be a string or a more complex object. Our price could be an integer, a floating point number, a double. We don't know, but that's why we're setting it up this way. Now we'll need a constructor. We will take our product, then set up some parameters. The data type of our item is t. T item. But if we're creating a product, we also need a price. The data type of our price is u. U price. This dot item equals the item that we receive. This dot price equals the price that we receive. Okay, let's do a test run. Let's go to our main Java file. Product equals new product. And again, we need those type arguments. So this time we actually need 2, because our class is set up to receive 2 type arguments, t and u. For our product, let's say that the first type is going to be a string, followed by a double. And then we need the diamond operator after the second product. Alright, now we have to pass in arguments to the class. Because we have a constructor, we have to pass in an item and its price. And with our type arguments, we set that up to be a string and a double. We have to pass in those types. For our product, let's say that it's an apple, and an apple is 50 cents. That's a double. Let's create 2 methods within our product class. We will create a method to get our item. Let's say public, we're returning an item. The data type is t, so we're going to return t. Get item. We will return this dot item. Then to return the price, let's say public u, because we're returning the price, it has a type of u, get price. Return this dot price. We have our product object. I'm going to take our product object, call the get item method. And this is going to return our apple. Or I could get the price. Get price. And that is 0.5. You can use string format, but that might be overkill for this lesson. Alright, let's create a second product. So we'll have product 1 and product 2. Now product 2 will use an integer instead of a double. And let's say that these are tickets, like movie tickets. Ticket, and the price will be 15 for $15. Let's take product 2, call the get item method. So we have our ticket, and we should have a price. Get price. The price of a movie ticket is $15. Alright everybody, so that is an introduction to generics. It's a concept where you can write a class, interface, or method that is compatible with different data types. Basically, we're writing the logic of how this class works, and it's compatible with all different types. You just have to set up a type parameter, and then pass in type arguments. And well everybody, that is an introduction to generics in Java. What's up everybody? So today I gotta explain hash maps in Java. Hash maps are a popular data structure. They store a pair of values, a key-value pair. You have a key and a value associated with that key. The keys have to be unique, but the values can be duplicated. Hash maps do not maintain any order, but they are very memory efficient. When creating a hash map, we have to set up type parameters. We have to specify what the data type of the key is and its value. Here's how to create a hash map. We will type hash map, let's say map for short, hash map equals new hash map. We'll need to import this class. It looks like we're missing something. Let's take a look. Raw use of parameterized class hash map. If we take a look at the hash map class, we have type parameter set up. There's 2 values. We learned about type parameters in the last video on generics. We can store any 2 types of values within a hash map. We have a key and a value represented by k and v. We have to send type arguments to the type parameters. When creating a hash map, we'll have to set up some type arguments. So after our hash map, we have to list the data type of what we're storing. These have to be reference data types. So let's say with our map, we're going to have products, an item, and a price. So for the item, that could be a string representation of our item. So for the price, we could do an integer, but I think a double would be better, because you can have dollars and cents. Then we also need to use the diamond operator after the second hash map. You don't need to state the data types again, even though you technically could. Java can actually infer what the data type is, so after the second hash map, add the diamond operator. And there we go. we have our hash map that we have named map. The way that we've set this up is that we've told the hash map class we're going to store a string as the key and a double as the value. So to put things in a hash map, we're going to take our map, call the put method. We're going to put something in the hash map. We've specified that we're storing a string, then a double. A string for the key and a double for the value. So let's say we have a store, and in our store we sell produce. We will have an apple, and its price will be 50 cents, 0.50. To put something in a hash map, you use the put method. We have to pass in 2 values as arguments. Alright, let's add a few more things. We'll have an orange. An orange will be 75 cents, let's say. Then a banana. Bananas are pretty cheap. They will be 25 cents. Alright, let's take a look at our hash map. I'm going to show you what happens if we output our map directly. System.out.println our map, our hash map. And here's what we have. We have all the key value pairs printed within our hash map. We have a string and a double. String, double. String, double. Now with hash maps, the keys have to be unique. For example, let's say I try and put another orange within here. We'll attempt to add another orange, and we'll see what happens exactly. Put another orange within our map, and let's say that the price is 1 million Venezuelan dollars. Yes, oranges are very expensive in Venezuela because of inflation. So here's what happens if we have duplicate keys. You actually overwrite the previous key value pair. Our orange is now worth 1 million Venezuelan dollars. So do keep that in mind. Hash maps cannot have duplicate keys. If you put another key value pair within a hash map and it already exists, you'll overwrite it. But that's also good if you want to change one of the key value pairs. Let's add one more key value pair. Let's say a coconut. Map.put. We will put a coconut within our hash map. Coconuts are a little more expensive. They'll be $1. Let's print our map to test it. There's our coconut. Then we can remove an element. To remove an element, take your map, call the remove method. Here you're going to pass in a key. Let's remove our apple. Then print our map. There, the apple is gone. We have orange, banana, coconut, but no apple. So I'm going to keep that in, but turn it into a comment. To get the value associated with the key, you can use the get method. So let me delete this println statement. We will take our map, call the get method. Let's get the value with this key. Give me the value where the key is apple, is what we're saying. That would be 0.5, meaning 50 cents. Or we can get our coconut. The value associated with this key is 1, meaning $1. Alright, you can also check to see if a key or a value exists. Here's how. We'll use the contains key method. Take our map, call the contains key method, and then pass in a key. Is there a key of banana? That returns a Boolean, in this case true. Is there a pineapple? There is not. So that returns false. You could use this within an if statement. Here's how. We will check if, let me zoom in, if our map, call the contains key method, and then pass in a key. Does our map contain any apples? Contains key apple. If that returns true, we'll output map.get, then we'll get our apple. This will give us the price. Else, if contains key is false, then we'll output something else. We'll output key not found. Alright, let's test this. So we do have an apple. we've set this up to return the price. But let's say we are looking for a pineapple, contains key pineapple. If we do find a pineapple, we will get the price. Currently, there's no pineapples within our map. Key not found. So that's how the contains key method would be useful. We also have the capability to check to see if a map contains a value. So we will take our map within a print line statement, call the contains value method, and then pass in a value. Is there anything that's $1? 1.00. This returns a Boolean, and that's true. Our key of coconut has a value of 1.00, $1. And you do have to pay attention to the data type too. If I were to pass in an integer, this does return false. You do have to keep that in mind too. That's how to check to see if a map contains a key and a value. You can return the size of a map using map.size. Map. Call the size method. Currently, there's 4 key value pairs within our map. This will return the number 4. To get the size of a map, call the size method. Alright, now the last thing that we're going to do, if we were to print our map, we're given this ugly formatting, where we have a set of curly braces, then all the key value pairs, comma separated. This time, using a for loop, we're going to cycle through all the key value pairs. We will create an enhanced for loop. What we're going to iterate through is every key, and these have a string data type, because that's the way that we set them up. The data type of each element is going to be a string, which we will name key, colon, think of it as in, for every key in. Now, what we have to do is get all the keys from our map. And there's actually a method for that. A beginner's friendly way to get all the keys from our map, what we can do is take our map, call the key set method. This will return all the keys within our map, and they're iterable, so we can use them within a for loop. For every key in our set of keys, what do we want to do? Let's do the following. Within a print line statement, let's print our key plus, we'll list each product and its price. Key plus, maybe I'll add a colon, space, then pick a unit of currency. I'll pick American dollars. For every key, we need to get its value. So we can use the get method, plus map.get, pass in our key. By using an enhanced for loop, we can customize the output of the key value pairs. And I think this looks a lot better. We have each product, each piece of fruit, and its price, laid out in this format. You could technically use printf if you want to display 2 digits after the decimal, but that might be a little too much for this lesson. I want to keep it as simple as possible. Alright everybody, so those are hash maps. It's a data structure that stores key value pairs. The keys have to be unique, but the values can be duplicated. We have to specify the type for the key and its value. And well everybody, those are hash maps in Java. Alright, let's do this thing everybody. Today we're talking about enums. Enums is short for enumerations. They're a special kind of class. They represent a fixed set of constants. By using enums, they improve code readability and are easy to maintain. One of the major benefits of enums is that they're more efficient with switches when comparing strings. So basically, an enum is a special kind of class where we declare constants. Here's a demonstration. We're going to create a new class. File, New, Java class. We're going to select enum. Enum is a special kind of class, sort of like how an interface is a special kind of class. We will create an enum of day. Public enum day. Within this Java class, we can declare some constants. What we're going to write is enum constants. A common convention for these constants is that all the letters are uppercase. So after the enum constant, we'll add a set of parentheses, then associate this constant with the value. So let's say that we're working with days of the week. Sunday will be the first day of the week. Sunday will have a value of 1. Let's do this with the other days of the week. Monday, parentheses, then a value. Monday will be the second day of the week. Then we'll just follow this pattern. End all these constants with a semicolon. Alright, we have our enum constants. They have values 1 through 7. We're receiving some warnings here. Expected 0 arguments but 1 found. What we need to do is create a constructor. A constructor for our day class. When we define these enum constants, we're automatically going to call the constructor for this enum class, and then pass in this value. Let's create a field of day number for days of the week. We'll make these values private. We'll use the private access modifier. We don't want the ability to change them. We'll make them final. These are integers, that's the data type. We'll name these values day number. When we define these enum constants, we're automatically going to call the constructor and then pass in this value to the constructor. For the parameters, we'll have int, then our field of day number. This dot day number equals the day number that we receive. If you would like, you can add a getter method to actually get the day number. We'll use the public access modifier. We're returning an integer. We'll define a method of getDayNumber. And we will return our field of this dot day number. Alright, and we have set up our enum class. Reading and understanding these enum constants is a lot easier than these numbers. If I was looking at the number 5, I would have trouble understanding that that means Thursday. Now, how do we work with these enum constants exactly? Here's how. Within our main Java file, we will create a day object by using this enum class. Let me delete this. Day, rather than saying new day, and then passing in a number like 1, there's a different approach. We will access the day class, dot, and then specify a constant, a day of the week. Let's say Sunday. Remember that this is all caps. Our day is an object. Let's output our day and see what it outputs. This will output Sunday, all caps. If you would rather get the day number, the value that's associated with this enum constant, then we can use that getter method. Day.getDayNumber. So we have Sunday and 1. Where this is really going to be helpful is when working with switches. Here's a demonstration. We will actually use an enhanced switch. What are we examining? We're examining our day object. If our day matches a case of Monday, now this isn't a string. If this were a string, we would enclose this within a set of quotes. But using enums within a switch is actually faster than using strings. If it's Monday, then we'll output the following. We'll use an arrow, because this is an enhanced switch. Then we'll output, it is a weekday. Then if we have a case of Tuesday, let me just copy this. Tuesday will also output, it is a weekday. You can actually combine these cases together too. You just have to comma separate them. So case Monday, comma Tuesday, do this. Then let's do this with the other days of the week. Just for readability, I'll put these on new lines, each of these cases. So we have Wednesday, Thursday, Friday. These are all the weekdays, Monday through Friday. Then if we have case Saturday, then it's the weekend. Case Saturday, we'll do the following. Output, it is the weekend. And we will also add a case for Sunday. So currently our day is Sunday. That will output, it is the weekend. If it were, let's say, Wednesday, then instead we output, it is a weekday. If we were comparing strings, all these cases would be enclosed within a set of double quotes, kind of like this. But we don't need to do that. It's actually more efficient to use enums. For some practice, what we'll do this time is accept some user input. We'll need a scanner. Scanner equals new scanner. Pass in system.in. import this class. Be sure to close your scanner because I tend to forget. Scanner.close. Then we'll need a prompt. We will output the following. We'll use print rather than print line. Enter a day of the week. We will create a string variable, let's say response, equals, use our scanner, call the next line method. All these constants are uppercase. We'll method chain the to uppercase method to make our user input uppercase. When creating a day object, by using the enum class, we will use our response. We will use the value of method, and then pass in our response. Now we should be able to type in a day. Enter a day of the week. I will type Monday. It is a weekday. Let's run this again. I will type Sunday. It is the weekend. What if we type in a day that doesn't exist, like pizza day? Well, we get an exception, an illegal argument exception. We can catch that exception using a try and catch block. Any dangerous code we're going to enclose within a try block. We will try this dangerous code. And catch any exceptions. We will catch that illegal argument exception, which we will name E. If the user input doesn't match one of these enums, then we'll output the following. Please enter a valid day. Let's try it again. Enter a day of the week. Let's try Tuesday. It is a weekday. Saturday. It is the weekend. Pizza day. Please enter a valid day. Pizza day is not one of our enums, but if we wanted to change it so it was, we can add that. Pizza day will be the 8th day of the week. At least it should be. We'll need a case for pizza day. Pizza day will also be part of the weekend. That just makes sense to me. Alright, let's try that again. Enter a day of the week. Pizza day. It is the weekend. Alright. Alright, everybody, so those are enums, meaning enumerations. They're a special kind of class, kind of like how interfaces are a special kind of class. They represent a fixed set of constants. They improve code readability and reliability, and where they're really useful is when working with switches, because when working with switches, using enums is faster than strings. If I wasn't using enum constants, I could use integers, which are also efficient. But as a programmer, this is way less readable for me. At first glance, I would have no idea what these numbers are. But if they're enum constants, this is perfectly readable to me. These are days of the week. That makes sense. And well, everybody, those are enums in Java. What's going on, people? In this video, I'm going to teach you all about threading in Java. Threading allows a program to run multiple tasks simultaneously. It helps to improve performance with time-consuming operations, such as file input-output, network communications, or any other background tasks. Any code that is considered time-consuming, we can have it run on a different thread, so that it doesn't inconvenience our main program. There's two options to creating a thread. Option 1 is to extend the thread class. This is the simpler option, but it's limited. Option 2 is to implement the runnable interface. This option tends to be better, because by extending the thread class, we're limited to single inheritance, but by implementing the runnable interface, that's one way around that. In this demonstration, I'm going to show you option 2. It's actually not that more difficult than option 1, and it gives you more possibilities. I'll give you a demonstration of why threading is useful. In this program we're about to write, let's say it's a game, or a quiz or something. A user has 10 seconds to respond, and if they don't, time's up. Currently we have one thread. We're running our program on what is known as the main thread. Without using any other threads besides the main thread, I might write my program something like this. We'll start with the scanner because we'll be accepting user input. Scanner equals new scanner. pass in system.in, import this class, and close your scanner when you're done with it. Scanner.close. We're going to let a user know that they have, let's say, 5 seconds to enter their name. You have 5 seconds to enter your name. We will create a prompt. Enter your name. I'll use print rather than print line. We will assign a string variable of name, use our scanner, call the next line method. And then once we have the name, we'll output hello plus the user's name. Hello plus name. So let's do a test run. Currently we don't have a timer set up. You have 5 seconds to enter your name. I can type in a name, hit enter. We display hello the name, and then the program exits. Processed finished with exit code 0. If we were creating some sort of timer, we could do the following. To make this simple, we could use a for loop. The for loop is going to cycle 5 times. We will have an index of I. Int I equals 1. That's where we'll start. We'll continue as long as I is less than or equal to 5. And then increment I by 1. During each cycle of the for loop, to mimic waiting for 1 second, you can access the thread class, call the sleep method, pass in 1000 milliseconds. When you use thread, that refers to the current thread that we're working with, in this case, the main thread, which is what our main program runs on. But since our thread might be interrupted, we do need a try and catch block, because this is considered dangerous code. We will try this code, where we will have our main Java thread sleep for 1000 milliseconds. And we will catch the following exception, an interrupted exception. So within our catch block, we will catch any interrupted exceptions, which we will name E. If our thread is interrupted, we will say, thread was interrupted. In our imaginary timer, we'll need an exit condition. Let's say if our index of I is equal to 5, that means time's up. So we'll output time's up. I'm going to show you why this won't work the way that we think. We have 5 seconds to enter our name, but there's no prompt or anything. Then we get the message time's up, and only after that loop is complete are we allowed to enter our name. And then we can type in our name, we get the output of hello our name, and then the program exits. So the problem that we're running into is that all of this code is running on our main thread. We have 5 seconds to enter our name, but we can't reach that code until the 5 seconds are up, because our main thread is waiting for this loop to finish. So what we could do is create a separate thread where we're counting to 5, and our main thread is going to be in charge of accepting our user input. So here's how to create another thread. We're going to extend the runnable interface to create a runnable object. Let's go to File, New, Java class. This will be a class. We'll name this class myRunnable, or something unique that's relevant to what you're creating. myRunnable is going to implements, because we're working with interfaces, the runnable interface. If you implement an interface, it's kind of like you're signing a contract. We have to override any required methods. We need to override the run method. We need the @override annotation. Then we will override the run method, public void run. Within this run method, we're going to add any code we want to run in the background on a separate thread. Going back to our main Java file, we're going to cut this loop and then paste it within the run method. When we call this run method, we'll have this countdown timer running in the background on a separate thread. Any code you want to run on a separate thread, place within the run method. Alright, going back to our main Java file, we'll tell the user they have 5 seconds to enter their name. We have our class of myRunnable. We will create a myRunnable object, or whatever it is that you named this class. Let's say myRunnable will be the name of the object, equals new myRunnable. We will take this runnable object, pass it into the constructor of the thread class. Here's where we're going to create a new thread. Thread equals new thread. Pass in your runnable object as an argument to the thread constructor. Now we just need our thread to start. You'll take your thread, call the start method, and this should work. Let's try it. You have 5 seconds to enter your name, and we get that prompt of enter your name, but I'm not going to type in anything. We get the message time's up because we ran out of time. Let's try it again. I'll type in my name this time. There we go. We get our output, hello bro. Then we get the message time is up. Both these threads are running at the same time. The code within our run method is running on a separate thread. It's running in the background while our main program is running. So that's why threads are useful. So let me extend this time. Let's say 10 seconds. If I is equal to 10, just to give us some more time. You have 10 seconds to enter your name. Now, check this out. You have 10 seconds to enter your name. I'll type in my name immediately. We get the output, hello, whatever your name is. But the program is still running because that second thread is still running in the background. Our program doesn't exit until all threads are done. If your main thread is done, you can end all other threads, but you'll want to set those threads to be what is known as daemon threads. A daemon thread will end when the main thread is over. We will take our thread, call the setDaemon method, pass in true. This thread is going to end as soon as our main thread is finished. Let's try it again. You have 10 seconds to enter your name. I'll type in my name. We get our output, and then our program exits without saying time is up. Processed finished with exit code 0. That's because we set our second thread to be a daemon thread. It ends when the main thread is over. Now, on the other hand, let's say that we wait for time to be up. We wait the full 10 seconds. Time's up. Our program isn't over yet. We're still waiting for user input, and I can still type it in. Hello, bro. Processed finished with exit code 0. Optionally, what you could do to get your program to exit, go to your runnable class, wherever you would like your program to exit. When seconds equals 10, that's where I would like to exit. To exit the program prematurely, I can access system, call the exit method, pass in an exit code of 0. That will end the program. Alright, let's try this again. You have 10 seconds to enter your name. I'm not going to type in anything. I'm just going to wait for the full 10 seconds. Time's up, and then our program exits. But that's what we want, though. The way that we've set up this program is that we want this program to exit either when we finish typing in our name, or we run out of time. Alright everybody, so that is an introduction to threading. It allows a program to run multiple tasks simultaneously. It helps to improve performance with time-consuming operations. It's useful with file input and output operations, network communications, or any other background tasks. And well everybody, that is an introduction to threading in Java. Yo, we finally made it to multi-threading in Java. Multi-threading enables a program to run multiple threads concurrently at the same time. As we've talked about in the previous lesson, a thread is a set of instructions and they run independently from other threads. Multi-threading is useful for background tasks or other time-consuming operations. In the prior lesson, we've learned that there's two ways to create threads. We can either extend the thread class or implement the runnable interface. The second option is better in most cases because we're not limited by single inheritance. Here's how we can get started multi-threading. We're going to create a new class. File, new, Java class. We'll call this class myRunnable. myRunnable will implement the runnable interface. If we're implementing an interface, it's kind of like we're signing a contract. We have to override any required methods. We have to override the run method. Public void run. Whatever's within the run method, this is the code that's going to perform when this thread is up and running. So what would we like to do? Just for a beginner's example, let's count to 5 using a for loop. We'll write a for loop. We will create an index of I. I'll set that equal to be 1 right away. We'll continue as long as I is less than or equal to 5, because we're counting to 5. Then increment I by 1. During each cycle of this for loop, I would like this thread to wait for 1 second before printing whatever I is, whatever the current count is, if we're counting. We will access the thread class, call the sleep method. Pass in 1000 milliseconds to sleep for a second. We will need to surround this method with try and catch blocks. We'll catch any interrupted exceptions. But let's output the following. We'll say thread was interrupted. After our thread sleeps for 1 second, let's display the current count. I'll just say I, just to keep it simple. Let's go back to our main Java file. We'll need to create a runnable object. MyRunnable. Let's say MyRunnable equals new MyRunnable. We have to pass in this runnable object to a thread object. Let's say thread equals new thread. We will pass in our runnable object. To get this thread to start, we have to call the start method of our thread, thread.startMethod. And this should work. We'll test it. 1, 2, 3, 4, 5. And then we exit the program. Another shortcut you can do too, instead of creating a named runnable object, we can pass in an anonymous runnable object to the thread constructor. So let's copy this section, delete this line of code, and then pass in a new runnable object. This will work too, and it's a lot more concise. Now, we won't have just one thread, we'll have 2. So let's rename thread as thread1, copy this line of code, paste it, rename the second thread as thread2, thread1.start, and thread2.start. So now we'll have 2 threads running at the same time. They're running concurrently. So they both say 1, 2, 3, 4, 5. We have successfully multi-threaded. You could differentiate these by getting their name. Here's an example. To get each thread's name, we're going to access the thread class, call the current thread method, and then method chain the get name method. Then I'll add a space plus our counter of I, just so we can see each thread by its name, and what it's counting exactly. Okay, let's try this again. We have thread 1 and thread 0. Now, they won't always be in the same order. They're running independently. Thread 0, that's our thread 1. Java's thread 1 is our thread 2. Okay, here's an exercise. We're going to have thread 1 say ping, and thread 2 say pong, like we're playing a game of ping pong. We'll modify the myRunnable class. We'll need some text. A text variable. We'll say private final, we don't want it to change, string text. Then we'll need a constructor to assign it. MyRunnable will have one parameter, a string of text. We will assign this.text equals the text we receive. Instead of printing our counter, we'll print our text. Alright, and that's all we need. Going back to our main Java file, we have to pass in some text when we construct a runnable object. For the first thread, we'll say ping. For the second thread, we'll say pong. So here's what we have currently. Pong, ping. And then we exit the program. Before we start the threads, let's say game start. There's one more thing I want to show you. Game start. After we start the threads, let's try and say game over. Game over. Here's what happens. Game start, game over. And our 2 threads are still running. Then we finish. So the problem here is that in our main thread, it doesn't wait for thread 1 and thread 2 to finish. Our main thread ends immediately. We can have our main thread wait for these threads to finish by calling the join method of each thread. Our main thread will wait for these 2 threads to finish. After these 2 threads start, we'll use each join method. Thread1.join and thread2.join. And we do have to surround these with try and catch blocks. Try thread1.join and thread2.join. If our main thread is interrupted, we'll output main thread was interrupted. Okay, this should work now. Before we display game over, we're going to wait for our 2 threads to finish. Here's what we got. Game start, and we display ping pong. And we'll do that 5 times, and then display game over. Alright everybody, that is an introduction to multithreading. It enables a program to run multiple threads concurrently. A thread is a set of instructions that run independently. Multithreading is useful for background tasks or other time-consuming operations. And well everybody, that is an introduction to multithreading in Java. Hey everybody, in this video we're going to create a working alarm clock that plays music using Java. Alright, let's get started everybody. This alarm clock is going to serve as a final project for us. We'll combine a lot of concepts that we've learned throughout the series. When starting a new project, a good first step is to declare all your variables, or other objects that you'll need throughout this program. We'll begin with the scanner because we'll be accepting user input. A user is going to enter in a time. Scanner equals new scanner. Pass in system.in. And we'll be importing classes as we go along. At the end of this program, we're going to close our scanner, but we'll actually move it later on, because our alarm clock class is actually going to be using it. More on that later. We have our scanner, and currently, we're closing it. A user is going to use the scanner, and enter in hours, minutes, and seconds to set the alarm. When the user types in a string representation of a time, we need to parse it into a local time object, but we'll need a formatter object. We will create a date-time formatter object. You'll need to import this class too. We'll name this object formatter equals, we will access the class of datetime formatter, call the of pattern method. Within this method, we have to pass in a pattern that represents the time. For hours, minutes, and seconds, within a string, we will pass in 2 capital H's for hours, colon, 2 lowercase m's for minutes, colon, 2 lowercase s's for seconds. When a user types in a string representation of a time using our scanner, we'll use this formatter object when we parse it into a time object. Then we will create a local time object, which we will name alarm time. We'll instantiate that later. Import this class. Now we'll need a user to enter in the time. We'll create a prompt. Enter an alarm time. We'll give them a prompt for this format. Hours, minutes, seconds. Let me switch this to print, because I like it on the same line. Let's create a string variable of, let's name this input time equals, use our scanner, call the next line method to get a line of text from the user. Alright, now here's where we're going to parse our string, our input time, and assign it to our alarm time object. So we have to convert it, we have to parse it. We will assign our alarm time object, set it equal to, access the class of local time, and there is a parse method. we have to pass in two arguments. The first is a string representation of our time, and our formatter object that we have previously declared and instantiated. Then we'll output the following message. Alarm set for plus our alarm time. We can output it directly. Let's do a test run. Let's say I set my alarm for 7:30. This is going to be in military time. Alarm set for 7:30. What if we type in a time that doesn't make sense? Like the word pizza. Well, we encounter an exception, a date-time parse exception. We can use exception handling to catch this exception. I'm just going to copy it, and then paste it later. This portion is considered dangerous code. We can put that within a try block. Try this dangerous code. Catch any of the following exceptions. We will catch that date-time parse exception, which we will name E. Import this class. Okay, then take all of this previous code, stick it within our try block. We will try this code and catch this exception if it pops up. We'll output the following. Let's say invalid format. Please use hours, minutes, seconds. Let me change that to use. I've already used pizza. Let's go with taco for the alarm time. Invalid format. Please use hours, minutes, seconds. Let's try 8 o'clock. Alarm set for 8 o'clock. Alright, good. We know that that works. Why don't we prompt the user to enter in the time again if it is an invalid format? We can use a while loop. While some condition is true, continue to do the following. Let's cut our code, our try and catch blocks, stick it within the while loop. What's our condition? While our alarm time is empty. There's actually a value that you can assign an object, and that is null. Null has no value. Within our while loop, we'll continue this while loop while our alarm time is equal to a value of null. So if I were to just hit enter, we get an invalid format. Please use hours, minutes, seconds. And it won't let me continue until I enter in a valid time. So I will set this to be 9 o'clock. And then our alarm is set for 9 o'clock. The first section of this project is complete. We have successfully set an alarm time. Our alarm time is a local time object. The next part is to create an alarm clock class to create alarm clock objects. We're going to create an alarm clock class. File, new, Java class. We will name this class alarm clock. We're going to have our alarm clock run on a separate thread. To do that, we can implement the runnable interface. So we can do some threading. But if we implement the runnable interface, it's kind of like we're signing a contract. We have to override the run method, public void run. When this alarm clock is running on a separate thread, it's going to execute any code within the run method, but we're going to fill that in later. Currently, our alarm clock needs one thing. It needs an alarm time, which we will send it from the main Java file. Let's set that up as a field. With our alarm time, I'm going to make it private. I only want the alarm clock class to be able to change it. I will also make it final. It's unchangeable. The data type, it's an object. It's a local time object, which we will name alarm time. And then we do need to import this class too. Alright, then we need a constructor. We will take our alarm clock. We need one parameter currently. A local time of alarm time. We will assign this dot alarm time equals the alarm time that we receive. Alright, that's good. Okay, let's go back to our main Java file. Before we close our scanner, we're going to create an alarm clock object. Alarm clock is the class. We will name this object alarm clock equals new alarm clock. But the way that we set up this class is that we have to pass in an alarm time, a local time object. We have our alarm time. We've already verified it using this while loop. It should be a valid format. We will pass in our local time of alarm time to the alarm clock in order to construct it. Since our alarm clock is going to be running on a separate thread, we'll have to create a new thread. Thread, let's name this alarm thread, equals a new thread. And then we'll pass in our alarm clock. We can do this because our alarm clock, it implements the runnable interface. So our alarm clock is going to run on a different thread than the main thread. To start a thread, you will take your thread, in this case alarm thread, call the start method. So once we start our alarm thread, it's going to execute the run method. Alright, so for testing purposes, let's get the time right now. To get the time right now, we will create a local time object. Let's just call it now. What's the time right now? Equals access the class of local time, call the now method. I will display the time right now, just for testing purposes. I want to be sure that our alarm clock class is working. So we have to enter in a valid alarm time. I'll just set it to be 8 a.m. Alarm is set, and here's the current time right now, at least for me. I'm filming this video at 7:26 in the morning. It is going to be in military time. And then we have a bunch of milliseconds after. We know that we're successfully calling the run method. So we have the time right now. We're going to compare times. Is the time right now before our alarm time? If it is, we'll continue sleeping. We'll have our thread sleep. We can delete this print statement. I was just testing it. We need to check if the time right now is before the alarm time. If it is, we'll continue waiting. We can do this with the while loop. Take our time right now, call the isBefore method. We can compare local times. Is the time right now before our alarm time? If it is, we're going to sleep for 1 second. Access the thread class, sleep for 1000 milliseconds. Alright, we do need to surround this with a try and catch block. Let's do that. Try and sleep for 1000 milliseconds. If this thread is interrupted, we'll output the following. Thread was interrupted. This is if we encounter an interrupted exception. We're checking the time right now. Is it before our alarm time? If it is, let's output the time currently. I'm going to condense some of this code. Outside of our while loop, we're already creating an object of now. So why don't we do this? Let's cut this line and do the following. Access the class of local time, call the now method, and then method chain the isBefore method. Basically, every second, we're going to get the time right now and compare it to our alarm time. Is the time right now before our alarm time? If this while loop is running, we'll output the time. So we'll output local time, call the now method. Let's do a test run. Enter an alarm time. I'll just say 8 a.m. to keep it simple. Alarm set for 8 a.m. And here's the current time. It updates every 1 second, approximately every 1 second. Now let's do some formatting, because I don't like all these milliseconds afterwards. Here's what we could do. We could create an integer variable of hours, set it equal to, access the class of local time, call the now method, then method chain the getHour method to return the number of hours. Then we're going to do this with minutes. Int minutes get minute. int seconds get second. Okay, I'm going to show you what happens if I print hours plus a colon plus minutes plus a colon again plus seconds. Here's what we have currently. I will set this to be 8 a.m. Alarm set for 8 a.m. So this looks pretty good, but I would like some leading zeros. We could do that with printf. So let's switch this around. Printf. For printf, we'll add some placeholders, which we can use with a %sign. To display two leading zeros, we can use 0, 2. If we're going to insert an integer, we have to use d for decimal. So let's do this 3 times. 0 to d, %0 to d. We are inserting hours, minutes, and seconds. Let's try it again. I will set the time to be 8 a.m. Oh, and then I'm forgetting the colons and a new line character. So let's insert some colons and then add a new line character to the end because I forgot to do that. That's much better. And we have that leading 0 if one of these values is 1 digit. That looks pretty good. Now what we'll do, rather than updating the time and placing it on a new line every 1000 milliseconds, we're going to edit it in place. Here's how. With our printf statement, we're going to insert \r. This is for carriage return. It'll move the cursor back to the beginning, and then we'll get rid of the new line character. It should look something like this now. Our time is going to update in place rather than take up a new line for each time it updates. I think this looks a lot better. Alright, so we're going to condense some of these steps. Instead of accessing the local time class 3 separate times, let's just do it once. We'll create a local time object named now equals access the class of local time. Call the now method. When we assign hours, we will access our object of now. Now is our local time. Now.getHour. For minutes, now.getMinute. And seconds, now.getSecond. And then we'll insert them using our printf statement. Or even instead of assigning variables, we could just call now.getHour, now.getMinute, and now.getSecond. And we can delete these variables because we don't need them. Just for readability, I'll place these on a new line. And I'm just going to line them up. Alright, this should work too. Let's make sure. Yes, it does. You can keep this code the way it was before, but I like it a little more concise. Alright, our while loop is done. So, once we escape the while loop, that means the local time is our alarm time, or past our alarm time. So, for testing purposes, let's output the following. Let's just say alarm noises. We haven't added any audio yet. For my alarm time, I'm just going to set it to be 1 minute past what it is currently. In this case, 7:44. But pick a different time depending on what time it is for you currently. So I just need to wait for 20 seconds. Alright, once we reach our alarm time, or it's past our alarm time, we display alarm noises, and then exit the program. I'm going to add a new line character, just before we display alarm noises. For our alarm, we'll be playing some music later. Just for now, we're going to play a single beep, just to be sure that everything is working. Basically, to have Java make a beep noise, you can do the following. Access the class of toolkit, call the get default toolkit method, call the beep method, and then we do need to import this class. Once we escape the while loop, we will display alarm noises and make a beep sound, a single beep. I will set my alarm to be 7:47. I'll have to come back in 1 minute. There we go. We display our text of alarm noises, and hopefully you heard that beep. So we know that our alarm clock is working. To make a more sophisticated version, we're going to play an audio file. I have an audio file here. It's a WAV file. The following code isn't going to be compatible with MP3s. If you do have an MP3 file, you can always use an online MP3 to WAV converter. That's what I did. To make this convenient for me, I'm going to place this WAV file within my project folder. Here's my WAV file. Going back to our main Java file, I will create a string variable of file path. String file path equals, here I can list a relative file path or an absolute file path. This WAV file is within my project folder. I just need to list the file name. So I'm going to copy path, file name, and paste it within that string. With our alarm clock, we're going to send it our file path. We'll send it as the second argument, along with the alarm time. But we have to set up the constructor so that we can accept it. With our alarm clock class, we will create a private final string of file path. Then we'll have to set up the parameters. We are also accepting a string of file path, the location to that file, to play the audio. This dot file path equals the file path that we receive. With playing audio, there's a lot of code we have to write. I'll dedicate an entire method just to playing audio. Let's make this a private method so only our alarm clock can access it. It's not going to return anything, the return type is void. Let's name this method play sound. Once we reach the end, we will call the play sound method. But we're going to pass in our file path. So we need a parameter setup of string file path. And now we are within the play sound method. To play a WAV file, we're going to create a file object named audio file equals a new file, and then pass in our file path. Import this class. We'll be doing a lot of importing as we go along. Then we need to create an audio input stream. Audio input stream. We'll name this audio stream equals access the class of audio system, call the get audio input stream method. Yes, that's a lot to type. Then we will pass in our audio file. Import this class. Import the class for audio system 2. There's a lot of different exceptions that we'll need to catch, such as if our audio file is unsupported, like it's an MP3 file. We'll need some try and catch blocks. Try this code, catch any exceptions. Here's one we'll start with. We will catch any unsupported audio file exceptions, which we will name E. Import this class. If we encounter this exception, we'll output the following. Audio file format is not supported. If the audio is unavailable for some reason, let's say another resource is accessing it, we can catch that too. That exception is a line unavailable exception. Line unavailable exception of E. Let's say something like audio is unavailable. Import the class. Then as a safety net, we will catch any I/O exceptions, input-output exceptions. I/O exception E. Here we'll just say error reading audio file. It is good to catch specific kinds of exceptions first, which we are doing. This just acts as a safety net. So with modern Java, you can try with resources. You'll automatically close those resources when you're done with them. When we create our audio input stream, let's cut all this code and paste it within the try with resources block, then delete that semicolon. So we have our audio stream. We need to create a clip object. A clip acts as a player that plays an audio stream. Within the try block, we will create a clip object. Clip equals access the class of audio system, call the getClip method to create a clip object. Import this class. Then we will use our clip and open our audio stream object. To get the clip to play, we will call the start method of our clip. Clip.start method. One issue we're probably going to run into is that once we start playing the clip, the program is going to end immediately, so we might not even hear it. So temporarily, I'm just going to sleep for a couple seconds. Let's just sleep for 5 seconds. And then I do need to add a catch clause for any interrupted exceptions. We'll be deleting this, don't worry. I just want to be sure that it works. I'm going to set it for 8:02. I got about 40 seconds. We played our music for 5 seconds, and then we exit the program. What I would like to do instead is that we stop the alarm if we hit enter. Here's how we can set that up. We can delete this method where we sleep for 5 seconds. Instead, we'll wait for a user to hit enter. And delete that catch statement too. We're going to be using a scanner. Within a big project, different parts of your project may require different scanners, but I like to just reuse the same one. The problem with having multiple scanners is if they use system.in and one scanner closes it, it's going to close system.in for all of them. So rather than close the scanner at the end of our main Java file, we're going to do that within the alarm clock class, when everything is all done. So we'll do that at the end of the try block. However, our alarm clock class has no idea what the scanner is. We're going to send it as an argument to the alarm clock class. So we'll need to set that up. We will pass in our scanner and reuse it within the alarm clock class. Within the alarm clock class, we will create a private final scanner object, which we will name scanner. Import this class. Set up the parameters. We will receive a scanner object that we can use throughout the alarm clock class. This.scanner equals the scanner that we receive. Alright, and now we have access to that same scanner, the same one that we have instantiated at the beginning of our program. And remember, we are not closing it at the end of the main Java file anymore. Once our alarm is playing, we will wait for some user input. Let's create a prompt. We'll say, press enter to stop the alarm. I'm going to use print. We will use our scanner, called the next line method. Our music is going to continue playing until we hit enter. Once the user hits enter, we are going to take our clip and call the stop method. Then close the scanner when we're done with it. And that should be everything. Let's run this one last time. I will set my alarm to be 8:07. To get our alarm to stop, we just have to press enter. And the alarm stops, and we exit the program. Alright everybody, that is a working alarm clock that you can write using Java.